να το στείλουμε, να δει και το τηλέφωνο. Και βέβαια θα πάμε στα 10 και στα 15 λεπτά και σε μία ώρα να αρχίσει. Λες κάποιοι το ακούσαν ως είναι οι υπόλοιποι. Ωραία, δεν το θυμάμαι. Κύριε, να ξεκινήσουμε. Αν στέλνει, εμείς είμαστε. Από σας πρέπει να βγάλετε το τεχνικό τμήμα και εμείς και το τρίμα. Αν θέλετε να περάσετε στην πρώτη παρουσίαση, να πω κάποια πραγματάκια. Καλημέρα σας. Θα ήθελα να ευχαριστήσω τους παρευρισκόμενους, καθώς επίσης και τους ομιλητές, οι οποίοι θα στελεχώσουν και αυτή τη χρονιά, αυτή την ημερίδα, η οποία έχει σαν αντικείμενο την ενασχόληση με κάποια σύγχρονα ερευνητικά προγράμματα, πρωτίστως ευρωπαϊκά, χρηματοδοτούμενα από την Ευρωπαϊκή Επιτροπή, με στόχο τη δημιουργία μιας μελλοντικής, καινοτόμου και ανταγωνιστικής αγοράς των τηλεπικοινωνιών και του ευρύτερου τομέα των καθετοποιημένων αγορών. Χάριν της συντομίας του χρόνου δεν θα ήθελα να προλογίσω, θα έχω την ευκαιρία ούτως ή άλλως είτε εγώ είτε οι συνεργάτες μου να το κάνουμε στα 9 διαφορετικά session που έχουμε ουσιαστικά διαμορφώσει. Θα ξεκινήσουμε με την πρώτη ενότητα, με την πρώτη σύνοδο, η οποία αφορά τα έξυπνα ενεργειακά πνεύματα, τα smart grids, και είναι αφιερωμένη σε ένα τρέχον ερευνητικό έργο, το smart grid. Θα δούμε τις διαστάσεις αυτού του προγράμματος στις ομιλίες που θα ακολουθήσουν. Εδώ θα κάνω μια παρέμβαση, επειδή αρκετοί από τους καλεσμένους μας έρχονται από άλλα κράτη-μέλη της Ευρωπαϊκής Ένωσης και επειδή οι συγκεκριμένες δραστηριότητες εμπίπτουν στο πεδίο διάχυσης αποτελεσμάτων που ζητά συμβολιακά η Ευρωπαϊκή Επιτροπή, για να έχουμε μεγαλύτερη απήχηση, οι παρουσιάσεις, οι περισσότερες, αν όχι όλες, θα γίνουν στα αγγλικά, όπου βεβαίως, για τους λόγους που σας ανέφερα, πρώτα χάριν εκδήλωσης συνδρομής προς τους λοιπούς ξένους ομιλητές και κατά δεύτερο λόγο για τους αποκλειστικούς σκοπούς που ορίζει το συμβόλαιο του προγράμματος. Όπου βεβαίως χρειάζεται θα γίνει παρέμβαση διαδραστική στο τέλος κάθε ενότητας στα ελληνικά. Περνάω λοιπόν αυτό το κατόφλι και συνεχίζουμε την παρουσίαση στα αγγλικά. So, good morning again, ladies and gentlemen. The actual presentation will be about the Smart 5 Grid project, which is a very important initiative in the scope of the actual European policy. We have a briefing here. We can see how the project is structured. We have 24 partners from 7 European member states. Just an overview of the consortium. What has to be kept in mind is the fact that we have a variety of market actors, including telecom operators, digital and transmission system operators, technology companies, universities, and of course a large amount of SMEs that will promote, according to the European policy, innovative solutions for the market. Just some briefing about the actual state of the art in the energy sector. Energy is one of the largest machines in the world. Actually, electricity is the source of making everything real. In this scope, we have what we call as smart grid, which practically combine traditional grids with communication and information technologies and create new opportunities for activities. This is the area where fast deployment of 5G comes, especially involving vertical partners. So this is expected to have impact and opportunities for growth in the market sector. Continuing our discussion, we identify that smart grid is an important asset. It needs to be connected to modern ICT technologies because the challenge is to have a lot of energy metering and measuring devices through a communication network so that to collect the information and make smarter the grid infrastructure. And here comes the innovation from 5G. So far, this was not an area for the telecom or the ICT providers because in the communication infrastructure, for various reasons, they had some sort of limited involvement. However, the situation changes dramatically with fast progress. And so the main challenge here is to include 5G generation of communications in order to have larger bandwidth, end-to-end latency, high reliability, and of course the opportunity of connecting a mass number of devices. So here comes the concept of our project. It practically intends to promote innovation for the energy vertical via a 5G-enabled experimentation platform. We can see here that we have a variety of market players that come together, work together in order to promote new and innovative solutions in the vertical ecosystem. Very, very quickly, what we have here are the various objectives of the project. Of course, this should be just one slide for a whole presentation. What we intend to do is, first of all, to create the necessary platform to serve the energy vertical. To propose an architecture and the related interfaces, this has been done. Then, in parallel, to develop the open network applications repository that will have the involvement of other market actors. To have performance of those network applications, and then proceed to the validation and verification framework of these network applications. The most important part is here, the realization of 4 use cases. Okay. And then the option of passing directly to market analysis and the new business models. The motivation of the project, the technology features leading somehow the motivation of the project is via these bullets. We have a Smart 5 Grid multi-access edge computing platform. We propose a 5G core service-based architecture, and of course the various network applications that will form a necessary repository via our technological solutions. The architecture, I will give more details in a dedicated presentation. The most important is that we have 3 distinct layers. The one is practically based to the NFV Mano concept. We have one related to the energy approach and our platform following the targets of the project. And then we pass to the 4 use cases that will be presented very, very quickly. So, as I mentioned before, the aim is here to propose an environment for third-party developers via the introduction of the necessary network applications. This is the structuring of our project according to the objectives I mentioned before. And very, very quickly, an overview of the use cases. The Italian pilot, it's about the automatic power distribution grid fault detection. We have a scenario where we intend to consider how the 5G network can improve performance of remote control connectivity for real-time automation and monitoring of the distribution grid. The challenge here is mainly related to the reliability of the communication infrastructure, and also it is relevant to the option of having a reduction to the operative costs. The purpose is improving the continuous accuracy of the communication layer, improve performance of real-time self-healing capability, which is a very important option, and also overpassing constraints related to the grid stability and the cybersecurity. Then we have the Spanish pilot, which is about remote inspection of automatically delimited working areas at distribution level. I will pass, for the sake of the economy of time, very quickly these slides, because I will come back to a next presentation, and meanwhile, the other speakers will cover these issues. Here, the challenge is about promoting the priority for the safety of the workers. So we introduce a process enabling the detection of workings and their working tools when they access a delimited or forbidden area. This is the technical solution via the inclusion of sensors and other ICT-related equipment. Then we pass to the third use case that will be presented in detail in a forthcoming presentation. Here we have connection of thousands of decentralized REs, renewable energy sources units, and their inverters, allowing control by the involved energy market players. The scope is to realize millisecond-level precise distributed generation monitoring focusing on renewable energy resources. Why real-time is monitoring? It is for these 2 main reasons. The owners can predict and prevent the potential future malfunctions and can have benefits in their operation. This is the technical solution. And finally, we have the joint Greek and Bulgarian pilot, where we intend to deal with inter-area frequency oscillations that potentially may affect the system stability. So we propose a solution based on the involvement of phasor measurement units. And this may be an opportunity for the establishment of a communication infrastructure for supporting wide area measurement systems of each involved smart grid. More details will be given by my colleagues. We have a dedicated framework involving infrastructure both in Greece and Bulgaria. We have a joint phasor measurement unit PDC scheme, phasor data concentrator scheme that will give all the benefits coming from 5G. This is a depiction of the system that will be discussed in the next presentations. I'm running up because we are somehow in delay. And practically, I summarize the introduction by saying that our project is a very important research initiative proposing transformation of the power distribution grids to smarter entities. The main innovation is the adoption of 5G network infrastructure and facilities via the development of network applications consisting of chained VNFs. So this is very, very quickly the first part, the first introduction, and then I will give the stage to the next speaker, our friend Mr. Dimitrios Brodimas from the Independent Power Transmission Operator, ADMIE, in Greece. I would suggest any potential questions to be collected and come by the end of the session because of the interactivity of the presentations. Thank you for your attention and apologies for running somehow the slides. However, I expect that the next speakers will give more details. Dimitris, the stage is yours.
Thank you. I'm a PhD candidate at University of Patras and a researcher for the Independent Power Transmission Operator of Greece. Today I'm going to present you our use case in Smart 5 Grid project regarding the real-time wide area monitoring of Greece and Bulgaria. IPTO is the use case leader in this use case. So, the high integration of renewable energy resources in the energy grid introduce a lot of issues in terms of reliability and security of supply in the energy grid. So, we need a real-time wide area monitoring framework that is going to monitor and control the actual energy grid. This tool is going to provide some information and some insights and strategies regarding the operation of the grid to the two TSOs, IPTO and ESO. The actual objective of this use case is the creation of a wide area monitoring tool, as I mentioned earlier, which is going to be composed by a virtual phasor data concentrator, a VPDC, and from the actual measurement devices, the PMUs, the phasor measurement units. Those two components are going to be connected via a 5G communication network. On the right-hand slide, on the right side of the slide, you can see the actual map of our use case, where the two PMUs are going to be deployed in Thessaloniki and Blagoevgrad, while the edge cloud server hosting the VPDC is going to be deployed in Sofia. But what exactly are the PMUs? They are measurement units measuring voltage and current phasors, meaning that, and this is their major advantage in comparison with other measurement devices, that they can compute the frequency of the grid. In addition, they timestamp each and every one of the measurements, and they use the two protocols, C37118 for the measurement transmission, and the VPDC is actually described via the C37244. The traditional and the legacy solution of the PMUs and the PDCs is that the PMUs forward their data through several hops of the PDCs. However, this solution integrates a lot of latency during the transmission of the data through all those hops, and every hop introduces almost 40 milliseconds of latency until those data reaches the common control room. However, our solution proposes one virtual PDC that directly communicates the interested PMUs, the one in Thessaloniki and Blagoevgrad, directly to the common control room. So, in comparison with the other legacy solutions of the PMUs and the PDCs, we do have direct communication between those devices using 5G networks, and in comparison with previous generation of wireless networks, we do achieve several KPIs in terms of latency and reliability, and we are almost the same with the optical fiber, meaning wireless solutions. Here are some KPIs. As you can see, we do need a lot of reliability and availability for the measurements to arrive at all times at the VPDC. We do need an end-to-end latency from 40 milliseconds up to 160 milliseconds. The VPDC waits for all the measurements to arrive for 40 milliseconds, and we need high bandwidth and security. Here is the high-level architecture of our use case. You can see the interconnected systems on the left side of the slide, where the PMUs are deployed in Thessaloniki and Blagoevgrad. The 5G networks in each substation is used to gather the measurements and forward them to the edge cloud server hosting the NetApps. The NetApp is composed by the VPDC, the advisory service, and the monitoring service, while we use the nearby one orchestrator in order to deploy those services via Helm charts into Kubernetes cluster. So the NetApps, the first one, the VPDC is responsible for the aggregation and synchronization of the data provided by the PMUs using the protocol C37-244, as I mentioned earlier. The monitoring service next is responsible to present several status indicators and visualization features regarding the PMU measurements, such as the frequency and the FPS of the arriving measurements. And finally, the advisory service, who is responsible to provide several remedial actions back to the TSOs. Here is the actual network setup that we are implementing in our substation. We do have the PMU connected to the three phases of the energy grid. In the secondary transformer, we use Ethernet link to directly forward the measurements to the ZXL 5G gateway, and from there the 5G network is used to send the data through the international carriers and 5G non-standalone to the edge cloud server. Three scenarios are implemented. We're using 3 SIM cards, 2 from Cosmote and 1 from Vivacom, with different APNs, but this is going to be more in details in the next presentation. Here are some photos of the substation, where we do have the GPS antenna and the gateway outside of the substation, the PMU internally mounted on the rack, and a small overview of on the right side of the slide. So last but not least, regarding the target market and the opportunity, the proposed solution is strongly correlated with the energy sector, since we are using the PMUs. So the possible customers of the solutions could be the TSOs or the DSOs or the RSCs. Regarding the opportunity, it lays on the provision of a framework that enables fast fall detection and fast frequency responses in the ensuring grid stabilities and seamless operation. That's all from my side. Thank you.
Let's say the loss of time we had, which is evident for a large session. I think we have got the opportunity to give direct focus on the related use case. We will pass to my colleague Michalis Rantopoulos.
Thank you very much.
Michalis is a member of his team dealing with Smart 5G, and we'll give the next presentation. We can pass to presentation number 3.
Thank you, Ioanni, for your kind words.
Do you need this, Michalis, or?
Yeah, I think I can.
If you stay, in case you need.
In case. Thank you. Good morning to all. I'm Michalis Rantopoulos. I've been working at Cosmote Mobile Communications for 21 years now. My background is telecoms, and I have been involved in various projects. This presentation is a combined effort with Dr. Ioannis Kouliouros under the title Vertical Use Case, Real-Time Wide Area Monitoring Between Greece and Bulgaria, Developing a Modern Network Interconnection Scheme by the 5G Operators. A brief overview of the real-time wide area monitoring. The scope of our use case number 4 is the real-time monitoring of a geographical wide area, where cross-border power exchanges take place. The interconnection flow between Greece and Bulgaria is monitored, leveraging the advantages that the 5G communications infrastructure provides. To achieve the enhancement of the interconnected power system operation, live monitoring of the interconnected power system flows is of vital importance. For that reason, the PMU phasor measurement unit, as explained by Dimitris earlier, PDC scheme will be used, enabling high data number and granularity. Finally, the focus of this presentation is the utilization of 5G, which contributes to the connectivity between the PMUs and the VPDCs, offering its low latency and high reliability, fulfilling the critical constraints of this use case. The goals of the real-time wide area monitoring. First of all, under a broader perspective, the continuous expansion of the distributed energy resources significantly increase the complexity of the power system, making its real-time operation and control functions demanding and difficult to handle. The existence of a wide area monitoring is essential that is capable of capturing and alleviating dynamic phenomena that create hazardous conditions for the stability of the entire European power system. Multiple control areas exist in the European power system, where its TSO is responsible for the control of its system. For the proper coordination between neighboring control areas, regional security coordinators owned by adjacent TSOs are established. One of the RSC's goals is the coordinated security analysis in multiple time frames, day ahead, intraday, and real time. It's important to mention that offering of an orchestratable VPDC concentrator service compliant with the Energy ETSI and cloud-native standards, offering of a data network able to facilitate real-time monitoring of critical energy KPIs such as frequency, and automated control actions on a later stage. Finally, offering of a platform to bridge the application with the network and manage both of them according to selected KPIs.
Εδώ κάτω όμως φόντς.
Να φαίνεται το από το δευτικό.
This is a high-level overview of the traffic flow paths regarding use case number 4. On the left part of the diagram, you can see the interconnected systems owned by IPTO for Greece and ESO for Bulgaria. The two PMUs, PMU1 is offered again by IPTO and is covered through 5G non-standalone Cosmotes network regarding the Greek demo, and as referring to the Bulgarian demo, PMU number 2, so-called, will be covered by 5G non-standalone network by Vivacom through a private APN tunnel reaching the user plane path, the edge cloud servers. The particular location is at Thessaloniki of IPTO substation, and ESO's substation is at Blagoevgrad region. The edge cloud servers, however, are based at Sofia, and some reference to the interconnection as well. One of the main challenges of our demo, of the Greek site demo, is the 5G network coverage at Thessaloniki site. According to our discussions with Access Network Department, we have a predicted fair outdoor coverage of the specific spot where the PMU will be placed. However, due to the industrial nature of the installation and the big pylons surrounded by metallic constraints, metallic buildings, let's say. This ability to cover through 5G network is severely affected. There is a site survey ongoing. We will try to tackle all those issues. We are in open communication in any case with the Access Network Department and its engineers of Cosmotes. The initial testing, what we did about 2 months ago, was just a proof of concept to measure or to test the end-to-end connectivity regarding the network part. At this diagram, there is no PMU connected. The 5G gateway router was installed at IPTO's headquarters in Athens, and Cosmote provided a 5G-enabled SIM card which was installed in the gateway router, and we started sending some basic testing signals through iPerf. The laptop with the iPerf client was connected to the gateway router and managed to successfully send some readings with the aforementioned critical latency criteria successfully met. However, we have a screenshot of the first results. However, this is not evident of what will be the final implementation at the real demo, since the public internet was used as the backbone network, which will be avoided in any case for obvious reasons during our demo. We have investigated various scenarios for the interconnection part of the Greek site. According to our research, the roaming interconnection scenario seems to be the most, seems to provide the optimal routing. So for this, for the implementation of this, we asked Vivacom colleagues to provide us with a 5G-enabled SIM card, enabling this. Of course, this scenario is feasible due to the 5G commercial roaming activated between Cosmote and Vivacom. So this Vivacom 5G SIM card is installed at the 5G gateway router, and the 5G connectivity is successfully established. And the main feature that we would like to highlight on this diagram is the home-based routing for the roaming interconnection scenario, which basically means that the serving gateway, which receives the call near Thessaloniki, directly forwards the user plane path to the packet gateway at Vivacom's network at Sofia, which is locally nearby Vivacom's Edge Cloud server. With this way, we managed to keep the user plane path, let's call it locally, that is between Thessaloniki and Sofia, not having excessive paths through Athens and again to the north of Greece. The first results, this is a screenshot of the first results obtained by IPTO a few weeks ago at the 31st of October. We see that the number of hops are limited. However, the latency seems to be excessively high, seems to be above our critical targets. And we are looking into this. Hopefully, at the next site survey, we'll be able to bring this significantly down within the 40 milliseconds critical constraint of the absolute wait time till the data reaches the PDC. This is a similar diagram of the 5G network coverage at ESO's Blagoevgrad site. They have Vivacom provides a good outdoor predicted coverage for the PMU location at Blagoevgrad. It seems to be rather straightforward, which means that the interconnection scenario is kept locally at Vivacom. There is no roaming involvement in any case. They have created, Vivacom colleagues created a slice for the APN Smart 5 Grid WP4, which handles the data between the serving gateway and the packet gateway at Vivacoms, and successfully forwards the packets to Vivacom Cloud Router. There was also an initial testing similarly to what we did from IPTO's headquarters in Athens. As you can see on the left part, there is no PMU involved. The initial testing results, similarly to our case, by using the public internet path, were, let's call it, successful in terms of latency criteria. The jitter also seems to be reasonable, and yes, but please note that the PMU was not connected at the 5G gateway router for this case, neither. Finally, a synopsis of what we have discussed so far, the pending issues and the lessons learned regarding the 5G network tests, the connectivity test and initial KPI tests via the 5G gateway to the edge cloud server using public 5G non-standalone internet of Cosmote and Vivacom, using as user equipments, firstly, the PCs for the initial testing scenario, as we discussed for the Greek and Bulgarian demo, and then by connecting the PMUs to the gateway router. PMU tests are mainly owned by IPTO, are handled by IPTO, provide our support, of course, as telecom operator wherever it's needed. Validity tests with the manufacturers of the PMUs is also a challenging task. And the lessons learned so far, I have to highlight the difficulties regarding the coverage issues due to the, we are talking about real life situation, we are talking about industrial substation where our coverage is affected by many at first sight, let's call it, predicted factors. There are security constraints, of course, on physically and let's call it network-wise. The integration of 5G gateways with the PMUs, of course, which is a task performed mainly by IPTO with our help, as I said before. And we have tested various scenarios for each SIM card, either through Greek APN, private APN, public internet APN, and Vivacom APNs. For each scenario, we have to deal with the security rules at the edge cloud server and handling as well the PMU target IPs. There is some configuration to be done. I think I have completed now my presentation. I hope I'm in the...
Okay, Michalis, thank you. Thank you as well for being within the prescribed time frame of your presentation, the details you have mentioned, in particular demonstrating once again how theory is different from practice, how dealing with practical issues about network deployment and testing. And of course, this is part of the validation and verification process which has been started, and we expect that in the course of the project we will have more results to demonstrate. Now we will pass to the next speaker. We will have virtually our friend Mrs. Ralitza Rumenova from Entra Energy in Bulgaria. In particular, I would like to express my profound thanks to Ralitza for joining this session. However, it still, we have some difficulties, it appears. Okay. Okay, we pass. Unfortunately, I'm not aware of everything. Thank you, the panelists, for giving me this information. We will pass short to the next presentation, which is an overview of the architecture. Okay. I have to count the time. I will try to pass it very quickly. It is presentation 5, P5. And hopefully, if Ralitza manages to join, we will have them at the end. So, following to the presentations regarding the scope of the project and the specific use cases. What I will try to do, once again very quickly, because I have many slides, and the aim here is just to give the initiative to the speaker to look for, and to the audience, of course, to look for further information, investigating data in the web or in the dedicated website. Otherwise, we could have selected a certain number of slides, and that's all. On the contrary, my preference is to give more information, hopefully, in order to give more initiatives to everybody who is interested just to look for deeper. So what I will try to discuss here is about some features coming from the part of the architecture proposed by the Smart 5 Grid project. These are the contexts of the presentation. We have seen in previous slides the information. We have many European partners. We have a project of 3 years duration. We have seen the composition of our consortium, which practically means that it is expected to have strong impact on the market activities, on the energy vertical market in particular. These are some essential aims of the project, just to remember and have an idea of what we are looking for. Actually, it is about promoting innovating solutions via a dedicated experimentation platform in the energy vertical. How we will do this? The response is by using a 5G-based experimental facility where we will deploy new services and dedicated network applications. We will have a necessary repository, and then, of course, via the validation process, we will try to investigate any potential business opportunities. The challenges, very briefly, are listed here. Actually, we intend to promote a new framework which will support flexibility, orchestration for the network slicing options and very low latency in order to have a better quality of the service. And these are some challenges: very high device density, what has been mentioned before, numerous sensors and metering in the scope of the smart grids, very high bandwidth for allowing massive data flows, and of course very low latency for various purposes like for detection, network isolation, recovery devices, and so on. These are the objectives presented in previous presentations. Okay, I pass it very, very quickly. These are the 4 use cases in Italy, Spain, Bulgaria, and the joint one between Greece and Bulgaria, which means that we expect to cover a lot of applications from the vertical sector. And now the aim of my presentation. Actually, the proposal is about structuring an appropriate architecture and related interfaces. What I will cover in this presentation is the concept of smart grids, the cloud-native paradigm, and the multi-access edge computing in 5G networks, which is a very important one, how all these are related in the scope of our presentation. As already mentioned, smart energy grid implicate for many and demanding challenges in the energy sector. Actually, the challenge is here that the energy infrastructure needs to be digitalized, and this is also a very beneficial option for deployment and inclusion of renewable energy sources within the traditional energy grid or the smart energy grids. So here, some actual challenges: the interoperability with distributed resources, need to properly manage congestion and multidirectional energy flows, so active participation to the energy market through the provision of new services via flexible framework, new forms of energy demands. All these are traditional challenges for the grids. And in this framework, we have challenges for the energy system operators to have the necessary tools to supply the necessary, let's say, facilities and to guarantee for a quality of service. So in parallel, we have options about minimizing energy costs, environmental impacts, and of course, the major challenges about stability and security of the systems, as both presenters Dimitrios and Michalis mentioned before. So for the case of the smart energy grids, these are necessary for the integration of amounts of variable renewable energy sources. And in particular, when we do so, we can maintain stability and efficiency of the system. In our framework, we focus on this challenge, and we try to propose dedicated solutions. So what we intend to do with the inclusion of the smart grid framework is to integrate interconnected and wide distributed components, both from hardware and software nature, and so create higher functionalities. What these functionalities are? It's about advanced metering and monitoring, which is a very important one, active network management, which is a challenge for any sort of network infrastructure, flexibility services, as I mentioned before, and of course, some potentially smart charging services like vehicle to the grid or vehicle to home. All these are some challenges coming from the inclusion of smart grids. And here comes the response from the case of our project. Actually, in the Greek-Bulgaria demo, we intend to develop advanced monitoring. In the Spanish demo, we have focused on the safety system. In the Italian demonstration, in the Italian pilot, the aim is about an active grid management system. So previous challenges, more or less, are among our priorities. Now, some information about the cloud-native context. Why? Some characteristics, very briefly, what we are talking about. These applications often needed to operate at global scale. They must scale with thousands of concurrent users. These are the main and the fundamental features characterizing what we call as cloud-native application, built on the assumption that infrastructure is fluid and failure may be constant, so that to deal with unexpected situations. And these are designed to upgrade and the necessary underlying infrastructure. These are also included in the scope of our Smart 5 Grid framework. So this is an approach in our architecture to design, build, and run application as virtual functions. We will see what we call later on as network applications. This actually refers to the way how these applications are created and deployed, not to the way these are executed. And we propose, I don't want to give more details for the sake of the economy of time. However, this is an important slide, how we proceed. We consider the 5G PPP cloud-native approach on 5G vertical services, a dedicated white paper proposed by the European Commission and the European industry. So what we consider is a depiction of the evolution from the classic solution based on VNF implemented to run inside virtual machines. And we have these considerations where classic solutions based on running a virtual machine on top of bare metal public cloud and the use of hypervisors. OpenStack has been the de facto cloud computing platform in our approach. However, this is the panacea because we still have problems to deal with, and it is evident. So it is difficult to manage multiple VNFs. It is hard to combine different blocks from different vendors if we consider multiplicity and multi-tenancy feature. We expect that for all these cases, in the course of the project, we will give related solutions. And now, passing to the final part of the presentation, multi-access edge computing, in very general terms, allows a smooth transition in the 5G network rollout. It is quite important because due to the virtualized characteristic supported by MEC, it is easy to monitor performance and resource needs of an application. So this is quite attractive because we can provide many improved capabilities at the edge of the network, intelligence and the ability to charge for a service. So these have, apart from the pure technical impact, also a very important business impact as well. Our solution in the project is briefly mentioned here. We integrate the MEC data plane with the 5G system data plane. An application function interact with the 5G control plane functions so that to influence traffic routing and steering. In the 5G context, the prime aim is to support low latency and enable enhanced performance and quality of experience. So all these challenges can be faced and via the consideration of MEC and related solutions can be provided. Just to summarize that this feature reduces latency to the millisecond level, which is the high challenge, especially for the case of use case 4 presented before, and allows for constant connectivity. And so it is expected that this will provide a multiplicity of benefits for the provision of related services to the market sector. Now, just a very briefing, because these 3 slides, the one and the 2 following, could be a dedicated presentation. However, just to give some information about what we are talking about, among the core features of the project and similar projects is the development of network applications. This is a challenge for developers to define applications in the form of joining accordingly pieces of software in the form of virtual network functions. We consider the Edge NFV framework, a dedicated framework is to develop a network application as a cloud-native application. That's why I mentioned some essential pieces of information before. The network application contains the component to offer a service as a software, and this is mainly our approach. So a network application can contain one or more VNFs, as we can see here. Just indicatively, without more details, we have a network application and 2 dedicated VNFs. This is the challenge of the project, actually, for all use cases. And this just gives an idea how the network application is to be developed. For the time being, just keep in mind that we have these separate parts, stages, which is about the development, verification, validation, and then the publication, each one conformant to the specific needs of the project. And now, just to conclude, 5G networks are essential tools for the development and expansion of smart 5G technologies, because 5G allows for the integration of numerous devices. This is actually one of the features of the 5G technology to the smart grids, so that to collect a lot of information and then properly manage the production and the distribution and the flow of energy. In our scope, in the Smart 5G framework, we propose a platform based on 5G, and this will take place in parallel with network applications. We have seen that the project also proposes an option for enhancing security, reliability, efficiency, and relevance to real-time solutions. We will consider the virtualization framework, which is based on cloud-native applications, which is the basis for developing the necessary VNFs. And of course, the inclusion of multi-access computing forward innovation. We expect that in the course of the project, we will manage to offer what we actually characterize as new horizons for the energy vertical. And that's all by my side. I don't know if our colleague from Bulgaria was able to join or not. Not? Okay. In any case, we are according to the time schedule. I also want to express my thanks to the technical panel. So before passing to the next second session, if there is any question, any comment by anyone among the audience, if not, I will summarize and express my profound thanks again to the speakers. Also to our colleague from Infolysis, Mrs. Marina Koulaloglu, who supports all dissemination and other organizational activities of the project. I hope we have managed just to pass some ideas, just to promote some innovative features coming from the original scope of the ongoing Smart 5 Grid project. What you have to keep in mind, if I may use this term, is the fact that this project is among the few ones dealing with the energy vertical, and this is a project which practically, via the difficulties it faces, it also identifies new options for extending digitalization in the energy vertical, which is an area not practically touched by ICT technologies, at least up to now. So we expect that via the proposed use cases, some new solutions in the form of the respective network applications will be able to be offered to the market sector. And we expect that this will create a new dynamicity for the market actors to deal with the main partners of the consortium, because the consortium is open, it supports interactivity, it supports collaboration with other third parties coming from the market sector. And this is a very great and remarkable opportunity in order to see how 5G, how communication technologies in general may be involved within the energy vertical sector. So if there is no other question by anyone else, we can have a short break, and I will invite my colleague, Dr. Christos Gizelis from OT to be prepared for the next second session. So we can have a very short break, something like 5 minutes before passing to the next session. Thank you all, ladies and gentlemen, for your attention. Αγαπητοί κύριοι, κυρίες, θα προχωρήσουμε στην επόμενη σύνοδο, η οποία θα ασχοληθεί με το Dataports Project. Όπως είπα πριν, επειδή οι παρουσιάσεις αφορούν σε ένα ευρύτερο κοινό, γίνονται στα αγγλικά, θα μεταβώ και εγώ λοιπόν στα αγγλικά, by welcoming everybody participating in this second interactive session, which will be about opportunities and challenges for the seaports of the future in the 5G and beyond era. We will see several aspects and innovations coming from the Dataports EU-funded project. I would like to welcome my colleague, Dr. Christos Gizelis, with many thanks to Christos and to the other speakers for their kind support in order to organize this session. And Christos will also be the chairman of this second session. The stage is yours.
Thank you, Yannis. It is a great pleasure to be here. And I would like to thank you on behalf of Dataports Project for giving us the opportunity to present our research activities in this year's Infocom conference. Dataports Project is not a 5G project. However, 5G, IoT, and other network technologies could be the backbone in order to transfer and share data, data that are considered are resources for data-driven platforms like the one that is proposed by the Dataports project. Something's wrong with the... No, it doesn't. Okay. Dataports project, another EU-funded project under the Horizon 2020 framework with a 3 years duration. We just received a 3-month extension. Currently, we are reaching the final stage, 4 months left. A budget around 6 million euros, 900 person months, and 13 partners from all over Europe. Industry partners, Porto, pilot entities, research centers, universities. So we together create a cluster that combine all the skills needed for this research. So what Dataports project is about? It's about creating the seaports of the future, creating ports, actually making ports from interconnected into smart and cognitive by providing a secure environment in order data to be aggregated and shared from and to different sources. And that will have a port community to benefit from this data exchange. How we plan to achieve this? By creating a distributed architectures data-driven platform that is capable for data processing, data aggregation, acquisition, and of course under a secure environment, and also being compliant with the data protection and European regulatory environment. Having blockchain as the main backbone technology to ensure security and trust. We ran 3 use cases, 3 pilots, one in Valencia port with several scenarios like tracking of transport operations, data sharing and analytic services for port authorities, sharing verified gross mass. Another use case in the Thessaloniki port pilot with services for container pickups, passenger facilitation, and statistics, but also run a global scenario use case with reference in tracking containers and port management systems. Why we do all this in data ports? Because access to information gives answers. Answers for what? For better customer insights, new forms of collaboration between the stakeholders of the seaport ecosystem. Also, answers will improve decision-making to the decision owners, the key stakeholders, and of course expand the customer base of the entities, of the companies around the seaport. And this gives opportunities for businesses, for citizens, for research centers, and public bodies. Why? Because it creates a new data-driven market. Citizens or data providers can have full control over their data, gives access to services. Research community can have access to data and provide new services. And public bodies using this platform could have better governance services, better digital services, or even real-time statistics. This is how we imagine the seaport ecosystem of the future. It will include industry end users, technology providers, data market actors, and more are more than welcome to join. We envision a seaport ecosystem expanded with more stakeholders than the ones that are already known. Cargo hauliers, port terminals, transport operators, cargo owners, other data-driven platforms, custom authorities, even culture, museum authorities, commerce associations of the local region, railway authorities. All these could be come and create an ecosystem around the seaport of the future. And data will be what they will bind them. At the beginning of the project, we ran a survey to identify the market needs. And we saw that the community is ready to be on board the seaport transformation. We see a great interest from the shipping and maritime community, actually a major actors in this attempt. Universities and research institutions show a great also interest because they have a thirst for data, and this data will help them, will assist them validate their research, and port authorities could be the selling point for them. So it's a new economy also for the academia. Telecommunications, of course, data sharing could rely on telecoms. ICT services, cargo logistics, software houses, and all this you can depict from this picture. Another feed we had from this survey is why all these entities have an interest in data ports and in data-driven platform in general. They need data, and they need them to process safe conclusions, so decision-making for research purposes, and to better map their customer needs. So these are considered the key elements that were considered in the last 3 years of data ports. And of course, accuracy, availability, and up-to-date are what is important when using data. And all these parameters are also covered within a data ports project. especially accuracy, availability, data being up to date, and the easiness to migrate those data. And all this based on the components, the tools that created in the Dataports platform. And more about this, you'll hear from the next Dataports colleagues. Some of the achievements so far. We managed to create specifications and match the existing ones of the industrial platforms. We create a Dataports architecture where it could be the baseline for the future of the seaports. We create a new business and exploitation and innovation strategies. And all details about this can be found in our website. So this is it. I would like to thank you. If you have any question before we pass to the next speaker.
Thank you so much, Christos, for this global presentation of the Dataports project, giving all expectation and innovations coming from the project. Just a general question by my side regarding the maturity of the market related to the innovations. You mentioned that there is strong interest. How, according to your expertise, how easy you find this transformation by taking into account, let's say, the outcomes of the project and the interest of the market actors, because it's very important. Just a comment on that, if possible.
The market actors are there. The need is well known. The stakeholders, in some cases, are very skeptic. Shipping and maritime sector do not make very fast moves forward. However, we have a consortium with strong technology skill sets, and we have managed to create tools that will help and ensure security and trust. So even that slight objection of some stakeholders, I'm sure that we'll overcome very soon.
Thank you so much.
Thank you. Okay, thank you. Now it's time to welcome a fellow data porter representing Thessaloniki Port Authority, one of the main pilots of data ports, Mr. Grigoris Dimitriadis. Grigoris, it's great to have you.
Hello. Hello, everyone. First of all, I would like to thank OT for inviting us to this event and giving us the opportunity to talk about data ports from like our point of view. Yeah, I am Grigoris Dimitriadis, as Christos said. I work in the ICT department of the Port of Thessaloniki, and I'll give you a brief overview from an industry partner perspective of the participation to data ports. So shall I share my screen? Can everyone see it? Can I have some feedback about if my presentation shows?
Yes, we can see your presentation and you as well.
Okay. And me as well. All right. I'd rather not. Anyway, so first, a few things about Port of Thessaloniki. As most of you may know, it's the second largest port in Greece. It's located in Thessaloniki in the north. THPA is the acronym that we use, so you'll see it throughout the presentation being used. Thessaloniki port has a great hinterland connection and is considered to be a gateway port to the southeast and central Europe. It occupies a total space of 1.5 million square meters and spreads across a length of 3.5 kilometers. And it's literally adjacent to the city, which is sometimes both good and bad, actually. Well, the port includes 6 piers. You can see them in the photo. It's got open and indoor storage areas suitable for servicing various type of cargo. You can see at the bottom, we handle containers, dry bulk, liquid bulk, general cargo, and also servicing passenger vessels and cruise ships. You can see from the pie chart, it's quite obvious that most of the revenue is generated from the container terminal. It's about 66%. And the container terminal, together with the conventional cargo terminal, handling all the bulk and general cargo, they make up about 97% of the port's revenue. And we recently opened a dry port in Bulgaria to service the hinterland for logistics issues. Now, as mentioned, THPA is one of the pilot ports in data ports. And in the context of the project, a number of use cases actually are being implemented. I'm just going to briefly mention them here. It's the Coreor or container pickup use case, which I'm going to analyze mostly in this presentation. We also have 2 use cases featuring statistics and predictions, which involve fusing data generated from various THPA systems and applications to generate useful statistics, operational statistics, and KPIs. We have 2 use cases that also fuse data, but this time we're giving emphasis on mobility and mostly combining OTs, mobile subscriber data, and also arrivals of passengers and cruise ships in the port to produce heat maps and predictions on movement of people and vehicles around the port area. And finally, we have 2 global use cases, as they are called. They showcase the use of IoT devices, but not as strict. Posidonia Operations is an application that feeds data to the Datapulse platform, and it uses an ICE antenna to build some intelligence on top of it, because an ICE antenna just transmits raw vessel location data. And Posidonia, by using cartography and combining cartography and then the vessel data, transforms basically this raw vessel location data to events that are meaningful to the port in real time. Like, for example, the ship has just moored or docked or undocked and all that. And finally, the other global use case is smart containers from TrackSense. It uses IoT devices mounted on containers. They are sensors mounted on containers, and well, they also transmit data about themselves, and they allow parties to follow the location of a container. Now, about the main use case, we'll call it main because it's the one that heavily features the blockchain component, which is central to data ports. Well, with this use case, the goal was to support, sorry about that. Right. The goal was to support the THPA ecosystem stakeholders and to better organize and manage the container pickup, with emphasis to land gate access, meaning the trucks arriving to the port in and out for traffic issues. And the way to achieve that is that the blockchain application that is being developed will facilitate secure information sharing between THPA and the supply chain related parties, namely shipping agents and tracking companies, about concerning the business cycle of the electronic request to pick up a container. So for this scenario that was implemented, we identified three involved parties, the entities. One was obviously THPA as a company. We would just call him a terminal operator, somebody from THPA. Well, they need to have a unified information from a number of systems so as to verify that all relevant paperwork is in place and provide a container release order. A shipping agent, they need to make arrangements and all the relative paperwork for picking up the cargo. And the tracking company that needs to be timely informed for the container pickup. Now, this is a sketch of how the solution is structured. We can see that the three mentioned involved parties, THPA, the shipping agent, and the tracking company, all interact with the local blockchain instance or node, which in turn interacts with the Dataport platform and its components, and also with THPA infrastructure. So this is all centralized and overseen by the blockchain component, a major part of which is the data governance, which you see on the scheme, and you'll hear more about from the next presentation by Mr. Zerzalidis. So roughly the process is this. A shipping agent, well, they deal with a container, and once it arrives and it's unloaded from the vessel, they have to arrange all the paperwork related to the container being able to leave the port and being picked up. Ourselves, the Port Authority, will have to verify that all relevant paperwork is in place, and we approve the container discharge. But at the moment, before Dataports, without having any further involvement. That means that the shipping agent has to make an arrangement with a tracking company about the pickup of the container once it's allowed to leave, and the THP is not part of this arrangement. So the Dataports platform will introduce the blockchain component that's going to store the request. It's called the container release order, where all the life cycle of this, the container release and pickup, can be followed by all involved parties. So this is the core thing I've been referring to. As I said, it's an acronym for container release order. It is an electronic message following XML and EDIFACT standards. This is actually one of a set of similar XML messages that have been defined in the maritime industry, such as COPRAR or COARI, that they describe various operations like loading a container or announcing a vessel arrival and others. These are used for electronic exchange between systems without people have to call in the phone or something like that. So in a caller message, as you may get a glimpse of, the shipping agent specifies the container that they want to pick up. Small parenthesis, each and every container is actually marked with a globally unique identifier. They're not just nameless boxes going around. And also in the caller message, they define also details about the container, like which vessel it was unloaded from, its cargo, its size, the weight of the cargo, what's the contents inside it. And in the message, they also specify when the request gets approved, which tracking company will come to pick it up, because shipping agents are not tracking companies; they collaborate with people that have the trucks, actually. Right, this request gets stored in the THPA systems. Well, obviously through the blockchain component, and it has to be checked by THPA staff to see if everything is in order. For example, customs clearance or nothing pending in payments, or any issues that the box may have to be able to leave the port. And if everything is okay, then THPA approves the request. And when it does that, a unique permit ID is generated. Now, this unique permit ID is obviously tied to the specific courier request that was made by the shipping agent. Now, through the blockchain component, this permit ID is communicated both to the shipping agent and that sent the request, the courier request, and the tracking company that will pick up the container. Now, in THPA, in order to optimize the flow of trucks in our premises, we have an application in place. It's called the Truck Appointment System, or TAS, as we call it. And truck companies and drivers have to use that to book slots where they set a time window when they will arrive to the port and either deliver a container or pick up one. So the tracking company, when accessing that system to make a booking for the pickup, they specify the container to be picked up and also enter the generated permit ID that I spoke earlier. Now, the blockchain component, since keeps track of all the steps, it can notify anyone and also make sure that the given ID container ID, in that booking matches the expected permit ID. And if all goes well, then the tracking company receives a confirmation for a successful booking. So the truck can proceed with coming to the port at the defined time slot, of course, to pick up the container. So this is the flow I just described. You can see the order. Shipping agent sends the courier request. THPA receives the request. Everything is okay. Number 3 issues the permit ID. And well, the next part is the nice part. That number 4 is actually forked. Both the shipping agent and the tracking company get notified of the permit ID, so they know that everything's all right. And using that permit ID, then the tracking company, number 5, sends a request for a booking, which is received by THPA. And if everything is all right with the booking, then the booking is accepted, and there is a time window defined for the truck to arrive to the port and actually pick up the container. So this is the scenario that this use case actually implements. So some benefits from that use case and from the participation of THPA in data ports in general. We have safe and secure transactions and data exchange, immutable single source of truth for all transactions. These are actually buzzwords that really hint to the blockchain component. We have a transparent business cycle of container discharge, and with that, THPA ecosystem stakeholders can optimize their processes. We have a platform that contains and combines data from different sources and entities. And through all those, we have an increase of operational awareness, reduction of time loss through optimized use of resources. So that was it from my side. Thank you very much again for inviting us and having us, even online, not IRL, sorry about that. So if there are any questions or...
We don't see any hands raising from the audience here. Grigoris, thank you very much. You very well bind the business need, the business cases, and the technologies that used in Dataport's project. So thank you, even if you couldn't be here with us today. And
logistics issues, sorry about that.
Next time.
I was honored to be invited though. Yeah, thank you very much for the participation once again. Good morning from me.
Have a good day. So it's time to become more technical. So I would like to invite my colleague from Dataports, Alexander Zelidis from CERT ITI.
Μπήκα κατευθείαν στο κλίμα της παρουσίασης στα αγγλικά. Αυτό είναι, με αυτό μιλάω. Ωραία, ωραία. Ευχαριστώ και εγώ πάρα πολύ. Thank you very much for the invitation and for the opportunity to present our work here. It's a great venue, and we're glad to be part of all the projects that are being presented. My name is Alexandros Zerzeridis. I'm a researcher, software engineer at CERT, or EKETA in Greek, the Center for Research and Technology, which is situated in Thessaloniki. Today I'm going to speak about the data governance component of the platform, which makes heavy use of the blockchain technology that has already been mentioned as part of the local use case. So let me start. So data governance is a mechanism that enables the enforcement of access rules to business data assets in a transparent, verifiable and non-reputable way. And here, when we talk about business data assets, we mean various data sets provided by various organizations of the maritime sector, which can not only be ports or trucking companies or shipping agents and so on, but can also be telecommunications companies or other partners of the general ecosystem of the port, like the municipality that the port belongs to, and so on and so forth. Various data sets. However, all these data sets, what they have in common is that they provide some value to the port's operations. So they are needed as part of some analytics that is being done, or some aggregation of data to produce some valuable result. And data governance increases the confidence in the registered data, because with data governance we know who registered the data, we know the metadata of this data, we can describe the dataset in a non-reputable way, let's say. I mean, the provider of the data gives the description, gives them the data, and everybody is certain that this is the case. And also this ensures data sovereignty, which means that the provider can be certain that his or her data will not be appropriated by some other entity. The aim of including data governance in data ports is to provide a secure platform for defining data sharing rules, and in trying to, in the beginning of the project, in trying to figure out what would best suit this endeavor, it was quickly realized that blockchain technologies is a very strong candidate for this type of framework. And the reason is that there are the features that blockchain offers are easily adapted to our needs here. So it's easy to define data ownership within a blockchain network, and we can easily have an agreement between the participants on the data distribution policies, which is the key issue of data sharing. The features of blockchain that make this make it so attractive are summarized. I mean, some of the main features, let's say, that support what I said are summarized here. So we have a shared ledger. That is the basis for everything. This is an append-only system of records, which is shared across the network. Every participant in the network has a copy of this ledger, and no one can alter this ledger by themselves. Any attempt to alter it is detected by the system itself, and it's rejected. This main feature offers full provenance, so we know every transaction, where it came from, when it was done. We know the full the entirety of the transaction's history. It offers non-repudiation, so nobody can later say that we did not do this or that. It's clear who did what. It offers transparency and traceability, and it's a single source of truth for everything that goes on the network. The second technology on the top, on your top right, is the smart contracts, which are business terms to which all participants in the network agree, that are encoded as computer programs. So whenever there is a transaction going on, there is a program, a smart contract, which is a program that is called to carry out this transaction. So every time a particular transaction happens, it happens with the exact same way, with the exact same rules that were agreed upon at the start of the network, and there is no way that this contract can be altered. Again, the same as with transactions, any alteration will be detected and rejected. Unless, of course, there is a consensus. That's the main feature below the smart contracts, which is a critical number of participants agreeing that a certain thing should change. And there are various algorithms that can be used for consensus. The main idea is that there's always a threshold above which decisions are valid. So if, let's say, some protocols might need 100% participant agreement. So all participants must agree on a change for it to be valid. Or there could be a 50-50 rule, or whichever other percent is suitable for the situation. This consensus idea is also what drives transactions. So for transactions to be passed on and encoded in the ledger, they have to be also agreed upon by all participants based on a consensus algorithm. And finally, we see that the main feature is privacy. All transactions are secure, authenticated. There is a built-in identity mechanism. Every participant has a unique identity within the network, so everybody can be certain that a transaction was made by this or that participant and no other. And transactions happen within a channel, which is a group, let's say a sub network within the network, where participants from a certain, let's say, consortium have their transactions. on a given network, there might be tens or hundreds of channels. So a channel is a way of ensuring that the participants will have their own space, let's say, within the network to carry out their transactions, and you can even have even more privacy by having private data on a channel, but that might be getting a bit too technical. But privacy is the last of the main features that I want to talk about. Now, when we talk about the blockchain in the business process, it's useful to see what came before the blockchain technology, what was the state of affairs before the application of blockchain, and what happens after we apply blockchain technology. So, before the introduction of blockchain, we see that that each participant keeps their own ledger. These ledgers are updated separately, so it's expensive to keep them in sync because everything is duplicated, and also there are intermediaries adding margin for their services. So more complex, more expensive. It's also more inefficient because the business conditions, the contract that I was mentioning as part of the blockchain, which is there, it is a computer program. In any case, the business conditions which must be there in order to have any type of business network are duplicated for every participant, so this is quite inefficient. And it's also vulnerable because if one of the points that make up the business network fails, for example, if a bank system is compromised, the whole business process suffers from that. Now, in the case of blockchain, we have a solution that is comparatively inexpensive, since there is only one conceptual ledger. Each participant has to set up its own peer or peers. These are nodes, computers participating in the network, but that's done in the beginning once, and you don't need any special, let's say, maintenance for it. Not more than you would need for any server that you might have, for example. So it's set up once, and it participates in the blockchain network, and that is comparatively inexpensive than having to rely on external systems that could possibly fail or be compromised, and so on and so forth. And also try to it's inexpensive in the sense that here you don't have to try to sync your ledger. It's automatically synced because of the way the system is set up. Cryptography. 3 more minutes. Cryptography is used to ensure the network participants see only their part of the ledger. And we have provenance, immutability, and finality. The maritime has certain challenges that come with that domain. Data are in silos, information is exchanged in a bilateral manner, processes are time-consuming. This is mostly manual in nature because of the nature of the people involved in that. Some of them might be port workers. They might not have any, special affinity with technology, so many of that work is manual, much of that work is manual. So the impact of blockchain in maritime is quite big. And we can see in general, I won't go into much detail here, but in general you can see that we move from a mesh of interconnections to one big network of strictly defined relations and well-defined relations. The position of the data governance platform in the Dataports platform is the red boxes up there. They're the ones that data governance is the framework that analytics and data process services use in order to get to read, let's say, the permissions that each user has on a certain data set. So somebody wants to use a data set for analytics. Okay, what's that person's permissions on that data? Does he have the permissions to read the data set to use it for analytics? If yes, data governance says it's okay, and the process continues. Same for data processing services, which are the ones that actually read the data set from its original source. The technology we use are Hyperledger Fabric for the blockchain network, the Fabric SDK for Node.js, the storage is CouchDB, and we write smart contracts in the Go language. The architecture is a classic Hyperledger Fabric architecture with the channel in the middle. You have provider, consumer, and organizations using the channel, and also the other Dataports platform components also using data governance, as I mentioned earlier. And you have the two ports, THP and the Valencia Port Foundation, the Port of Valencia, that are the main the main constituent parts of the network. So they have their peers, ordering service, and certificate authorities, and they also provide through them external organizations can get access to the network. And this is the last slide. As far as the verticality, let's say, of the solution goes, we have on the bottom we have the Hyperledger Fabric with the ledger and the chain code as the basis, as the back end. Then we have our middleware built in Node.js using the Fabric SDK to talk to the chain code, and also presenting a REST API to the various front ends that might be. And the front ends are what the users use to get dataset metadata, to get and define access rights on datasets, and so on. And I think I'll stop here. Thank you very much.
Thank you very much, Alexandros. If there is any question.
Just a general question about the implementation and applicability of blockchain technologies. In the specific example, do you face any difficulties regarding the implementation, or apart from the technical implementation, are there any financial constraints, or we may say it's a normal situation, a usual example of implementation of these technologies into a wider framework to serve the specific aims of the Dataport project?
Okay, the framework itself is open source, so there is no, with respect to its adoption, there is no economic setback, let's say. Using blockchain technology could be somewhat daunting for smaller companies, because, as I said, they have to set up a peer and in order to participate to the network, and that could be technically challenging for a small company. So they would have to do it through a technology provider, let's say, for example, CERT, as we're doing with THPA, with the Port of Thessaloniki. But I think these are this is something that can be overcome very easily and is overcome in this situation, because there are partners, there are entities that can provide this sort of technological help, let's say.
Thank you, Alexandros. Now it's time for the last presenter, Mr. Achillas Marinakis from NTUA ICCS.
I would like to thank you for the invitation and the opportunity to talk to this conference. My name is Achillas Marinakis, and I am a research engineer from the Institute of Communication and Computer Systems, which is affiliated with the National Technical University of Athens. I'm going to present the data processing and interoperability services that we implement in the context of the data ports project. So this is the overall architecture of the project. It is the same picture that my colleague Alexandros showed before, and with red color are highlighted the functional components that compose the data processing services layer. These components are the semantic interoperability, the data access, and the data abstraction and virtualization. All these components are going to be analyzed in the next slides. Starting with the semantic interoperability, its scope is to define an unambiguous way to interpret the data that are being exchanged between computer systems in order to simplify the reuse of data within the smart sports domain. One of the lessons learned during data ports is that enabling interoperability is a very difficult task, simply because different organizations and stakeholders within the smart sports domain do not follow a common standard. Instead, they have their own vocabularies with poor definition of semantics or no semantics at all. In order to facilitate interoperability, we put a lot of effort to try to describe and model the port's data in a systematic and standardized way. The first step of this data modeling process was actually to identify and analyze the different data sources that we had to deal with and integrate in the data ports platform in terms of the meaning and the format of the data. And secondly, we carried out a state-of-the-art analysis and review of the existing ontologies and vocabularies that appear in the literature for potential reusability. The tangible outcome of this data modeling process is what we call the data ports common data model, which I will present now. some information about the common data model. It is based on 5-ware smart data models guidelines and is also fully compatible with other European standards and initiatives. So we have the root, the smart spots domain, which is then divided into many subjects, each one of which contains many entity types. This is the complete picture of the Dataport's common data model. With a blue color, you can see the different subject, and with a green color, you can see the different entity types. The representation of each one entity type is described using JSON schemas. After defining the Dataport's common data model, the next step was, the next challenge was actually to connect heterogeneous data sources to the Dataport's platform. For that reason, we have implemented the so-called agents, which are scalable software components that retrieve the data from the data sources, translate them into the Dataport's common data model, and finally make them available to the processing layer via a unified API. Two types of agents have been developed. The on-demand agent, which is responsible for retrieving historical data, which is depicted in this figure, and the public subscribe agent, which is responsible for providing real-time data. Τώρα, καλύτερα. Ωραία. Thank you. Once the data are the translated and once the data, the translated and harmonized data are available by the agents, the next step was actually to offer this data as a service, putting special emphasis on the quality of the data and the quality of service. This is achieved through the data abstraction and visualization middleware, or briefly DAV, which let the application developers simply define the content and the format of the data they need, and then just rely to the proposed middleware in order to retrieve those data regardless of the underlying technical complexity. As can be seen in the figure, DAV is composed by 3 subcomponents, which will be analyzed in the next slides. The first subcomponent is the preprocessing and filtering software, which is responsible for the initial preprocessing, cleaning, and filtering of the incoming data. Typical preprocessing techniques are being performed at this stage, like removing all the white spaces from the string values, remove the duplicate records, filling the missing values, or detecting outlier values. The goal of this subcomponent is to improve the quality of the data, which clearly affects the performance of the data-driven applications that are built on top of the data. The next subcomponent is the virtual data repository, which is actually a distributed infrastructure to store this preprocessed data. It is a data lake that is capable of upscaling and downscaling in a fully automated way based on the incoming workload in order to achieve resource optimization, low response times, and high availability. Finally, the next subcomponent is the virtual data container, which is actually the interface between the middleware and the data consumers, which in our case is the analytics component of the Dataports platform. Its role is to further process, filter, and then serve the data as data points by applying specific filtering rules to the datasets, and then transform the data to the desired format like JSON, Parquet, or CSV. Some more details about the filtering rule system that we implement. Its goal is twofold. On one hand, to enable the consumer simply retrieve only the portions of the data they are interested in, and thus to minimize the processing and the network workload. And on the other hand, to detect and remove obvious wrong values most probably caused by sensor malfunction, like for example, abnormal temperature values. The syntax of the filtering rule system follows the subject operator object syntax and is kept simple on purpose so that the rules can be specified not only by data scientists or experts, but also from users with limited or no technical background. And in the end, what we actually offer to the data consumer is a common access layer through which they can simply define queries in the form of rules in a unified format, and then they rely on the VDC designer, the provider of the data, to develop all the necessary software in order to execute those queries according to the selected storage technology. For example, in the case of Dataports, the storage system is based on MongoDB, but it could be easily adopted a relational database or even an object store system. The filtering rules system, even in those cases, could be easily applied. So thank you for your attention. Any questions, please?
No. Thank you. Thank you very much, Achilles. This presentation concluded the Dataport session, what Dataport project is about. We try to present you both business and technical aspects of the project. We believe that we set the floor for secure and trusted data sharing that could enable the seaports transformation of the future. Thank you very much.
So good afternoon, ladies and gentlemen. We will now pass to the third intern session, actually, which is about investigating machine learning opportunities in the 5G and beyond era, based on the scope of the Marshall Project, which is one of the most innovative, let's say, frameworks promoted by the European Commission towards fulfilling this specific aim. The first presentation will be given by Dr. Alexandros Kostopoulos from the Hellenic Telecommunications Organization, OTE, one of my best colleagues and also technical manager on behalf of OTE in this project. Alexandros will present the entire framework, and then we have some subsequent presentations towards looking deeper in the Marshall innovative attempt. Alexandros, the stage is yours.
Thank you, Yannis, for the introduction. Good morning, everyone. We will start with the first presentation of the Marshall Project, which is about machine learning based networking and computer infrastructure resource management for 5G and beyond networks. And this is a presentation from Ioannis Kochliouros and me from OTE. Just a brief outline of our presentation. I will talk about Marshall Project at a glance, as well as some motivation, the motivation part of our project. Then we will proceed with the technical objectives, our methodology, our major innovations so far, as well as our current use cases and experimentation scenarios with their corresponding requirements. Regarding our project, we are on the topic 5GPP smart connectivity beyond 5G. The duration of our project is about 3 years. Now we are at the end of the second year of the project, and the overall budget is around 6 million euros. So we have 14 partners from European EU member states, and the project coordinator is iQuadrat. Regarding the motivation, as in most of the 5G projects, because we do all have the same needs regarding the evolution of 5G and 6G networks, is to support all types of applications and a massive number of end users. So in this complex ecosystem, our main goal is to provide an end-to-end performance analysis and optimization in order to employ and adopt these solutions by multiple vertical industries over the same shared infrastructure. In this slide, we present the main objectives of our projects, which include the development of massive MIMO networks, the compliance with ORAN Alliance architecture, the design of SDN control plane towards fixed mobile convergence, which is very important for us in order to have efficient use of the available resources. We focused on elastic edge computing paradigm, and also we focus on privacy and security related domain for enabling trust in multi-tenant infrastructure. Of course, we employ several machine learning mechanisms. Also, all our innovations will be demonstrated via proof of concept and experimentation scenarios, and of course, a set of dissemination and exploitation activities. Regarding the technical objectives, apart from ORAN Alliance, we focus on the provision of a 3-layer network architecture with the different RAN components. the design of interfaces among the Marshall entities in order to provide cell-free support. Of course, functional requirements for front-hauling technologies and definition of new interfaces for coordination among the distributed units. Specifications for virtual elastic infrastructure, including mobile edge computing system, software-defined networking control framework, and machine learning-driven automation. Part of this, of course, is the mobile edge computing platform using the existing cloud-native frameworks. Requirements for analytic and decision engines for software components, and of course the specifications of machine learning and blockchain technologies in order to enable trust in multi-tenant environments to support network slicing capabilities and so on. Our methodology, of course, we start with a set of data that are generated. The first phase of our project includes the design of Marshall use cases, KPIs and specifications. The second phase has to do with the innovation design, including 3 different technological pillars, like the network design, the elastic infrastructure design, and the security innovations design. The third phase has to do with testing and evaluation across all these domains. And the last phase is focused on the integration and the proof of concept. Our major innovations so far include the definition of requirement specifications and KPIs for the following scenarios and proof of concept. The first one has to do with cell-free networking in dense and ultra-dense hotspot areas with 2 experimentation scenarios that will be presented in a few slides. And the second one has to do with cognitive assistant and its security and privacy implications. Regarding the functional and non-functional specifications for virtual elastic infrastructure, we focused on computing and networking infrastructure, optical mid-haul support for fixed and mobile convergence, mobile edge computing management for 5G and 6G networks. And here the focus has to do with the coordination of the available resources for MEC applications, the support of the disaggregation of application functions both horizontally and vertically, as well as the management of the available resources through a cloud-native approach. Regarding the analytical part, let's say, our algorithms focus on virtual network embedding, inter-data center load balancing, resource optimization on converged infrastructures, and analytic mechanisms. Regarding the security and privacy domain, our focus is on the design of a decentralized framework for confidentiality and direct contracts in beyond 5G networks, the design of policy-driven, secure, collaborative computations and distributed storage in multi-tenant infrastructures, which is very important for us because we have a set of available resources that should be allocated in an efficient manner, as well as machine learning and hardware accelerated slice security mechanisms. The first experimentation scenario has to do with the deployment of cell-free networking in 6G networks with massive access point deployments. So here we focus on aspects related to dynamic adaptability and coordination, the design of cell-free enabled distributed units, max scheduler, and the physical layer as well. The modification of control plane protocols and ORAN specified interfaces, the hybrid MIMO front-haul solution, and in order to consider this scenario, we assume representation of an indoor-outdoor event with a high number of users and access point densities, with the user-generated content, and the real-time consumption by the end users using a mobile edge computing platform. The second experimentation scenario has to do with the fixed and mobile convergence. And here we assume two different fixed network segments dedicated to X-Hall. So we have front haul based on WDM transmission technologies, as well as back and mid haul based on point-to-point and point-to-multipoint technologies. And here again, the representation of an indoor-outdoor event where we assume users that are connected to servers that can stream video, and fixed clients can be also served by the same infrastructure via point-to-multipoint links, sharing the same capacity with the radio edge node. The second proof of concept has again two experimentation scenarios. The first one has to do with the cognitive assistance and smart connectivity for next generation sightseeing. Here we consider two different applications. The first one has to do with the real-time video analytics and visual guidance. And the second one with cognitive assistance, virtual representation of artifacts projected at augmented reality glasses. So you can imagine a use case focused on tourism, for example, using AR glasses. And here we consider aspects related to load balancing, lighten the network burden of augmented reality applications, how we will create different slices in the network in order to be compliant with the different SLAs, since we assume that we have different applications running at the same time. And then, as a next step, we focus on the same use case, but we consider mechanisms related to security and privacy in multi-tenant infrastructure. So, in general, we consider different layers of data security and privacy. One has to do with information sharing among the different tenants, because it's very important to assume that there is trust among the different partners and entities. Legal security using smart contracts. Security, of course, for the data that are stored in the cloud. And, of course, the end users' security. Now, regarding the requirements, which is the next step after the design and definition of the use cases, is the analysis, of course, of the existing technologies, the definition of functional and non-functional requirements, and some selected indicative requirements include event detection mechanisms, optimization based on different criteria, as well as decision and analytic engines. Regarding the privacy and security domain, some indicative functional requirements include the availability of the smart contracts and atomicity, the data ownership, the data generated that should be encoded but directly useful for machine learning tasks, aspects related to privacy, preserving data representation, and of course the size of the output in order to be configurable. So these are some indicative requirements which, of course, are revisited during the whole project. Similarly here, requirements about data policies and network security. For example, that the data stored outside the premise of a trusted party must be encrypted. On the other side, regarding the network security, the system should learn from the user sessions, etc. So, in order to employ and adopt machine learning mechanisms. So, thank you for your attention. We will proceed with the next presentation, which will be focused more on the KPIs that we have defined so far about Marshall Project, and then a technical presentation about Marshall architecture and elastic infrastructure that will be presented by ICCS. So, thank you very much.
We will pass to the next presentation. I will give the next presentation and then the other two speakers, and potentially, because there are some issues that from one presentation to the other are covered, maybe if there are any questions, we can have the questions at the end of the session, because I have the feeling that if somebody asks something just right now, this may be answered when we discuss the architecture or later, just for the economy of time, if there is no objection by you and the other partners.
Okay. We'll pass to the next presentation. B11. Okay, ladies and gentlemen, thank you for your participation to this Marshall dedicated session. In particular, what we intend to discuss via these four dedicated presentations is the progress and the innovative scope coming from the Marshall Project, which is among the few ones addressing the challenge towards formulating the network in the 5G and beyond era. So, as a complementary to the previous presentation, we will now try to discuss and provide some information about the KPIs, which is actually the evident, the key performance indicators, those measurements that will allow us to assess the efficiency and the applicability of our proposed solutions, of course, in the scope of the prescribed proof of concept. This has been jointly prepared by me and Alexandros. However, I have noticed that in the project only my name is mentioned, and I apologize for this, although it is not under my, let's say, scope of responsibility. So we have seen previously the project. I can pass this slide. I suppose we will see it again. Just to remember that we have 14 partners from 9 European member states and a very experienced project coordinator, I Quadrat from Spain. Just some introduction briefing. We have the 5G opportunities that actually modify very profoundly the mobile networks as a whole entity with an evolved approach architecture. And 5G adopts also edge computing as a key paradigm, involving a lot of potential architectures. We have the Open RAN initiatives that have a key role in this sort of evolution. However, if we consider these technologies, up to now, of course they have been developed, but in a separate way, one to the other. The same also stands for algorithms that do not only run in the cloud, but so optical and wireless links cannot be abstracted in the same way. So we have a challenge here to rethink the architecture and the related algorithms and propose some, yes, okay, propose some solutions. The positioning, we have application traffic flowing from and towards the end users and the end devices, and we utilize a diverse set of involved wireless and optical technologies. We have a variety of involved infrastructure, and we have to consider the fact that there is a necessity for exploitation of key technological development in order to structure a new infrastructure model which will have these two essential features.
In this model, technological infrastructure blocks will be transparently and flexibly replaced by others, and this will be done while offering similar networking on other computing offerings and control with related monitoring capabilities. So here actually comes the challenge from the Marshall Project, where we consider the option of proposing a new sort of infrastructure able to support multiple distributed edge nodes and a huge number of access points, a new unified and hierarchical infrastructure in order to provide intelligent management and also to include machine learning algorithms and artificial intelligence features, and of course, multi-tenancy, which is something which is strongly relevant to the competitive nature of the market. So here comes the project, a new paradigm of elastic virtual infrastructures. It actually provides a new architecture towards 5G and beyond, which proposes and offers significant degrees of flexibility and closed-loop autonomy and improve spectral efficiency via self-free networking from the technical point of view. This is a quite important concern because we consider three pillars that affect not only the proposed new architecture, but also the KPIs that will be discussed in the following parts of my presentation. Alexandros has presented previously the two proof of concepts, just to have this in mind, because the related KPIs are, of course, relevant to the two POCs. And we start our dedicated presentation about the KPIs. The first one is about resource utilization. It is about resource utilization of host and data centers according to those included in the cloud, regional, and edge domain. It is expressed in terms of computing, storage, and networking of the involved host and data centers. It is measured in the physical, virtualized, and containerized function across the different network domains related to both. And it is efficient for high-demanding use cases where it is practical to share effort by considering the involved hosts, also including the MEC option. So this is the first one. The second one, it is about the scale-out latency, the scale-out of containerized application functions. This practically, as a definition, refers to the time necessary from submitting the order of creating a containerized function to the deployment of this function. So it investigates how to achieve the optimal latency budget through the MEC orchestrator in our platform, and it is measured from the master node of the cluster managing the containerized function, for example, by considering the Kubernetes mechanism. And it is relevant to the challenge of providing latency for time-critical use cases like AR, augmented reality applications. The third one, which comes also according to the definition of the pillars I mentioned before, is the computing resource utilization, which practically means percentage of the available processing and storage virtual elastic resources consumed by the MEC applications. The target here is to investigate how the use of the virtual elastic data center resources can be increased through extension to the MEC system, and it is measured by computing resources, according to the definition, placed at the edge nodes. So this is another option of having an assessment of the way how the new architecture scheduled to serve the two POCs actually works. The next one we have defined in the project is the communication network efficiency. It is the network efficiency in terms of communication resource utilization and latency, something more generalized but efficient and effective at the same time. It is practically the way to which we use the active communication resources and the introduced latency. How we measure this? By using communication resources that are available at the access and transport part of the network. And here, for example, this can be used for time-critical applications below 1 millisecond. This is the specific, let's say, aim of introducing this extra KPI. Then we have a more generalized one because we have mentioned that spectral efficiency is among the key targets of the Marshall Project. So this is relevant to the spectral efficiency, system spectral efficiency per user. This can be measured as a sort of information rate transmitted over a given physical resource block of the considered cell-free MIMO networks at the radio age. It investigates how actually what we call as a feature of spectral efficiency can be maximized, while simultaneously we optimize the radio resources of the radio edge. How we measure this? By using radio resources, once again, at the cell-free MIMO access points available at the radio edge now of the related architecture. The various parts of or edges of the architecture are relevant to the dedicated KPIs. We also have the frame loss, which investigates how the frame loss in the transport network equipment can be lowered to a minimum. It is measured at the transport network equipment using a traffic generator and analyzer. And passing to what we have mentioned before, according to the three essential pillars, we have some KPIs related to data privacy listed as here, the tenant data privacy, the smart content latency, and the smart contacts throughput. All these are defined here and are relevant, of course, to the data privacy, but also to the way how contracts based on privacy and SLAs are established between the involved actors. So I think that's all. This is my presentation coming as a complementary to the essential one previously given by Alexandros. All these are strongly correlated to the proof of concepts previously mentioned and described. And the scope or the basis for defining these KPIs actually comes from the three essential pillars that we will also see in the next presentations, as I expect. So, as I said, I would like now to invite the next speaker, Dr. Konstantinos Ramandas, on behalf of iQuadrat. They are the coordinator of this project, and we are quite happy working with them.
Thank you very much, and I do appreciate the invitation. So, thank you. So, hi all. This is Kostas Ramantas, and I am presenting this on behalf of John, who is the coordinator of this project but couldn't be here today with us. Okay, thanks. So, this is the overall architecture of the project. I think this was not previously presented. And some overall context about the idea of Marshall. So the European Commission announced the so-called beyond 5G calls to try to shape, let's say, some candidate technologies for 6G, so going beyond the 5G standard. So the Marshall Project actually proposed some of these beyond 5G techniques. And the core concept is cell-free networking, which we'll explain later. And also many innovations in the network design, including the radio access network, the transport network with the fixed mobile convergence paradigm. Also innovations at the edge with the so-called virtual elastic infrastructure paradigm, which basically proposes cloud-native technologies for the networks. And there is a presentation right after mine. And then also proposed innovations for the network security design. And all these to be applicable in the next generation of networks, the 6G networks. So the main insight of Marshall was that cell-free networks are very promising. In case you don't know, cell-free networking is a form of massive MIMO. But while typically massive MIMO applies to just one base station where you can have multiple antennas, even our cell phones have multiple antennas, cell-free basically scales this concept to a large number of base stations. So instead of just coordinating a bunch of antennas, you now have to coordinate the antennas of a massive number of base stations. And if you manage to do this, you basically increase the spectral efficiency a lot, because you avoid some problems like the cell edge problems. Typical networks do not have such a good performance in the cell edges. And also you can basically perfectly cancel the interference if you can basically coordinate the reception from all base stations of a network. Of course, the problem is that this is not scalable, because you have to coordinate the transmission from all the base stations in a network in a centralized unit, which is called a CPU. So there were actually two, not just one, European projects that were trying to build some practical cell-free networks. And the insight to build practical cell-free networks was, instead of using a centralized element from all your network, to try to basically coordinate only the neighboring base stations, those that are on the same neighborhood. So for example, here, you would only coordinate these base stations, and maybe these base stations, but not all of them on a central unit. So basically, the main insight of the Marshall project is this distributed cell-free coordination. And instead of having one single CPU, you have multiple DUs. Another innovation of the Marshall project is a front haul, which is based on hybrid MIMO. Typically, the front haul is based on fibers, and it connects the base stations or the radio units with the backhaul, but Marshall uses millimeter wave. And the innovation here is that beam forming and beam steering is supported, so you can basically change your topology on the fly through these hybrid beam forming techniques. And another major innovation of the Marshall project was that it proposes the alignment of the cell-free concept with Open RAN. Open RAN is a way to architect 5G networks, but also beyond 5G, in a way where your components are not hardware, but they are basically software. They are virtualized functions, which can be deployed on commercial off-the-shelf servers and accelerators. The main Open RAN modules are the DU, the distributed unit, and the CU, the central unit. So Marshall proposes the cell-free DU to be mapped with an Open RAN DU, so that your cell-free networks can be deployed in an actual environment. So, as mentioned, there is another project which is doing distributed cell-free, but Marshall was the only project which was actually promised to deploy cell-free, distributed cell-free, in an actual 5G architecture and is mapped with Open RAN. So we are building basically a cell-free DU. This is one of the major outcomes of Marshall. A cell-free DU, which is also integrated through some special APIs with the rest of the Open RAN architecture. And actually, Marshall has proposed some extensions to the Open RAN architecture to accommodate for cell-free networks. Marshall is also working on the so-called fixed mobile convergence paradigm, which allows the telecom operators to manage their wired and wireless clients from the same network management system. So, for example, your fiber to the home deployment and your 5G deployments are served by the same 5G core, the same network management system, so you don't need to keep two separate systems or different billing systems. So this is basically a centralized system. So Marshall proposed a distributed fixed mobile convergent system, and again tried to map this fixed mobile convergent system to the ORAN architecture. So in the spirit of Open RAN, we have the Open RAN orchestrator here, which is responsible for the orchestration of the various network domains and the various SDN controllers. So if we go a bit deeper, 5G networks are associated with slicing, where slices are some dedicated, let's say, network connections with some dedicated resources. So Marshall has proposed a solution in the spirit of fixed mobile convergence with all these distributed software-defined network controllers in each domain, and each one of them is responsible for managing a sub-slice that is the specific technological domain. So we have an SDN controller for the radio access network, an SDN controller for the transport network, and an SDN controller for the fiber to the home network. And all this is orchestrated by a centralized orchestrator, which of course is not operating in real time. And then in this architecture, Marshall, because it's a machine learning based architecture, is proposing some closed loop operations that use machine learning to control the slice allocation, to control the scheduling. So all these SDN controllers basically internally use some very fast loops with machine learning algorithms to perform, for example, load balancing and to perform various end-to-end operations and slice optimization. Marshall also proposes some enablers for security. I'm not going to go very deep in this, since this is not really something that we are doing. And I think we don't really have a dedicated security presentation today. But in very broad terms, we have some blockchain technologies in Marshall and some smart contracts for keeping track of the slices and potentially being able to trade slices. And we have some policy languages which allow the owners of data being exchanged in the network to specify how this data is going to be shared and how this data is going to be accessed or even sold in a platform, and what kind of rights you have in this network. And finally, there is a very interesting work stream which is undertaken by Mellanox, and they implement some machine learning based algorithms for threat detection, and these algorithms are actually deployed at the network equipment, the network switches, the routers. So they basically implement some kind of a perimeter in the network, and the perimeter is implemented directly at the network appliances. So if you have some threats, the idea is that those threats will be blocked at the perimeter of the network directly by the appliances. And there is also the concept of a fusion, engine, which coordinates any threat signals from multiple such appliances. And some general information about the Marshall project, which is, as mentioned, now in the second year. And this concludes my presentation. Thank you very much.
Thank you so much, Kostas, for the presentation. We invite the next presenter, Dr. Polizois Soumplis from NTUA, the National Technical University of Athens. Thank you for joining, for your presentation.
Thank you for inviting me. So hello, my name is Polizoi Soublis. I'm a postdoc researcher at the National Technical University of Athens, and today I'm going to present about the key role that optical networks play in this virtual elastic infrastructure that is used by Marshall in order to provide a communication and computation infrastructure. So, over the last decades, optical networks have played a crucial role in improving the communication aspects. They provide high capacity and they enable the correct communication among different participants. So one could ask what to expect next. Optical networks are right now transforming our society in our digitally driven future, and developments are happening at the speed of light for emerging applications such as edge and cloud computing. They transform also data centers. They provide high capacity for transport networking for 5G and beyond networks like those that are present in Marshall, and also improve the broadband internet that we use in our everyday life. So, what's the role of Greece? Greece has become a key player in ICT infrastructure. Fiber to the home and fiber to the cabin installation increase and are expected to increase in the following years, while also submarine fiber optics cables in the Aegean and Ionian Sea are increasing. So, Greece is transforming to a hub of international subsea cables through respective cable landing stations, and also data centers are implemented at the suburbs of Athens by major providers such as Google, Microsoft, Amazon, Lambda Helix, and Lanco. Beyond the business developments, several research challenges also arise. These involve the design and the optimization of the ICT infrastructure that operate in the cities towards a virtual elastic operation. Users consume and generate data at a great pace, utilizing popular online services, Internet of Things, and smart city applications, which have increased requirements both in computing, storage, and networking resources. So, smart cities are becoming the main data source, and service providers, to address the issues that are present, tend to push more and more content, data, and services as close as possible to the end users. So, that edge computing paradigm was created, which is a computing paradigm that brings computation data storage closer to the source of data. In order to, as the capacity of the resources is limited, in order to address the issues that are present, it is required the elastic operation that can bring several advantages for the applications, such as decreased latency, decrease in bandwidth use and associated monetary cost, decrease in server resources and associated monetary cost, enabling data processing with zero perceived latency. As I said earlier, the resources are limited, so the model changes from a centralized to a distributed one, in which data move across the different layers, either horizontally in the same layer, or vertically from the edge to the cloud, for example, and vice versa. This distributed operation increases the complexity, but also the complexity further increases by the multiple resources with heterogeneous characteristics. In the edge can be found, for example, CPUs, GPUs, mini data centers, RAM, storage nodes, HPCs, and devices that enable acceleration, such as FPGA, ASICs, that also provide approximate calculations. So this requires
this, along with the application requirements that change dynamically with time, requires the resource orchestration mechanism to enable efficient data movement and resource allocation. Of course, this cannot be done without telemetry mechanisms that support this operation in an automated manner. Cloud-native applications can enable this distributed processing since they consist of container-based microservices. That it means that an application is broken into smaller parts called microservices, each one with its own computing and networking requirements that are set among the different microservices. This enables the execution in partial isolation within the host operating system, and it is enabled by the containers that allow apps to be packaged and isolated with their entire runtime environment. So it is easy to move them between environments while retaining fully functionality. And do not include a full copy of the operating system, and thus higher container-to-host deployment ratios are achieved, offering a greater elasticity for the virtual elastic infrastructure that is utilized by Marshall. But of course, this operation requires the development of appropriate resource allocation mechanisms that address the varying with time demands efficiently. We have formulated this problem as optimization problems where different constraints are taken into consideration and different objectives. The objectives are mainly conflicting. For example, the delay, that is the minimization of latency of an execution of an application, and the cost, because edge resources are more scarce, which means that they are more expensive, while cloud resources take advantage of the large scale and can provide lower cost. This also happens for the networking cost that is introduced, which for the edge resources is higher, while for the cloud resources taking advantage from the high transmission transponders is significantly lower. We formally describe these problems as mixed integer linear programming problems, which include all the constraints I described earlier and the different objectives. As we have seen from simulation experiments based on real data, the incorporation of edge resources in the execution of the application offers several advantages. For example, latency can be decreased about 50% when only the edge is utilized compared to only the cloud or mainly the cloud. And applications take advantage of these resources that can be near or far of the generation point. Of course, the edge does not transform only the application execution, but is also leveraged by mobile networks, especially for 5G and beyond networks, such as those in Marshall project and the cell-free concept, which requires distributed calculations in order to achieve the highest spectral efficiency at the axis. It offers other advantages, as I said earlier, lower latency, optimized network efficiency, reduced network congestion that can further increase the utilization of the network and also bring higher profit to the network operator. Without the mobile edge computing, use cases such as autonomous vehicles, mobile gaming, and IoT could not happen because the latency for transferring the data from the edge to the cloud will be prohibitively large. Integrated fiber wireless communication, as we said earlier, play a crucial role, and we have formulated the respective problems where we examine it as an optimization problem in which we require the availability of optical and wireless resources so as to serve the user requirements using just enough of the available resources in a flexible and dynamic manner. Again, we have described this respective problem as a mixed integer linear programming formulation with several constraints that are introduced by the different domains, the optical one and the wireless one. Yes? Yes, later on, let me finish my presentation.
All these will be uploaded, all presentations will be uploaded by the end of the event in the dedicated website, so you will have the possibility to access the material from there.
Resource orchestration mechanisms are not enough to enable the dynamic operation. Their operations needs to be supported by respective telemetry mechanisms. These telemetry mechanisms need to be able to do it automatically, so as proactively or reactively re-optimize the network, doing the appropriate adjustments. For this reason, machine learning and artificial intelligence play a key role for network telemetry mechanism in order to provide load predictions, detect performance degradation, and provide recommendation actions. We have followed an approach in which we leverage knowledge graph because it's a way to incorporate, to include more information regarding the infrastructure in a compact form. We should not forget that there are many parameters that are taken into consideration, and knowledge graphs seem to be the best solution for this. And also we leverage machine learning tools such as graph embeddings and anomaly detection schemes to enable the detection of events. When these telemetry models are combined with the respective resource allocation mechanisms, advantages are provided both to service providers by modeling the dynamic aspects in a measurable way and maximizing the overall resource efficiency while facilitating the implementation of complex billing models by forecasting the capacity needed to accommodate future demands. On the other hand, for the user perspective, it maximizes profit while ensuring quality of service requirements. Also, it offers an additional layer of protection against adversarial attacks. Here I conclude my presentation. Thank you for your presence.
Presentation. We may be able to conclude the Marshall session unless there is any question. If not, I will set a question to Alexandros and Kostas potentially regarding the next activities of the project, the aims, and towards having an applicability in real market scenarios, how you estimate you will realize these actions?
So the project duration is about 3 years. Now we are at the end of the second year of the project. We focus so far on the use case design, the requirements, the KPIs, as well as the edge cloud resource mechanisms and the privacy and security mechanisms. So, of course, the technical work packages are ongoing, and during the last year of the project, we focus on the evaluation, on the demonstration of the proof of concept, as well as on integration part, which is a very challenging part in all these projects, not only for Marshall, but for the Horizon 2020 projects. And we will also focus on the business and market aspects in order to see how the Marshall solutions from a technical perspective could be translated, interpreted in a business model, and how this could create new profits for all the involved stakeholders, including the telecom operators.
Okay, thank you. Okay, thank you. I would like to thank once again all presenters for their support, for their warmth coming to this event. And we will now have a short 5 to 10 minutes break, and we will pass to the next session, which will be about advanced 5G application trials for market verticals, the fourth intern session in today's workshop. Thank you once again for your attention.
Καλησπέρα στο αγαπητό κοινό. Πριν περάσουμε στα αγγλικά, θα ήθελα να ευχαριστήσω όλους τους παρευρισκόμενους για την παρουσία τους σε αυτή την τέταρτη κατά σειρά ενότητα. Όπως εξήγησα νωρίτερα, επειδή σε κάποιες ενότητες υπάρχουν ξένοι ομιλητές από τη μία πλευρά και από την άλλη πλευρά υπάρχουν και απαιτήσεις από τα ευρωπαϊκά συμβόλαια για ευρύτερη διάδοση των αποτελεσμάτων. Υπάρχει βίντεο το οποίο, αν είναι στα αγγλικά, θα μπορεί να είναι προσβάσιμο από πολύ περισσότερο κόσμο. Θα ήθελα να είμαι σαφής κάθε φορά. Αυτός είναι κυρίως ο λόγος που ζητάμε από τους ομιλητές παρουσίαση στα αγγλικά. Δεν έχουμε κάτι με την ελληνική γλώσσα, την οποία αγαπούμε και εφαρμόζουμε επιμελώς, ειδικώς και στα θέματα ορολογίας εγώ προσωπικά. So, ladies and gentlemen, now we will pass to the next session, which is about advanced 5G applications and trials in market verticals. It comprises presentations and results coming from 3 European projects, the 5G Tours, then we will see the 5G Heart, and finally the 5G Victory projects, which all formulate a framework for KPIs around dedicated verticals, in particular about investigating enhanced mobile broadband, massive machine and type communications, and ultra-reliable low-latency communications. Now we'll give the stage to the first speaker, a friend of mine, a colleague from OTE, Dr. Verisarios Gezerlis. He will present the 5G Tours project.
Thank you very much, Ioannis, for the invitation. I'm Dr. Verisarios Gezerlis. I'm from OTE, from the research labs of OTE, where we are responsible for a lot of 5G projects, European projects, and we are also responsible for a 5G Greek site, which is installed and implemented at the OTE facilities at Psalidi. I will present you results from European project, the 5G Tours. The 5G Tours is a project that just is finalized, and in OTE we were responsible to implement the Athens an efficient mobility city. This implementation was developed at the OTE facilities, the one part, and the other part at the Athens International Airport. We have developed 4 main use cases that has to do with 5G, with a 5G mobility-related city, and
recording in progress.
And that improve the tourism-related experiences and the airport logistics, and by means of smart parking management application, video-enhanced ground-based vehicles with live video transmission, the evacuation of an airport terminal in case of an emergency, and also for tourism, for a mobility of students for educational purposes using augmented and virtual reality mobile applications. The implementation was based mainly in a previous project, the 5G project, a large project, where 4 main sites, 5G sites, were developed in Europe. One is in Greece, the other is in Turin, in Italy, the other in Rennes, France, and Spain, the 4th one. The first implementation was developed by OTE and Nokia mainly. The infrastructure was by OTE and Nokia, and now have expanded this implementation at the airport of Athens. This is the whole, the complete infrastructure that we have developed. We have a Nokia 5G core, a non-standalone version, and another one, which is in standalone version. We have from Wings a Kafka broker, an OSM, and some diagnostic tools and an AI-enhanced model that is used for dynamically allocate resources application resources to the use cases when they run. We have an infrastructure with probes from ACTA, a server here. This is the part of OTE facilities. And we have a lot of VMs that are used for the 4 use cases. Also, we have an interconnection of this site to the 3 main sites of the Europe, with the Spain, with the Rennes, with the Spain, and with the Turin, where we have an interworking layer where the 4 sites are interconnected. And also, we have a 10 gigabps line from OTE facilities at Psalidi, Marousi, to the area of airport, where we have installed 2 outdoor antennas, 4 indoor antennas, a lot of BBUs, 2 BBUs, and a lot of probes, where the probes are used in order to measure the KPIs in real time. And here we run 4 main use cases: the smart parking, the follow me cars, ground-based vehicles, the emergency evacuation, and the augmented and virtual reality for tourists. Also, we host some other use cases that we run at this infrastructure. So also from this, in this infrastructure, we have also antennas and interconnection to other European projects. So this is the main infrastructure which is used for a lot of European projects. Also have developed a strong infrastructure about the KPI measurement with the help of ACTA. We have installed the TOAMP and Viavi software. You can real 24/7 KPIs in real time. And these KPIs has to do with throughput, the max sustainable throughput, latency end-to-end, run latency, jitter, packet loss, availability, and reliability. So this is the end-to-end infrastructure network from OT facilities to AIA, Athens International Airport, and we can measure all these KPIs in real time. The first use case that I will describe very shortly is the smart parking management system. This use case, we have 2 applications. The mobile application, which is at the driver's part, and 1 dashboard where we manage the parking spots. So we have installed 50 parking spots and have used 50 chipsets for these parking spots, 4 from Sequence and 46 Quectel. And we have the one cloud platform where the parking spots sends through narrowband IoT information if they are occupied or are free, or other information about the battery and the status of the parking spot to the cloud. The dashboards reads this information, and also the application part of the driver reads the information of the status of its parking. In this application of the driver, we can see the optimal route in order when a driver comes to the airport, the application will guide him to the nearest free parking spot. We have very good results about reliability, availability, latency, and throughput. The throughput is about the download, about 250 Mbps, and this is because in the airport it's a very difficult area, since we have a lot of 5G companies, Cosmote, Wings, and all that, that transmit in the frequencies, in the different bands, but however, there is a lot of interference, a lot of noise, and due to this sort of situation in the frequency bands, we had only the ability to have a 50 megahertz band in order to run these applications. So this is the result that we have less throughput here. this is the downstream and upstream. We had very good results. We had also, during the project, we ran a lot of requirement analysis about the KPIs. We described all the KPIs and so what are the accepted values for these KPIs. The next use case that we implemented, very important use case for an airport, is the video enhanced ground moving vehicles. We have 3 vans at the airport. We have 3 cameras, high definition cameras, 3 5G peplink routers installed into the van, each one of the vans, 1 application and 1 media server. In this use case, each one of the cameras sent in real time high definition video to the airport security operations center, and different stakeholders can connect to this media server and can see in real time what happens in the apron area where the airplanes are, like police, ambulance services, fire brigade, and all that stakeholders. Here is a photo from the airport security operations center of the airport. And this is the peplink router. And this is the application that we have where 3 vans run to an airplane, and we can see the 3 different streams. Very good results also here. We have the limitation of the bandwidth. And let's move to the use case 12, which is the emergency airport evacuation. Very important also use case for an airport. Here we have a scenario of a bomb, I would say. Sorry, not yet for the video. We have 3 indoor antennas. This is at the satellite terminal of the, if you know, the low-cost terminal of the airport. We have implemented an LBS algorithm, locate-based service algorithm, which locates the mobile devices of the evacuees, of the volunteers that we have during the trial. We were about 20 volunteers for this use case, and we had 3 exits, and we ran an application which guides us to the nearest exit of the 3. And also, this application makes a balance of the evacuees in the 3 different exits. Also, we had here very good results. The application was developed and gave very good results. And also, the KPIs that we measured were acceptable and with very low latency, very high availability, reliability, and acceptable throughput. And the 4th use case has to do with the tourism, and we ran this with Ελληνογερμανική Αγωγή, a private school, if you know, where the participants in this use case was 24 students from Ελληνογερμανική Αγωγή. Very interesting use case. We had a mobile device, well, the student and a gear VR set. The students were this one set connected to the mobile device. The mobile device were connected to the 5G. We had 2 scenarios, one outdoor and one indoor scenario. And we used 1 augmented reality application, 2 augmented reality applications for the indoor scenarios, and 1 virtual reality application for the outdoor scenario. The outdoor scenario was a tour around the airport. The students had the mobile devices. They were connected to the 5G and they could see a VR application with quiz about Myrtis. This is the theme of this exhibition that we ran this application. Myrtis is a young Athenian girl who died by typhoid fever in 430 before Christ during the Peloponnesian War, and her face has been reconstructed by Professor Papagrigorakis' team at the University of Athens. So this is the theme of this use case in the exhibition. This is an environment of the virtual application, the environment of the augmented reality applications. The students find it very interesting, and we will see also an interview in the video next. And very good results also here to this application. This is the 4 main use cases. During the 5G tours, we ran also in Athens site, in Athens node, and other applications with multi-site use case with in collaboration with REN's site, where in Athens we had a monitor, and at the REN's there was an operation room in a hospital, and we could see here with the doctor what happens at the other part of this at the REN's. So you can see the video also which describes all these use cases.
Thank you so much, Felisarios.
Ωραίο. Πώς φάνηκε η εμπειρία?
Ήταν μια πάρα πολύ ενδιαφέρουσα εμπειρία για μένα και πιστεύω ότι με βοήθησε αρκετά να διευρύνω τις ορίζοντες μου.
Η εμπειρία αυτή μου φάνηκε καταπληκτική. Πιστεύω ότι ήμουν πάρα πολύ τυχερός που το βίωσα. Θέλω κι άλλα να το ζήσετε γιατί ήταν καταπληκτικό.
Ήταν πάρα πολύ ενδιαφέρουσα και κάτι όχι συνηθισμένο από βιβλία κτλ. Δηλαδή ήταν σίγουρα πιο ωραίο ο τρόπος που έγινε και πιο διασκεδαστικό.
Πάρα πολύ ωραία και μπορούσαμε να εμπλουτίσουμε τις γνώσεις μας με έναν πολύ ενδιαφέρον τρόπο.
Okay, this is the interview of the students. Thank you. We can close the... Thank you very much, all of you. If you have any question.
I would like to invite Dr. Ioannis Patsouras from ACTA. He will complete the framework of 5G tools in parallel with some results coming from the 5G Heart project. And then potentially we may have any questions jointly if relevant.
Hello. Okay. Good afternoon. My name is Ioannis Patsouras. I work in ACTA. ACTA is an SME. We will say a few words about the company, but the focus of today's presentation is to look at the results that we delivered in the 5G Tours and 5G Hard Horizon projects, and what conclusions we can draw out of this. A few words about the company. ACTA is an SME. It was founded back in 2002. Our areas of competence and expertise are around monitoring and test measurement solutions. We operate in the area of Greece and the Balkans and Cyprus. We are certified with ISO 9001. And we offer a variety of solutions for various sectors of the telecommunications industry. Here we only highlight 2 or 3 areas where we are active at the present time. One of these, which is quite important, is the zero-touch provisioning solution, which is applied in, it is the configuration of the automatic configuration of the CPEs. It is applied in all the telecom operators in Greece. The AMF Observatory is something that is also in operation. It is a web-based platform, and it is in operation also in Greece and in other countries around the world. ACTA has delivered a specific interface and analysis of the results for this. And also for the fiber optic network implementations, ACTA has a suite of products that allow us also not only to test and measure fiber optics equipment, but also to monitor their operations. I come to the focus of the competence and what is going to be presented today that has to do with the mobile network monitoring, and in this case, the 5G network monitoring. Dr. Gezerlis referred to some of these. I will also say that in both of these projects, the 5G tours that was described in detail before and the 5G hard, what we did, we employed a suite of products that were based on one hand on Viavi hardware and software probes, and on top of this, ACTA developed using open source visualization and analysis environment. So in this slide, what we see is that we measured with this equipment, which is carrier-grade equipment, and it is both in terms of efficiency and in terms of stability and reliability, it is superior to ping and other off-the-shelf measuring solutions. We measured a variety of protocols and KPIs that have to do both with the physical layer as well as the service layer. And here we have an overview of the equipment that was used. These two probes are hardware probes. This is small form pluggable, so you understand it's not real size here, obviously, but you understand that the scale factor is very different from that one. And also, we had software probes in various parts of the system. This allowed us to measure basic KPIs that were specified by the architecture and the requirements of the projects that had to do with throughput, latency, packet loss, and also with the peak throughput and the availability and reliability. And we measured this alongside the network, both in terms of the end-to-end performance from the point where the application was running up to the user, but also among various segments. This is interesting, and it will become apparent what are the implications later on. What I was saying is that the platform that we have developed is called the KPI Measurement and Validation Platform. It is based on the Nitro Fusion solution of Viavi, and then it is augmented by open source software to form a complete system that allows, the system has some specific characteristics. It measures real time, okay, or almost real time, because there are a few milliseconds apparently that take some processing time. The granularity, it runs 24/7. The monitoring granularity is 1 minute, but the sampling granularity can be anything from 10 to 100 milliseconds. So for the designated paths and points of interface and the designated KPIs, a complete set of measurements is running that it can be stored and processed later, and also it can be visualized. The visualization that is afforded by the platform can be seen, two snapshots of this visualization can be seen in this slide, where here we see a geographical map representation that if it was in real life, then one could click and see the whole path from the two locations of the project for the 5G tours. This is what Dr. Gezerlis described, the locations in Athens, in the hotel labs, and the locations in the Athens International Airport. And as you click on this and you expand, you see all the installations and all the routes that the traffic passes through. Here, this is one screen that contains, I could call it a management level presentation in terms of the cockpit view, and also the progression of the KPIs, the KPIs that have been selected in real time. So for the 5G tours, Dr. Belisarios described in detail the use cases. ACTA had installed along the whole network, all the way from starting from the hotel labs, the transport part of the network that was between Marousi and the international airport, and then within the airport there were installations of radio units, and ACTA had installed probes in specific points in order to be able to measure two things. Here were of importance: the capability and the capacity of the network. This is something that you would normally do when you set up a network and you activate it in order to give it to use for your customers or your clients. And the other thing that was very important for this project, and this is what we see here, was the real-time live traffic that was passing through the network at a given moment. This was made possible, and here I have an example that is relevant to what Dr. Gezerlis described before. We have the use case that had to do with the artificial reality and the virtual reality, and we see how there were the students, they were creating some traffic using their mobile phones and the application, and here we see how the traffic evolved in real time as the students moved from the outside area to the inside area, or vice versa. And so we see the gap when somebody is moving, is not using it, and then he goes from the AR to the VR application, and we see again traffic being generated. Of course, the total traffic of this during this trial that was like 10 students was something around 50 megabps, which was well below the capacity of the 5G network, but it is a real case. Here it is only a sample of the KPIs that we measured, because I want to draw some conclusions. Dr. Gezerlis presented for various cases the various results. The conclusion that we draw here has 2 or 3 main components. So one thing is that In terms of latency, we measured around 20 milliseconds. This, for a 5G network, might not seem spectacular, but it is satisfactory because it is around or below the psychological level or the human level where a human can process. And also, we identified where this was coming from. So, for the run part, it was almost 1 millisecond. For the transport part, it was 0 point something millisecond. So we understand that the best part of these 20 milliseconds was coming from the physical path, from the antenna to the UE, to the mobile. This was to be expected because it had to do with the varying atmospheric and network conditions in the area. Most of these trials were conducted during a wintry period. And also another thing that needs to be taken into account is that this was a real network. It was set up. It was not in the lab, but nevertheless, it was a trial network. It is not a commercial network. So the installations were minimal, and the output power was minimal. The packet loss was always close to 0% or 0 point something percent. Jitter, which is important because jitter was not a strict requirement of the architecture measurements, and in this project, we in Greece managed to measure all of these KPIs, but jitter is important for the perception of the user. If you have high jitter, and even for these figures of latency and throughput is good, but the user will not enjoy the communication, will not enjoy the video. In terms of video, the high jitter will show some stuttering, for sure. The throughput was measured professionally, not with an off-the-shelf tool, like speed test or something. The professional tool was based on a protocol that is used by the operators to measure the network. The speeds that were achieved, the maximum speeds, were around 200 megabps for the download and around 20 megabps for the upload. Again, this is not spectacular for a 5G network. There is a good reason for that. But it proved in real life to be sufficient, and the users did not complain. In some of the cases, the importance of the traffic was for the download streams. In some of the cases, the importance was for the upload streams. In the case where we had the surveillance, the monitoring cameras on the cars, in the apron, for example. Another thing that we did in this project, and it was important for the project and for us, was that we did radio field measurements. I'm telling the story here. I told you before that all of this is leading somewhere. The thing is here that because this network had a minimal configuration and a minimal setup, at some points along the project, we faced serious coverage and serious service issues. On one hand, the network was up and running, but on the other hand, it was not delivering. So we brought in specialized equipment that did RF measurements. Oops, sorry. We did two things. One was to measure the coverage. This is the map of the apron area, of the runways and the apron area. This is the equipment that we used, and this is a colleague of ours that was going around taking measurements. And we also measured the interference. We eliminated some timing error, but the most important thing is that we identified that there was interference from a commercial network, so we had to limit our bandwidth. So this was a network that was running in this frequency band, but with a 50 megahertz bandwidth. And this is the reason why we could not afford, from a point onwards, spectacular throughput figures. I will say a few words now about the other project where we provided services in the Horizon project, the 5G hard. Here it was a slightly different situation with, again, challenging, but for a different reason. It is an aquaculture facility. This is still running. It is in the Megara area. And there is a small house, not call it house, a hut for the equipment. And this is the schematic of the network, the servers and the core parties in the Hotel Labs facilities. And this is the part that is located in the area around Megara, a minimal part of the equipment there, some servers, some probes. For obvious reasons, in this installation, you cannot put a lot of equipment. Here we identified very early on the need to have a permanent 24/7 view of what is happening, a remote view of what is happening. When you run the trial and you are there with a mobile or with an application, you do something. But for this project, this was not enough. So what did we do? We sourced a modem that was used as a UE with a 5G hard SIM card. We created an installation and installed it. So this was a permanent user of the network for our sake there. Using this and also using what the UEs that the users were having, we measured, we installed again various probes in various parts of the network. This is a view of the segmentation, a schematic view of the segmentation to measure the various paths, the transport part, the backhauling, all the way. These are the various CPAs that I was telling you, which could be this special modem router. It could be UEs like the 5G UEs that we have on our hand. And we measure, this is a server that we installed there with the SFPs that you can see here. And this again is the view that we see. In this case, it is from the Marusi lab all the way to the area here. And let's see what results we got. One thing, again, that we must take out of the equation and feel confident about is the transport network. So the transport network here was a special case because it was not purposely built for this project. This transport network here goes all the way from the hotel labs to Megara, and parts of this, as it passes through various nodes, are parts of a public transport network that OTE is using. Still, this had 1 Gbps capacity. In the Tours project, it has 10 Gbps capacity. We measured that it is according to spec. These are real measurements with 0 packet loss, almost 1 Gbps throughput, and meaningless latency or round trip time. And these are the graphs for this case. In terms, now let's turn our attention to the end-to-end network measurements because this is something that's relevant for the user. There, what we see, and the graphs again are not just a depiction, they are real graphs. You can see two things without even looking at the numbers. You can see the stability in terms of the latency, also the stability in terms of the loss. Don't be alarmed by these peaks. The scale here is very narrow. It is 0 and 0.2 decimal digits. So these are something that should not concern us. The latency is stable. It is around a figure of 10, 15 milliseconds, and it is stable. So this means that this is a well-behaved network. Again, I would lie to you if I would not tell you that this had to do also with atmospheric conditions, because most of these trials were done when the weather was good. You can imagine why this was the case, because you are near to the sea and in an area where you can only send people there if the conditions are not very harsh. Still, we had a very well-behaved network. We had the throughput, again, in the figures of around 200 megabps, the downput, and 60 megabps, the uplink, the throughput. This variation, again, has to do with the various instances that you measure the network. Our equipment was there, and it measured the network for months. So during the actual trials that took place, the last session of the trials took place in October, we measured figures like this. So to be fair, I also measured this. The uplink was stable, was almost all the time around 50 or 60 megabps. This is a particularly good figure. It is important for this use case because the users of this vertical are sensors and cameras, surveillance cameras and cameras that are underwater cameras that measure, that check the fish in real time and through artificial intelligence measure their size and their food consumption. So all of these video uploads were uploaded on the network. With this capacity, this was more than sufficient. What I was saying, the upload from the cameras. So these are various use cases or various scenarios, as it was called in this project. The figures here are small. It is the real-time live traffic that was passed from the camera upwards. Here it was like, the captions are the other way around. So here it was from this camera, it was around 5 megabps. From that camera, it was around 10. In total, when both cameras the drone camera was running, it was higher, around 15. Quite stable, the traffic. There was no reason not to be stable. When you see some drops or rises of the traffic, this has to do with somebody giving the command to the camera to turn or to pause or to do something. This was a stable network, so one, of course, could say that 5G here is more than sufficient, but this was the case to make this happen. So I will conclude with a few. Okay, this is busy with text, but and it has two columns. The thing here is to say that, to keep out of this, is that in both projects we had a variety of equipment and a variety of vendors. We measured the networks with the same type of equipment and the same methodology. The results are comparable, and this has to do with the fact that in both cases the available bandwidth was 50 MHz. And it has been proven in various 5GPP projects that for 50 MHz, you cannot go higher than 300 Mbps. We also did at some stages of the project, at the early stages, we did measurements with this setup in the labs, and there we could get up to 1 Gbps, which is something that the literature is always bragging about for 5G. The radio conditions were varying, and this could affect in various times of the day and of the year the KPI figures, but still the latency was, especially for 5G hard, was 15 milliseconds. There we had some URLLC cases. Initially it was specified that the desired latency target would be 5 milliseconds. This is a dream for 6G, maybe, or beyond 5G, but this is what really happened. And another thing to keep in, this is the last here I conclude, is the fact that all these measurements and all these results were made available to be further analyzed through a standardized interface that had to do with the 5G Kafka and be reused for correlation with measurements from the applications, with measurements from the VNFs, in order to see if there are any correlations and any consequences. Of course, all of this is detailed in the deliverable. I will not go into this here. So I think this is all that I had for today. Thank you. And if there are any questions.
Thank you so much, Dr. Patsouras, for your support, for once again, on behalf of ACTA. Just a general question regarding the applicability of the solutions proposed by the 5G hard project. Based on your presentation, it appears that the network is ready. The network provides enough support for the realization of the 5G. Some issues, of course, potentially may be referred to the next generation. However, it is remarkable the stability, as far as I have noticed, unless I'm wrong. Regarding the involved, let's say, end users, the entities, do you see that they intend to use these solutions further on, or this was just a challenge for the course of the project?
Thank you. This is a very good question, and in this project, this has been addressed. There is an exploitation and a business plan by the involved partners. Here, the vertical is the aquaculture. For the aquaculture to use this, some things must happen because it is a non-technical industry and it is an industry that cannot say that I have 200 employees so I can get 10 engineers. So there are things that need to happen. The whole value chain must come into play for this to happen. The operator, the provider of the service for the network stability, the provider of the applications, and the user of the vertical that is using this application. This has been identified in the project. It is a challenge. It is not something that is short-term. Maybe in the future, if we see 5G private networks, this could become more evident. Keep in mind that this vertical also has other installations in other parts of Greece. So for them, it would make sense to use this environment, to reuse this environment 2 or 3 times. And this way, it would make sense also for us and for other SMEs that are collaborating with them. So it is something that is in the works.
Now we will pass to the next speaker, Mr. Eleftherios Milionas from Independent Power Transmission Operator, ADMIE. He will present some
features of the 5G Victory project, which is about transforming power utilities into smart factories. Thank you for joining the event. I would like to express my profound thanks to you and to IPTO because you have embarrassed the activity and provided contributions here and in the Smart Private Grid project. Thank you.
Thank you very much. I hope everyone hears me well. So, my name is Eleftherios Milonas. I am a researcher. I'm working as a researcher at the IPTO, the Independent Power Transmission Operator of Greece. And I'm working at the 5G Victory project. Today, I'm going to show you how we, IPTO, are using 5G technology in order to transform power utilities into smart factories. Okay, first of all, some few things about us. As I already said, IPTO, or otherwise known in Greek as ADMIE, is the Independent Power Transmission Operator of Greece. That means that we are responsible for the operation, the maintenance and development of the power transmission grid, the Greek power transmission grid, which spans over 11,000 kilometers, covering the whole of mainland Greece and and some of the Greek islands as well, and has a great number of facility sites as well. The main things that IPTO is concerned in its everyday challenges, are let's say, the real-time monitoring of the facilities, of the assets, which is critical assets, because it has to do with the stability and the operation of the power grid, the overall power grid. And so we are interested, the problems that we face are referring to smart grid and Industry 4.0 use cases. I mean, we have the collection of measurements and synchronization of measurements from different sites. We have real-time information exchange between IPTO and other high-voltage partners, customers. And of course, we need to know if or when some equipment is going to fail in order to repair it. We are very concerned with the health of the equipment. And so IPTO is very active in different Industry 4.0 research projects and is acting as a vertical user who is giving access to the facilities in order to test and validate new technologies and new solutions. Okay, now having cleared a little bit the role of IPTO in general, what is IPTO's role in 5G Victory? Well, 5G Victory is overall about large-scale 5G trials. And it has 4 main verticals. It has transportation energy, media, and factors of the future. And of course, there are some cross-verticals as well. But in our case, IPTO is more concerned with 2 use cases, including, of course, the factors of the future, which is the one I'm going to talk to you about today. And we are trying to show how 5G can help in order how we can deploy smart factory services on top of 5G technology. And of course, here you can see the consortium, which is a very big consortium, let's say, and has a lot of partners. Okay. The smart factory services that we are showcasing at the 5G Victory project and at this use case are 3 different services: the predictive maintenance, the operation, and the security one. These are 3 different cases with very diverse KPIs. And briefly, I just mentioned here that on the predictive maintenance, we have, as I said earlier, the collection of measurements from different sites, of different measurements, and with different protocols as well. And the processing of the data, the transmission and processing of the data, and the, let's say, the data analytics that we have to apply in order to take some insight, to have some insight on what is happening to our facilities and the equipment health. We have the operation service that is about the most critical, let's say, aspects of the grid. I mean, the equipment that is highly critical, and I will show you one example later. And so we are very concerned with the timing, with low latency transmissions and low latency processing. And the security one is about high-quality video feeds, CCTV monitoring, and processing of video, of high-quality video in general, in order to have some alarms, generate alarms, and for the security of the facilities. Okay. These are the facilities that we demonstrate the use case we IPTO at this specific case. We have the two facilities of IPTO, the Rio and Anterior, which are interconnected through a submarine cable of 150 kilovolt, and they are electrically connected, and of course they are also connected through a fiber cable. And we have the University of Patras, which, okay, let me rephrase that. Actually, we have these two facilities. At the facilities of Rio, we have some 5G equipment, which are where the measurements from Anterior and Rio are collected and processed locally. And also, we have installed a millimeter wave link with the help of Infocom Telecom that connects the IPTO facilities, let's say, with the University of Patras, which is the provider of the 5G connectivity and the 5G network in general. And what you actually see here is one private 5G network. This whole system, I mean, we have the private network, which has to do with the two facilities, and of course we have an extension of the network to the University of Patras for access to the university data center, where some of the services you will see are running at. And okay, let's go to the next slide. Okay, here is a more technical stuff. I did not put much technical stuff here, but I will talk about it a little bit later. Here you can actually see the 5G architecture that we have used in our specific use case. Here you can see the three services with three different colors as network slices. You can see with blue we have the security one, we have the green one for the operation, and the red one for the predictive maintenance. And the whole purpose, let's say, of this network and this use case is to show that we have three different services with diverse KPIs running on top of the same equipment at the same time, and with actually some different network topologies. For example, the operation, let's say, service, which is more critical, it has to do with the latency, as I said earlier, is running on the lower part of the network. To give you an explanation, here we have AVME field, which is where all the measurement equipment lie, and we have the control IPTO, let's say, control room, where the 5G equipment is installed. So this is all done. This part, let's say, is done. This part from the Rio and Anterior side. We have the equipment. In this case, let's say, high voltage cable sensors, and that are measuring are seeing the equipment health of the submarine cable, and are reporting through 5G. We have some equipment that are giving, let's say, are enabling 5G connectivity with the G0 B, and that is installed at the Rio facilities where most of the services are running. And why we have done this in that way is because we need low latency. We can't leave data, go to the cloud, and come back again at the facility, because we may need to, let's say, enable some control action, take some control action. And at the same regard, we have also the predictive maintenance, where the reason why we have it here running at let's say, the lower end of the network is because we want to make sure that no one else beside our technicians has access to the information that is running here at the substation. I mean, we want the AVME technician, IPTO technician, coming with a 5G UE, let's say an Android phone, and coming to the facilities and connecting to the network and having access to the platform, let's say, that the service that is running here. We don't want the information to travel outside of our premises. And of course, okay, the security one is running most of it at the cloud of the University of Patras, the cloud facilities. Okay. Okay, here you can see briefly the equipment and software that we have used in our use case. This is the G.B, as I called it later, or the Patras 5G Autonomous Edge. It is actually not only a G.B, it has the 5G run capabilities, and it has also an MX server, and all of it is running here at this mobile box. And of course, it can run all the 5G stack on top of it, and also it enables service provisioning through OpenStack technology and virtualized, in general, virtualization technology. We have, here you can see actually the millimeter wave link that we installed at the IPTO premises in order to connect our facilities with the University of Patras. This whole thing, I mean, this was the most challenging part, let's say, of the work, installing this link, and here the image doesn't give credit to it a lot. We have the UiTop data management platform from Infocom, which is let's say the IoT platform that we used in our solution for most of the part. And of course, the equipment that we installed, the networking equipment, the industrial sensors, etc. And here you can see some pictures from our lab testing when we set up, made a simulation, let's say a 5G network at the University of Patras. Here we have two laptops acting as sensing device, measurement devices. 5G CPE here, giving 5G connectivity to the devices. The 5G RAN here, the cloud at this here, at this part of the image, and the dashboard here where we are working with UiTop, and we can see actually the network, we can monitor the network, let's say, from that image here. And the same network at the real infrastructures here, where it is the same setup. I mean, the 5G RAN, the equipment here, real equipment, the 5G CPE, and the UiTop dashboard here. And in this picture is actually, you can see some parts about the security service. You can see actually a mobile, let's say, surveillance robot that we are using in order to have enabled through 5G connectivity with some equipment, and we are able to do outdoor inspection of the facilities and some indoor inspection with one camera here, some camera CCTV monitoring, and here is an image from our indoor inspection. Okay. Okay, I haven't included in my presentation much technical details. You can find many technical details in a video that we are going to share at the 5G Victory YouTube channel in actually, I believe, in a few weeks. But the overall findings, let's say, of our solution is that we actually, as I said, tested the support of different services on top of the same equipment and of diverse KPIs. The integration with legacy systems as, let's say, one at the Rio facilities. And of course, we tested how easy it was to actually deploy different services through this virtualization technology that the University of Patras guys have put in place and have tested for us. And in that way, we have concluded that let's say, the value of the 5G private networks, not public networks, is that, of course, you have actually the capability, you have the whole, let's say, the whole control of your network. You can make it as you want. You can have it in different topologies, some things running at the end, some other things at the cloud. We have actually the data privacy thing that I talked about, the predictive maintenance use case. which is actually really important to go into the facilities and be able to connect directly through this technology that the University of Patras have included. Of course, that this whole technology gives the capabilities to a vertical industry to actually put in place one network, 5G network, without actually needing, let's say, an operator. They can actually put in place themselves, let's say, with the help, almost themselves, through this virtualization technology and all these things that I talked about. And with that thing said, I include my presentation. If you have any questions, I'm happy to answer them now. Elsewhere, we can talk. You can find me in this email. And most things to come are on the YouTube channel, as I told earlier. So that's it from me. Thank you.
Thank you for your presentation, for the aspects of the 5G Victory project you have demonstrated, in particular related to the non-public networks, which is among the initiatives proposed by the European Commission, actually. I have not a question, but it was very interesting, the scope you have presented, and for me at least a challenge to look for deeper and collect information about this very important aspect joining. Thank you again for your presentation. Σε αυτό το σημείο νομίζω ότι μπορούμε να κάνουμε ένα μικρό διάλειμμα, επειδή υπάρχει μια ολίσθηση του προγράμματος 5 λεπτά και θα επανέλθουμε με τις επόμενες παρουσιάσεις.
Μετά την βοήθεια εδώ του τεχνικού πάνελ που μας συντροφεύουν από το πρωί και μας δίνουν λύσεις φανερά και μη φανερά, τους οποίους ευχαριστώ μια που μου δίνεται ευκαιρία, περνάμε στην επόμενη ενότητα. Η επόμενη ενότητα αφορά σε core technologies για innovation and connected automated mobility. Προσπαθήσαμε να ενσωματώσουμε διάφορα ερευνητικά προγράμματα όπως το Affordable 5G, το NEMO, το 5G Roots, καθώς και μια πολύ ενδιαφέρουσα συναφή παρουσίαση για Digital Twins που θα παρουσιάσει η αγαπητή καθηγήτρια Νάνση Αλονιστιώτη από το Τμήμα Πληροφορικής και Τηλεπικοινωνιών του Εθνικού Καπανιστριακού Πανεπιστημίου. Απλώς δράτω με τις ευκαιρίες για να κάνω την εισαγωγή αυτή στα ελληνικά πριν περάσουμε στα αγγλικά για τους λόγους που σας ανέφερα και θα το λέω σε κάθε έναρξη ενότητας για να μην χαρακτηριστώ ενδεχομένως ως μη υποστηρικτής της ελληνικής γλώσσας που αγαπώ πάρα πολύ, αλλά πρακτικά σε κάποιες ενότητες θα έχουμε κάποιους ξένους ομιλητές και όπως ανέφερα νωρίτερα θέλουμε η σημερινή εκδήλωση να έχει ευρύτερη απήχηση. So welcome Nancy once again.
Thank you.
Many thanks for your continuous support in various events. I will give you the stage. Looking forward to hearing your presentation.
Thank you very much. Thank you for inviting me and for giving me the opportunity to share with you some work that has been done by our team. And in fact, this work has been awarded one of the distinctions from the Ministry of Environment and the General Secretary of Forests. Our work here is related to, developing smart applications on top of a smart network combining 5G, Internet of Things, and other infrastructures that we can combine through 5G technology. Here we present a solution where we can combine with the speed of 5G networks, we can combine an interactive model through the development of 3D models, city models, and nearby forest models. So around the cities, we are addressing the forests around the city environment and the urban environments. And we try to combine information coming from the various areas where we implement Internet of Things, both urban and and rural areas. So in this case, we have developed a digital twin from a city, and we combine environmental monitoring between the city and the forests that are around the city. So what we are doing is that we exploit the 5G connectivity and the Internet of Things infrastructure in the city in order to combine information for monitoring the environmental parameters of the city together with the environmental parameters of the surrounding forests. Here you can have a look about the environmental digital twin of the city, where we are able to monitor parameters related to the quality of the air, temperature, and we are able through this kind of representation and visualization of the data to provide a panel, an interactive panel for the city administration in order to deal with environmental crisis, in order to deal with predictions for environmental impact for the city and the surrounding areas. So here you may see also that the environmental digital twin for the city and for the forests around the city are able to combine information not only for pure environmental monitoring, but to combine information related also to other resources like the energy. And in this sense, through the integrated or aggregated exploitation of this data, to be able to address sustainability for the city, the urban environment, and the rural areas. In order to develop the digital twins for both the urban and the forest areas around the city, we have used scanners with drones, where we have created through photogrammetry the 3D models that have been implemented in our digital twin environment. The digital twin environment is not only about geospatial information, but it is rather a 3D model that uses geospatial information and creates an interactive environment where we can view the information that is created by various parameters, by various infrastructure like sensors. We can view this information by different views. And this helps us to build knowledge and awareness about how these parameters and how the interdependencies of environmental spaces are in an urban and rural area, and how the implementation of an integrated 3D model, interactive 3D model, can help in actually developing awareness about both environments and the interdependencies between them. So what it means to develop a database or a knowledge base for rural and urban areas that are neighboring areas, what it means for climate change, what it means for climate impact in these areas. And in order to be able to address sustainability, we need to be able to predict and also to assess the risks on top of these models through the analysis not only of parameters but also of images that can be obtained and integrated in our 3D model. This means that we are able to predict based on the climate situation, the climate parameters, to predict the impact, for example, in forests that are around cities, the impact of this climate change into forests that are crucial for the sustainability of the cities. And we are able to analyze data that are captured in this digital twin model in a coherent way, so combine data from various areas inside the city and outside the city in order to develop the prediction for the climate impact in these areas, either urban or rural areas. In this sense, we are able to detect and predict the areas where we will have problems in the future in terms of deforestation around the cities, and through the prediction we are able to actually assess the risks for the whole city environment and the impact of this to the city environment and the raising of temperatures and the raising of or the deterioration of the quality of the air. And we are able actually to since we are able to predict, we are able actually to act in order to reduce the impact of the deforestation in the urban and the rural areas. We use, of course, on top of this 3D model, in order to make prediction or risk assessments or detect what kind of actions we can perform in order to mitigate the risks, we use machine learning and artificial intelligence mechanisms in order to address the risks, to predict the potential impact based on the measurements that we have on our model, and in order to simulate the potential actions that we have to take in order to mitigate the impact of the deforestation in the climate and the potential climate change of the city environment. So in this case, we combine a digital twin environment through an interactive 3D model, the combination and the aggregation of IoT parameters that we measure the potential information related to the climate, and also the AI and machine learning algorithms in order to predict, assess, and mitigate risks for climate change for the city environments. This was a work that, as I told you, has been awarded by the Ministry of Environment, and we are in the process of developing further the pilots that will actually showcase more results related to the measurements of such environmental impact in various cities and of different, let's say, of different population and different characteristics. And we want to further assess how this model can help in addressing climate impact in the cities of tomorrow and in smart cities of the future. So thank you very much, and I am available for any questions later.
Thank you, Nancy. If there is no question, just let's say a general comment by my side. It is very interesting to see this model which provides new horizons for environmental aspects. I have the feeling, however, that this could be extended on your behalf also to cover other aspects like civil protection, for example. So this is not the only, let's say, option promoted by your model.
Yeah.
I have the feeling that...
Thank you, Yanis. That's true. The other application of the model is actually for public safety. So we are able to classify events that are related to fires, and we are predicting the potential progressive, let's say, deterioration of the fire event in such areas. And therefore, we are able to predict how the human resources and the firefighting resources can be applied in specific areas. So this is very well connected to this type of models. Thank you very much.
This would be the objective of next year's presentation.
I hope so. We have the pilot now. We have our first pilot was in the campus of the university. Our second pilot will be done together with the Ministry of Environment at an area that they will provide us access. Thank you very much.
Thank you again, Nancy. We will now pass to the next speaker, an old friend. We will now pass to the next speaker, Dr. George Agapiou, an old colleague, a friend, who is joining us remotely. First of all, I would like to express my profound thanks to George for his effort to support this year's activity at Infocom. Many, many thanks, George, and looking forward to hearing your presentation will be about aspects from the 5G routes project, if I'm correct.
Yes. Yanis, can you hear me and see my screen also I share?
Tell him that you can hear him.
Yanis?
Hello, George. It is okay. Go on.
Okay, thank you, because I didn't hear you. First of all, sorry I didn't have the chance to come to this wonderful, let's say, conference. I tried hard, but I had different meetings, conferences, so it was also deliverables, and it was I was unable to come. I would be very pleased to meet also some old, let's say, partners, friends, and so forth. But at least I have the chance to give the presentation remotely. So I will talk about what we have done in 5G Routes project. We have a maritime scenario where, let me go to the next one, just to provide you a small outline. We have a maritime communication. I will present the use case. And finally, I will conclude my talk with what we have done and some achievements. So here, what you see for maritime communication, we talk about, we have different ships in the sea, and we talk about the communication from a ship to another ship, or we talk about the communication from equipment which are inside the ship to different, providing different services to the passengers who are inside the ship. And this is all comes to be the maritime communication. So the main target is to provide enhancement to the connectivity between devices, to offer quality of service by using 5G technology. So what we have done so far is, because it's, I guess it's a bit difficult to offer such things, inside
George, sorry for interrupting. I'm not sure if you're running your slides because it is frozen on the first page.
I run it, but you don't see it, eh?
Otherwise, if you see our screen, we can pass the slides for you.
Yes, Jan, I'm on the fourth slide, so if you can go to that one, sorry. Sometimes it's because of the internet is very slow sometimes. So the aim is to provide, now you see the screen, Yanis, eh? Okay.
George, share again. George, share again and start again your presentation.
Okay, let me stop, sorry, let me stop the sound and start again.
It looks like working well. Just wait a little bit. Can you put it on full screen?
Yes, it's on full screen. It takes a while, sorry, to move.
We see your slides, the sequence of your slides, so maybe you have to turn on full screen. In any case, okay, go on. We now see the fourth slide. Yeah, so continue.
So the aim in the ship is to provide connectivity between the devices, to provide quality of service to the passengers. Besides the ship communication, we have also satellite communication. So if there is not availability of the 5G network, then the communication goes through satellite. Inside the ferry, as I said, we have a 5G new radio. The base station is 5G, and also the core the same. It's 5G non-standalone, but we are going to use in the future, once Ericsson has it available, a 5G standalone core network. So the idea is to set the environment for the freight, because we have different vans, cars, who have a freight, and we need this freight to be secured inside the ship. And we have use cases which are offered to the passengers. So we are looking for quality of service. We are looking for IoT connectivity. between equipment and the freight which are on the trucks. And also we need to provide high capacity to the passengers. And also we have to provide what we call smart ship, which means to try to prevent some extreme events like fire or some intruders who try to either go to some places who were not supposed to be there. So now I move to the 5th slide. So this is a use case overview. So you can see on the picture,
George, it is still frozen on the previous slide. We do not see the use case overview. Let's wait. The control.
Still you don't see it yet.
The next one, please. Okay. George, our technical panel have managed to present your next slide, the use case overview. So we can have, you can provide your explanations, comments on that, and we will continue this way.
Okay, great. So we have, I will provide a use case overview. So the aim is to test the continuous connectivity inside the ship, inside the boat. So what we have constructed is what we call a ferry side unit. It's a gateway which is inside the ship. It can be inside the truck, and the idea is to be able to keep track and connectivity with the freight which is on the trucks. So the ferry side unit, the FSU as it is called, is connected also to the ferry communication infrastructure. It has different sensors to provide information and data about location of items, location of people, temperature, can provide the video capture of people who are moving around or of different items inside the van, or if a fire gets ignited inside the ship. So the FSU is we can say it's a gateway that is equipped with different sensors and provides and exchanges information from the gateway to the 5G network. And of course, this data is collected by a server and it's analyzed to check and to test the quality of the service which is offered inside the ferry. What we have done also is we plan to run a load simulation test, an MMTC, which is a heavy, and we're going to use a large amount of sensors in order to do the test stressing of data inside the ship. Now I move to the next slide, 6, where I present the massive MTC testing, where you can see we're going to use many different mobile terminals in order to achieve this huge amount of data, and to see, how the 5G network can operate in such heavy situations from a large amount of data. I move to slide 7. We have also built an MQTT server. MQTT broker, as it is called, is just a server that exchanges MQTT small messages. They're called MQTT. With the gateway, the FSU, as I explained before. So we can have a communication between the gateway, which is inside the ship, with the broker who is on the cloud. So the communication is done through the internet. And this data, of course, as I said, is used to test either the connectivity, the quality of service, or any movement that is inside the ship. I move to the next slide. Here I present the ferry side unit, the FSU. You can see on the lower left part, it's the gateway that has the different sensors, has a camera, sensors for testing the proximity of people, or it has a GPS to provide the location of different items or passengers who are inside the ship. And the idea is for this gateway to test if we have correct connectivity with particular items which are inside the ship, and if there is an exchange between those items. If we have any extreme events like a fire or a traveler who tries to intrude in some places. So pretty much that's the testing that we plan to do inside the ship. I move to the next slide. Here you can see a picture of the FSU gateway. It's on the right lower part. It's equipped with, as I said, with different sensors. It has a LiDAR to take also pictures to monitor the distance of obstacles. It has also some laser equipment based on LEDs, just to take pictures from passengers or from any extreme events, as I said. So we can say that it is a gateway router which is equipped by different sensors, and its idea and its purpose is to exchange a huge amount of data with a base station of 5G. And this data, of course, go to the control unit in order to provide further analytics and decide the operation of the whole situation inside the ferry. I move to the next slide. I think here pretty much I have the conclusions. So what you saw is a use case, or let's say a collection of scenarios that we plan to use inside the ferry, which is going to travel from one port of Finland to Estonia, and is going to test connectivity between sensors, continuity of service. We are going to have also video. And of course, it's going to test also some extreme events of either fire or intruders who are passengers who are not supposed to be in certain places. And by this, I conclude my talk. Thank you very much. Sorry for not providing the, let's say, the right video. The presentation was not so nice, but as you always
Thank you, George, for your presentation. If there is no question, or if there is any question, I don't see anyone. Okay, thank you again for your presentation, George, and for your support. We will now pass to the next speaker, Mr. George Kontopoulos from Bells Ltd, Greece. He will present the Affordable 5G project, which is about high-tech and affordable 5G network rollout to the Energy Corner.
Ευχαριστώ, Γιάννη, για την εισαγωγή. Θα σας παρουσιάσω στα ελληνικά, γιατί από ό,τι βλέπω είμαστε μεταξύ μας. Στα επόμενα λεπτά θα σας παρουσιάσω εν συντομία τα αποτελέσματα του Project Affordable 5G, το οποίο έτρεξε για τα προηγούμενα 2,5 χρόνια και ολοκληρώθηκε αυτό το μήνα. Ο λόγος ύπαρξης αυτού του project είναι ότι η Ευρωπαϊκή Επιτροπή έχει θέσει σαν στόχο να παραμείνει στην τεχνολογική πρωτοπορία όσον αφορά τα radio δίκτυα. Αφενός, στην Ευρώπη έχουμε την τύχη να βρίσκονται δύο παγκοσμίου φήμης κατασκευαστές radio δικτύων, η Ericsson και η Nokia. Όμως η Ασία και οι Ηνωμένες Πολιτείες τα τελευταία χρόνια προσπαθούν να κερδίσουν την πρωτοπορία και το Open RAN είναι ένας καταλύτης που ενδεχομένως να επαναπροσδιορίσει ποιος βρίσκεται στην κορυφή. Οπότε, στα πλαίσια του Affordable 5G, στόχος ήταν να υλοποιηθεί ένα end-to-end δίκτυο 5G που πρωτίστως στοχεύει τα private networks, το οποίο θα υλοποιείται από υποσυστήματα κατασκευασμένα από ευρωπαϊκές εταιρείες. Μήπως εξακολουθεί να έχει τον έλεγχο ο κύριος Αγαπίου της προηγούμενης παρουσίασης. Εντάξει. Λοιπόν, εν συντομία, θα δούμε το έργο, την καινοτομία που παρήχθησε σε αυτά τα 2,5 χρόνια και μια σύντομη συζήτηση για το οικοσύστημα των radio δικτύων. Το Affordable 5G υλοποιήθηκε σε 2 περιοχές, σε 2 test site. Το πρώτο ήταν το Καστελολί στην Ισπανία. Το use case εδώ ήταν mission critical υπηρεσίες που περιλαμβάνουν push to talk, push to video και push to data υπηρεσίες και επίδειξη artificial intelligence, machine learning τεχνικών για βελτιστοποίηση του δικτύου. Η τοπολογία του δικτύου ήταν αυτή. Εν συντομία να πούμε ότι το δίκτυο περιλαμβάνει από το Radio Unit, το Distributed Unit, το Central Unit, το 5G Core και όλο το Management and Orchestration. Το δεύτερο test site ήταν στη Μάλαγκα, όπου εδώ είχαμε 2 use cases. Το πρώτο ήταν γύρω από industrial δίκτυα, στα οποία πρέπει να υλοποιηθεί time-sensitive networking, δηλαδή δίκτυο που υποστηρίζει πολύ low latency εφαρμογές. Και το δεύτερο use case ήταν στα πλαίσια ενός smart city deployment, η λήψη πάνω από δίκτυο 5G video stream και η επεξεργασία με τεχνικές machine learning, ώστε να αυτοματοποιηθούν οι ειδοποιήσεις σε περίπτωση αναγκών και επικίνδυνων καταστάσεων στην πόλη. Και εδώ είναι εν συντομία η τοπολογία του δικτύου στη Μάλαγκα, όπου φαίνεται και η υποστήριξη του TSN. Και εδώ η παραλλαγή που υποστηρίζει την υλοποίηση του video streaming. Λίγα λόγια για την καινοτομία που παρήχθη στα πλαίσια του project. Το Radio Unit υποστηρίζει την αρχιτεκτονική Open RAN με interface 7,2 split και υποστηρίζει 64 element beamforming κεραία σε sub-6 φασματικές περιοχές. Το 5G Dirac είναι της Accelerant, μιας μικρής εταιρείας από το Βέλγιο, το οποίο είναι το Central Unit μαζί με το RAN Intelligent Controller. Είναι φυσικά ORAN compliant και υποστηρίζει την ανάπτυξη XApps στο RIC και έχει και το framework για την ανάπτυξη αυτών των εφαρμογών XApps. πρέπει να σημειώσουμε ότι στα πλαίσια του Open Run δεν έχει ακόμα γίνει στάνταρ ποιο είναι το framework για να αναπτύσσονται αυτές τις εφαρμογές XApps. Οπότε κάθε εταιρεία που φτιάχνει RIC φτιάχνει προσφέρει το δικό της framework για αυτές τις εφαρμογές. Στα πλαίσια του project επίσης αναπτύχθηκε και ένα τέτοιο XApp, το οποίο ελέγχει την ισχύ εκπομπής στο radio δίκτυο, λαμβάνοντας υπόψη παραμέτρους του δικτύου με στόχο να βελτιστοποιήσει το δίκτυο ως προς throughput και interference. Όπως στα πλαίσια του 5G Core, το οποίο είναι της Athonet, αναπτύχθηκαν κάποιες επεκτάσεις που να υποστηρίζουν το time-sensitive networking. Στα πλαίσια του Management and Orchestration υλοποιήθηκαν εφαρμογές Machine Learning για βελτιστοποίηση και deployment των resources, των υπολογιστικών resources πάνω στα οποία τρέχουν όλα τα applications του Management and Orchestration. Το Mission Critical Services είναι της ισπανικής εταιρείας NetMergent και υποστηρίζει και neutral host δίκτυα. Μπορεί να γίνει deploy και στο core δίκτυο και στο edge και μπορεί να αναπτύξει να κάνει deploy νέα instances στην περίπτωση που χρειάζεται παραπάνω capacity. Όπως είπαμε πριν, αναπτύχθηκε πλήρης υποστήριξη του Time Sensitive Networking end-to-end πάνω από το 5G δίκτυο. Ένας επεξεργαστής για εφαρμογές πολύ χαμηλής ισχύως που είναι βελτιστοποιημένος για να τρέχει machine learning εφαρμογές στο edge του δικτύου. Ένα enhancement στο open source Mano που επιτρέπει συγκεκριμένα deployment των Kubernetes network functions σε specific nodes ενός cluster. Και τέλος, το Smart City Platform, το οποίο υποστηρίζει, είπαμε, εφαρμογές machine learning, επεξεργασία βίντεο και alerts σε περίπτωση αναγκών. Και εν συντομία, λίγα λεπτά να πούμε για το πώς μετασχηματίζεται το οικοσύστημα του radio με καταλήτη το Open Run. Τα δίκτυα radio ήταν πάντα multi-vendor και θα είναι πάντα multi-vendor, καθώς άλλος είναι ο κατασκευαστής των chipset, άλλος φτιάχνει τα boards, άλλος φτιάχνει το software και άλλος κάνει το integration σε ένα end-to-end σύστημα. Όμως, μέχρι σήμερα, οι μεγάλοι κατασκευαστές radio, όπως η Ericsson και η Nokia, κρύβαν αυτή την πολυπλοκότητα από τον mobile operator, γιατί αναλαμβάνουν αυτοί να κάνουν το integration όλων των υποκατασκευαστών και να δώσουν ένα τελικό προϊόν, το οποίο σίγουρα λειτουργούσε χωρίς προβλήματα, όχι μόνο στο αρχικό deployment, αλλά σε κάθε software upgrade. Όμως με το Open Run, το οποίο υπόσχεται στους operators τη δυνατότητα να επιλέγουν ελεύθερα μέσα από πολλούς vendors, καθώς ανοίγει όλα τα interface του radio, έχουμε μια πιο πολύπλοκη κατάσταση, καθώς ναι μεν όλοι οι υποκατασκευαστές μπορούν να υποστηρίζουν ότι είναι compliant στο Open Run, αλλά ακόμα και αν κάποτε φτάσουμε σε αυτό το plug and play ready προϊόν, κανείς δεν θα είναι σίγουρος ότι θα υποστηρίζει και το performance που είναι αναγκαίο από τον operator για τα use case που έχει να υποστηρίξει. Σε αυτή την περίπτωση θα χρειαστούν testing labs, στα οποία θα μπορεί ο operator να δοκιμάσει όλους αυτούς τους προμηθευτές ως προς το interoperability και το performance. Και επειδή όλη αυτή η δικασία του testing θα είναι αρκετά πολύπλοκη για να μπορεί να την υποστηρίξει μόνος του ένας operator μεσαίου ή μικρού μεγέθους, πιθανότατα θα χρειαστεί την υποστήριξη και ενός system integrator για να τον βοηθήσει σε αυτό το έργο, ο οποίος ήταν αναγκαίος όχι μόνο στο αρχικό deployment, αλλά σε όλη τη διάρκεια ζωής του δικτύου. Άρα υπάρχει ένα ενδεχόμενο αυτό το vendor lock-in που είχαμε σήμερα και προσπαθούμε να αποφύγουμε τα δίκτυα Open Run να καταλήξει σε system integrator lock-in, καθώς ο operator θα πρέπει να αναπτύξει σχέσεις πολύ μακρόχρονες με τον system integrator που έχει επιλέξει. Εδώ ολοκληρώνω την παρουσίασή μου. Σας ευχαριστώ για τον χρόνο σας.
Ευχαριστούμε πάρα πολύ, ειδικά για την επισκόπηση του προγράμματος. Εγώ θα μείνω στο τελευταίο slide που πραγματικά ίσως για μένα ήταν η πεμπτουσία, διότι το Affordable 5G είναι το πλαίσιο για κάποιες καινοτομίες, όμως το τελευταίο slide, Γιώργο, πραγματικά επεξηγεί και το πώς λειτουργεί τελικά η αγορά και το τι περιμένουμε από κάποιες διαδικασίες και το πώς ίσως κάποια από τα αποτελέσματα τα οποία προκύπτουν μέσα από ορισμένες ερευνητικές δράσεις πρέπει να βρουν το δρόμο τους προς την εφαρμογή ή τουλάχιστον να θέσει κάποιους προβληματισμούς προς αυτό. Ευχαριστώ πάρα πολύ για την αναλυτική σου παρουσίαση, τα σημεία που ανέδειξες. Προσωπικά έμεινα περισσότερο εντυπωσιασμένος από το τέλος και τη διάσταση που δημιουργείται για την αγορά.
Στη διάθεσή σας για διευκρινήσεις.
Κάναμε μια πολύ ευχάριστη παύση στα ελληνικά. Δεν ξέρω οι επόμενοι ομιλητές, ο κύριος Νεοκοσμίδης, πώς θέλει να συνεχίσει. Εξήγησα τους λόγους της χρήσης των αγγλικών, οπότε αγαπητέ Γιάννη, αφού σε καλωσορίσω σαν συνέχεια της προηγούμενης παρουσίασης που θα μας δώσεις κάποια στοιχεία για το ίδιο έργο, παράγοντες που επηρεάζουν την υιοθέτηση στην αγορά, συνεχίζεις όπως θέλεις, είτε στα ελληνικά είτε στα αγγλικά.
Καταρχήν να σε ευχαριστήσω πολύ για την πρόσκληση. Θα συνεχίσω και εγώ στα ελληνικά. Συμμετέχω και εγώ μαζί με τον Γιώργο στο έργο Affordable 5G και σαν συνέχεια της παρουσίας του Γιώργου θα μιλήσουμε για τους παράγοντες που επηρεάζουν την υιοθέτηση των ιδιωτικών δικτύων. Στα πλαίσια του έργου λοιπόν Affordable 5G κάναμε μία μελέτη μέσω ερωτηματολογίων και μιας μεθόδου που ονομάζεται Analytical Hierarchy Process, που έχει τη δυνατότητα να βγάζει ακριβή αποτελέσματα με μικρό πλήθος συμμετεχόντων. Ουσιαστικά στείλαμε τα ερωτηματολόγια, γιατί απευθύνεται κυρίως σε expert του θέματος. Στείλαμε λοιπόν τα ερωτηματολόγια σε 20 experts εσωτερικά στο έργο. Λάβαμε όλα τα ερωτηματολόγια πίσω. Τα 16, σύμφωνα με τη μέθοδο, ήταν συνεπή με την μεθοδολογία. Επομένως, βασιζόμενοι σε αυτά τα 16 ερωτηματολόγια, βγάλαμε τα συμπεράσματά μας σχετικά με τους παράγοντες που θα επηρεάσουν την υιοθέτηση των ιδιωτικών δικτύων. Λίγα στατιστικά στοιχεία για τους συμμετέχοντες. Δεν φαίνονται τα ποσοστά, δεν ξέρω γιατί, αλλά η πλειονότητα των συμμετεχόντων εργάζεται σε μικρομεσαίες επιχειρήσεις, ενώ η αμέσως επόμενη κατηγορία είναι τα ακαδημαϊκά και ερευνητικά Ινστιτούτα και τέλος είναι η βιομηχανία που ακολουθεί στην τρίτη θέση. Αν δούμε τώρα τους κλάδους των συμμετεχόντων, το μεγαλύτερο μέρος είναι στο Other, μετά ακολουθεί οι Vendors Manufacturers, Ακαδέμια και τέλος τα IT Services. Ως προς το μέγεθος τώρα των οργανισμών που δουλεύουν οι συμμετέχοντες, Το μεγαλύτερο μέρος είναι μεταξύ 10 και 20 εργαζομένων. Περισσότεροι από 100 είναι η επόμενη κατηγορία, λιγότεροι από 10 η τρίτη και στην τέταρτη κατηγορία είναι μεταξύ 50 και 100 εργαζομένων. Τώρα, ως προς τη θέση των συμμετεχόντων, οι περισσότεροι είναι μοιρασμένοι ανάμεσα σε managers και CEO, CTO. Στην κατηγορία Other η επόμενη, στη συνέχεια έχουμε τους researchers και τους R&D engineers. Πάμε να δούμε τώρα τα αποτελέσματα. Ουσιαστικά, στη μελέτη μας βάλαμε ερώτημα για 5 κατηγορίες, 5 κριτήρια και στη συνέχεια κάθε κατηγορία αναλύθηκε περαιτέρω. Η πρώτη κατηγορία είναι το performance, δεύτερη business, acceptance, flexibility και technology. Προφανώς στο performance έχουμε όλα εκείνα το low latency, το high data rate κλπ. Στο business έχει να κάνει με τη μείωση του κόστους, το πέρασμα από το CAPEX στο OPEX, νέα επιχειρηματικά μοντέλα κλπ. Acceptance, πώς δέχεται η αγορά και οι τελικοί χρήστες πώς θα δεχτούν το νέο προϊόν. Flexibility και τέλος το technology με τα small cells, edge computing κλπ. Όπως θα δούμε στη διαφάνεια, τα αποτελέσματα στα βασικά κριτήρια, θα δούμε ότι εκτός από το performance που υπολείπεται σε σχέση με τα υπόλοιπα, οι άλλες 4 κατηγορίες έχουν περίπου το ίδιο βάρος σύμφωνα με τις απαντήσεις των συμμετεχόντων. Αν πάμε να αναλύσουμε κάθε μία από τις κατηγορίες, πρώτα απ' όλα έχουμε το performance, όπου όπως είπαμε συμπεριλαμβάνει low latency, high throughput, efficient energy consumption, reliable communications και resiliency. Θα δούμε ότι μακράν το reliable communications είναι στην πρώτη θέση με το μεγαλύτερο βάρος. Αυτό κυρίως οφείλεται γιατί οι περισσότερες εφαρμογές, τουλάχιστον προς το παρόν, των ιδιωτικών δικτύων έχουν να κάνουν με βιομηχανικά περιβάλλοντα, επομένως οι αξιόπιστες επικοινωνίες είναι το χαρακτηριστικό και ο παράγοντας των επιδόσεων που ουσιαστικά έχει τη μεγαλύτερη σημασία. Στη συνέχεια, στο δεύτερο παράγοντα, στο business, έχουμε μείωση κόστους, CAPEX, μετατροπή του CAPEX σε OPEX, νέα επιχειρηματικά μοντέλα και νέες ευκαιρίες στην αγορά. Εδώ βλέπουμε ότι υπερισχύει με μεγαλύτερο βάρος οι νέες ευκαιρίες στην αγορά, ακολουθούμενοι από τη μείωση κόστους και από τη μετατροπή CAPEX και από τα νέα επιχειρηματικά μοντέλα. Θα σταθούμε κυρίως στις νέες ευκαιρίες στην αγορά. Ουσιαστικά αυτό που απάντησαν οι συμμετέχοντες είναι ότι με την υλοποίηση τέτοιων ιδιωτικών δικτύων, αυτός που έχει πια το δίκτυο έχει ένα συγκριτικό πλεονέκτημα σε σχέση με τους ανταγωνιστές του και πιστεύει λοιπόν ότι έτσι θα αυξήσει την κερδοφορία του και θα αυξήσει προφανώς την παραγωγικότητά του και την αποδοτικότητά του. Στην επόμενη κατηγορία, το acceptance, οι υποπαράγοντες είναι advanced applications, ease of net deployment, security and privacy, regulatory issues, health and environmental issues. Εδώ βλέπουμε ότι με το μεγαλύτερο βάρος έχουμε πρώτα απ' όλα το security privacy, ease of network deployment, health and environmental issues και ακολουθούν advanced applications και regulatory issues. Όλος παραδόξως τα regulatory issues είναι στην τελευταία θέση. Παρ' όλα αυτά, κατά τη γνώμη μας, ίσως θα έπρεπε να παίζουν κάποιο μεγαλύτερο ρόλο, γιατί υπάρχουν πολλά θέματα ως προς τα ιδιωτικά δίκτυα σε συνδυασμό με καινούρια μοντέλα όπως είναι ο neutral host κλπ. Μέσα στα δίκτυα αυτά. Ωστόσο, πάμε να εξηγήσουμε λίγο τους παράγοντες που υπερέχουν, κυρίως το security and privacy και το ease of network deployment. Όπως είπαμε και πριν, επειδή οι περισσότερες εφαρμογές, τουλάχιστον προς το παρόν, έχει να κάνει με βιομηχανικά περιβάλλοντα, το security και privacy είναι από τους πιο σημαντικούς παράγοντες. Τα ιδιωτικά δίκτυα υπόσχονται αυξημένο security, κυρίως αν το ιδιωτικό δίκτυο είναι αυτόνομο και δεν χρειάζεται να βγαίνει προς τα δημόσια δίκτυα των παρόχων. Επομένως, τα δεδομένα παραμένουν μέσα στην περιοχή του ιδιωτικού δικτύου. Και στη συνέχεια, ease of network deployment, στη δεύτερη θέση, κυρίως επειδή νέοι παίχτες εισέρχονται στην αγορά, ακόμα και οι ίδιοι εμπλεκόμενοι, παραδείγματος χάρη ένα εργοστάσιο, θα μπορούσε εν δυνάμει να αναπτύξει και να διαχειριστεί ένα ιδιωτικό δίκτυο. Επομένως, το να μπορεί κάποιος να το αναπτύξει και να το λειτουργήσει με σχετική ευκολία είναι σημαντικό. Στο flexibility, οι υποπαράγοντες είναι resource and spectrum sharing, interoperability, SLAs tailored to needs, needs-based configuration, network operation automation. Βλέπουμε ότι οι δύο παράγοντες που υπερισχύουν είναι το interoperability και το network operation automation, και οι δύο παράγοντες σχετίζονται και αυτοί με τα βιομηχανικά περιβάλλοντα, με την αλληλεπίδραση και την διαλειτουργικότητα των συστημάτων και προφανώς στην αυτοματοποίηση των λειτουργιών των δικτύων αυτών, που σε συνδυασμό με αυτό που είπαμε πριν, ότι μπορεί και οι εμπλεκόμενοι, ακόμα και κάποιο εργοστάσιο, να αναπτύξει ένα δίκτυο και να το διαχειρίζεται. Επομένως, όσο περισσότερο αυτοματοποιημένο είναι, τόσο ευκολότερη είναι η λειτουργία και η συντήρησή του. Τέλος, το technology. Έχουμε 4 παράγοντες: Open Platforms, Open RAN, SDN-NFV, Cloud Native και Edge Computing. Πάλι με διαφορά 2 παράγοντες: Open Platforms, Open RAN και Edge Computing. Το Open RAN είναι κάπως αναμενόμενο, καθώς το έργο Affordable 5G βασίζεται στις ανοιχτές διεπαφές, με σκοπό να εκμεταλλευτεί τα πλεονεκτήματα που προσφέρουν. Ενώ το Edge Computing, η υπολογιστική άκρου, έχει να κάνει κυρίως με τα χαρακτηριστικά που χρειάζεται ένα ιδιωτικό δίκτυο, ιδιαίτερα σε βιομηχανικά περιβάλλοντα, όπως παραδείγματος χάρη να είναι τα δεδομένα όσο το δυνατόν πιο κοντά στον τελικό χρήστη, πετυχαίνοντας έτσι ακόμα και χαμηλή καθυστέρηση, που είναι πολύ σημαντική, ιδιαίτερα για περιβάλλοντα μέσα σε εργοστάσια. Κάποια σημεία έτσι για να ανακεφαλαιώσουμε σαν τελευταία διαφάνεια. Εκτός από το performance, οι 4 άλλοι παράγοντες, business, acceptance, flexibility και technology, είναι περίπου της ίδιας σημασίας. Έτσι λοιπόν οι vendors και οι providers πρέπει να δώσουν την ίδια περίπου σημασία για την ανάπτυξη κατά την ανάπτυξη των δικτύων αυτών και τέτοιων λύσεων. Οι υποπαράγοντες, ευκολία στην ανάπτυξη δικτύων, flexibility και interoperability, καθώς και, όπως είπαμε, και τα new market opportunities, είναι οι υποπαράγοντες που ξεχωρίζουν σε σχέση με τους υπόλοιπους. Και τα ευρήματα της μελέτης αυτές είναι σημαντικά για όσους εμπλέκονται στην ανάπτυξη και λειτουργία ιδιωτικών και επιχειρηματικών δικτύων, έτσι ώστε να επιταχυνθεί η ανάπτυξη τέτοιων λύσεων, όπου κυρίως στη χώρα μας παραμένει σε πολύ χαμηλά επίπεδα. Νομίζω έχουμε η μία ή 2 υλοποιήσεις. Μία σίγουρα είναι στις Κοσμοτές στην Καλπάκ, και νομίζω ότι υπάρχει κι άλλη μία στο Χρυσό, στα ορυχεία στη Βόρεια Ελλάδα. Κλείνοντας, θέλω να τονίσω επίσης, αν και δεν φάνηκε στη μελέτη, την σημαντικότητα του φάσματος και του τρόπου εκχώρησης του φάσματος. Στη χώρα μας, όπως και σε άλλες χώρες, δυστυχώς, η εκχώρηση έχει γίνει αποκλειστικά στους παρόχους, χωρίς να δεσμεύεται φάσμα για άλλες λειτουργίες. Πιστεύουμε ότι εκχώρηση τοπικού και αποκλειστικού φάσματος για ιδιωτικά δίκτυα θα βοηθήσει πολύ στην επιτάχυνση και στην επιτυχία των ιδιωτικών δικτύων, που αναμένεται να έχουν πολλά πλεονεκτήματα στο μέλλον. Νομίζω αυτή ήταν η τελευταία μου διαφάνεια. Ευχαριστώ πολύ.
Και εγώ θα ήθελα να ευχαριστήσω τον αγαπητό Γιάννη, τον κύριο Νεοκοσμίδη, για την παρουσία του ακόμα μία φορά στις εκδηλώσεις μας στην Infocom, για τα πολύ ενδιαφέροντα στοιχεία που μας ανέδειξε, για τις πολύ σωστές επισημάνσεις του και τους προβληματισμούς του ενίοτε, που συμμερίζομαι αρκετούς από αυτούς, αν κατάλαβα καλά, καθώς η προσέγγιση αφορούσε σε βιομηχανικές εφαρμογές. Αν βλέπαμε κάποιον άλλο τομέα, μπορεί κάποιοι από τους παράγοντες, και εύλογο θα ήταν, όπως η διαχείριση του φάσματος, ιδίως το ρυθμιστικό πλαίσιο, να είχαν πολύ μεγαλύτερη αξιολόγηση, θετική ή αρνητική. Παρ' όλα αυτά, είναι πολύ ενδιαφέρον να βλέπουμε αυτή τη μεθοδολογία, αυτή την προσέγγιση, για να κατανοήσουμε τελικά
το πώς την χάνουν εφαρμογής τα τεχνικά ή τα τεχνολογικά αποτελέσματα και οι καινοτομίες μέσα στην αγορά. Ευχαριστώ πάρα πολύ για μία ακόμα φορά. Αν δεν υπάρχει κάποιος άλλος να θέσει κάποιο σχόλιο, θα περάσουμε στην επόμενη ομιλήτρια. Ευχαριστούμε πολύ, Γιάννη. Είναι η αγαπητή συνάδελφος και στέλεχος της υπηρεσίας μας, κυρία Μαρία Μπελεσιώτη. Μαρία, δεν ξέρω εσύ θα τα πεις στα αγγλικά, γιατί είναι καινούργιο το project, όπως θέλεις.
Εντάξει. Τώρα και ο Γιώργος και ο Γιάννης τα είπαν στα ελληνικά, εγώ μάλλον θα τα πω στα αγγλικά, γιατί δεν μου βγαίνουν πολύ οι ορολογίες στα ελληνικά εμένα. Με λένε Μαρία Μπελεσιώτη, λοιπόν, είμαι και εγώ από το ΝΟΤΕ, από το Τμήμα Ερευνητικών Προγραμμάτων Σταθερής. Και το πρόγραμμα που θα παρουσιάσω ονομάζεται NEMO. NEMO is from the initials of Next Generation Meta Operating System. It's a project that started last September, and 26 partners from 9 different countries are participating, with Thanatos leading this effort. The contribution, the EU funding, is 10.5 million, and from Greece, besides OTE, Space Hellas, Synelixis, Entersoft, and ICCS are participating. The motivation for this project was the Internet of Things ecosystem growth. And the applications, the large number of applications that leverage data and metadata from connected things, moving from the IoT, the Internet of Things as we know it, to artificial intelligent Internet of Things. To this transition, to this path, many difficulties have arisen, such as the insufficient, real-time, secure, and trusted support from the edge cloud, and the fact that intelligence should be closer to data, but it is not. So, to this end, the project, NEMO project, aims to define an adaptable MOS architecture that will bring intelligence to the device. Our aim is this architecture to address both technical and business challenges, and to extend 5G network services in the control domain. Scalability will be considered as well at design level via deployment of lightweight cloud-native and edge-friendly open-source technologies. And since security threats and are difficult to avoid them, we will consider proactive processes so as to mitigate system and data threats. For this reason, several current and emerging technologies will be studied, evaluated, and partially adopted in this project. Okay, in terms of technological innovations, NEMO will address full stack, fully configurable, cloud-native and data-aware meta-operating system. And as I said earlier, it aims to bring intelligence closer to data and make artificial intelligence an integral part of the system. Cybersecurity and privacy will be considered as well. And the European competitiveness is expected to be stronger. Technical, economical, environmental, and social impact is expected from this project. And due to the fact that a meta-operating orchestrator will automatically reconfigure each node so as the federation to operate optimally under the policies that the administrator has provided. So, 4 pilots have been considered, 2 in Greece, 1 in Italy, and 1 in Germany. Smart farming and smart media and extended reality will be held in Greece, and smart energy and smart mobility in Italy, smart manufacturing and industry 4 in Germany. The verticals that we address through these pilots are farming, energy, mobility and transportation, industry 4, and media and smart city and extended reality. Regarding the first application of a smart farming pilot is the aerial precision biospraying. In this case, we aim to spray with drones equipped with multispectral cameras, olive trees, and the spraying procedure will be enhanced with thin-field data. In this case, the drone will decide which trees it will spray, so as we can see the intelligence has moved to the device. The same case is with terrestrial precision biospraying that will be held with angry robots, smart enough to avoid workers and trees. In this case, besides location tracking of trees and people, the robot will also decide where to spray. So again, we have the intelligence moved on the device. The technologies involved are spanning from sensors, measuring air temperature, humidity, wind direction, rain, leaf wetness, soil, moisture and temperature, to drone and mobile robots, image and video processing. We will also have a cloud and edge and the machine learning techniques, and of course all this will be supported by a 5G network offered by OTE. The second pilot will be in Italy. It deals with energy and smart mobility. The first application, smart grid flexibility, aims to monitor and analyze of medium voltage and low voltage electricity quality, and with the use of power sensors, innovative power sensors. The second is about proposed driver-friendly scenario based on traffic flow and parking prediction. In these applications, electric vehicles will be used in Italy. Now, this Industry 4 pilot was motivated by the need of mass autonomous production and the factories of the future, that is the demands of Industry 4. And of course, safety and the security of the people working in these factories. High-speed networks will be used, such as 5G new radio and time-sensitive networks, and Wi-Fi at AGVs in the factory. It considers the 2 applications as well. The first one aims to fully automate control material picking from AutoStore and autonomous transfer them to the production line. And the second one, νομίζω ότι έκανε σεισμό επηρεασμένη από το πρωί. The second one has to do with safety of the workers, where with the assistance of cognitive sensors such as safety cameras and radars, the position of each worker could be detected so as to be safe in the factory where he works. This pilot, Smart Media, City and Extended Reality, regards very fast and time-sensitive services migration to the edge with the use of extreme large media from thousands of users. It could be held in Athens, Greece, and it considers again two applications. The first one is the round of Athens race. And the challenges of this application has to do with real-time user-generated content, huge in volume, and content processing, and federated machine learning techniques will be used. The extended reality machine is going to be piloted in the planetarium here in Athens again, and here it's expected a great number of users to interact with virtual, augmented, and extended reality, spanning from a virtual tour in Athens, Greece, to a new dinosaur world that will be created. NEMO is going to have 4 living labs, one in Monevassia, where the biospraying use cases will be held, one in Terni, Italy, one in Ingolstadt, Germany, and the final one is in Athens. So to this respect, cross-platform seamless access to more than 30 types of sensors, drones, technologies, and smartphones is expected in this project. And 4 clouds will be used for the needs of the pilots, one in Greece, one in Italy, Germany, and Spain. And we hope that we will have a microservice migration between all these clouds. We hope that, as I said earlier, that the project has just started. And we hope that next year in the same conference we'll have more news to tell you about how our pilots are proceeding and how our work is evolving. Thank you very much for your attention.
Thank you very much, Maria, for this interesting overview of the opportunities and the challenges, because, as you mentioned, the project has just started. However, I think it became clear to the audience what the targets are, the priorities, and what is expected to be done. By my side, I would like to focus on the fact that, as you may find out, Industry 4, smart cities, extended realities, energy are among the forefront of applications promoted by the European Commission, and this will also affect investments and opportunities for growth in the related national markets as well. Thank you again for supporting the event, Maria.
Thank you very much.
Okay, in order to accelerate somehow, I would suggest with the next session, which is about the 5G innovations for verticals with third-party services. I'm saying so because one of the final speaker will not come, so we will have 3 instead of 4
speakers, and at least I see, okay, two among the speakers here. This is actually a session dedicated to the ICT 41 call, which is about the development of network applications for serving the market. These are based on VNFs in order to support verticals. Once again, the term vertical. I would like to invite, first of all, Mr. Dr. Costas Ramantas from iQuadrat, Spain. He will present the 5G Media Hub project, which is a 5G experimentation environment for third-party media services. And once again, my great thanks to iQuadrat for their continued support to the event.
Thanks for the kind introduction. So, hi all. This is Kostas Ramantas from iQuadrat Informatica. I am also the project coordinator. So, just a couple of words about iQuadrat, which is coordinating this effort. We are quite experienced in such research projects, which are funded by the European Commission with multiple ongoing and multiple concluded projects. So, an overview of 5G Media Hub. You can see that it's one of the ICT 41 projects focusing on innovations for verticals and building these so-called network applications, which we'll in short see. So, the aim and motivation of the project is basically to serve the media industry and accelerate the testing of media vertical applications through an experimentation platform which tries to cater to SMEs. So we're basically leveraging on some existing testbeds, some private 5G testbeds from previous research projects, and trying to make them accessible to some outside companies and SMEs. These are academic testbeds mostly. So what we are doing is we are building a set of experimentation tools which will make it much easier to interact with these, let's say, mostly academic testbeds which are used in this project. So these are federated, the existing testbeds. We are building these net apps, which we will in short explain what it means, and trying to also bring together the media community and the telecom network community. These are two very different communities and often speak not the same language. So this is also another challenge. So what are the net apps? This term has been gaining traction with the community. This was actually proposed by the European Commission as a term, the term net app. So the ICT 41 projects have started defining exactly what they are. The net apps, the consensus is that they are basically middleware. They are not applications. They are not over-the-top applications, just to use the telco terminology. They are middleware, so they sit right here in the middle, between the infrastructures, which is at the bottom, the testbeds, the networks, the servers, and the over-the-top applications. So the net apps are basically middlewares. They expose some southbound APIs towards the application, towards the infrastructure, trying to abstract the details, and have some northbound APIs towards the application. As an example, a streaming server could be considered as a net app. It offers, for example, some streaming APIs, and some application examples could be, for example, YouTube, or some similar application which actually is user accessible. So the net apps are basically targeting the developers. 5G Media Hub implements such net apps. And some examples of net apps that we're developing are, for example, as I said, the streaming server net app. We implement net apps for virtual reality applications. We implement content distribution network net apps, or CDNs, and also net apps for interactive 8K content. Also, one of the project outcomes is the cross-domain service orchestrator. which is basically a system which automatically manages and orchestrates these NetApps. It's basically a centralized component right here. And the NetApps are onboarded at a repository, which is like a marketplace, basically. And then the cross-domain service orchestrator is responsible for the instantiation of the NetApps at the testbeds and manages their whole life cycle. So starts, stops, and potentially uses load balancing. Also, as mentioned, important project outcomes are some experimentation tools that we are building that basically serve some SMEs or third parties that want to do some experiments and performance evaluations, either of their own NetApps or from some existing ones. So we're building this web-based portal, which allows easy access to these NetApps and easy access to the tools, like a validation and experimentation engine or a resource reservation engine to set up some experiments. And let's explain why these things are useful through some business models which we have defined. So 5G Media Hub caters first to developers, as I said. So the developers are given a 5G platform, and there they can perform some tests and use these tests for optimization purposes. They can optimize their applications and basically test some bleeding edge features of 5G, which may not be available in commercial networks, like 5G standalone, which has not yet been widely deployed, or edge computing. We call this business model the testing as a service. So the developers can basically pay to gain access to this platform and do some performance experiments of their applications. So some use cases to really showcase our platform. One is the 360 VR. So we are building this, as mentioned, NetApp to facilitate 360 VR over-the-top applications, which facilitates the implementation of virtual reality applications through which basically supports this viewport streaming, as we call it. So we take this 360-degree sphere, and in order to avoid transmitting all the sphere in real time, which needs a lot of bandwidth, we only stream the viewport, so exactly where the user can see. And keeping track of the orientation of this VR headset so that we can always stream where exactly the user is looking at. So this functionality is offered by the middleware, the NetApp, and really speeds up the development of such applications. We also implement a remote broadcasting pipeline. This allows the OB vans, which are typically used, for example, in football games, to be replaced by remote broadcasting pipelines. So this means that instead of having a camera crew or a director at the field, you can have them at the studio. So you stream all the camera angles and all the camera streams, and then the director can basically select which one will be broadcasted remotely. And this saves costs for, from the whole system. Then we have the co-creation use case, where we have joint music performance, where we can have we can have musicians in different sites, and also the audience can be on a different site, and the whole performance can be streamed remotely through 5G. And then we have this very innovative interactive 8K application, which is called basically Interactive Digital Narrative, or IDN, where you have the first screen with the main content and a second screen, like your mobile phone, and you can use this to interact with the main narrative. So you can change the story with the second screen. And finally, we have a multi-CDN application. This is for the distribution part of the media industry, where we have a multi-CDN net app, with a management console that can help select the optimal CDN and optimizes in general some parameters related to the distribution of content and exactly which content has to be cast and in which site. So, thanks a lot.
Thank you very much, Dr. Ramandas, for this very interesting presentation, covering aspects from the media industry, how network applications may be used in dedicated scenarios. We continue this session. I would like now to invite Mr. Dimitrios Frangos, researcher from the National Center for Scientific Research, Demokritos. Many thanks for joining this event.
Thank you.
He will present some findings from the Evolved 5G project. So the stage is yours.
Thank you very much for the invitation. So my name is Dimitrios Frangos. I'm a research associate at Media Networks Lab at NCSR Demokritos, and I work with Dr. Harilaos Koumaras, which is the technical manager of the Evolved 5G project. And in the context of this project, I would like to present you one of our major activities, which is the development of a network exposure function simulator. So a brief introduction about 5G programmability. When we talk about 5G programmability, we refer to the 5G core network, and specifically in the service-based architecture that enables the internal communication of the 5G core network functions through APIs. In 3GPP, and especially in SA6 group, they really like the RESTful paradigm, so they decided that the exposure of the services will be delivered through RESTful APIs. So you can see from the figure on the right, the framework of SA6 group, where we have different components. We have the northbound APIs there. We have the vertical application enablers, which are close to the vertical applications offered by the vertical industry. We have the SEAL, some auxiliary APIs. We have some edge computing APIs, and then we have this standard common framework called CAPIF to manage and expose securely these APIs to third-party applications. And beyond that, 5G programmability also enables the bidirectional communication between vertical apps and the 5G core network. So on the one hand, the applications can retrieve information from the 5G network, and on the other hand, they can influence how the network works. So here we have the network exposure function. This work pre-exists in 3GPP specifications from release 15 in LTE Advanced under the name Service Capability Exposure Function, and it belongs to the northbound APIs. And the main role is that it exposes the standard APIs that are based on the Open API specification to external applications that, in the context of ICT 41 projects, we call them NetApps, network applications. And one of the main features is that it hides the complexity of the underlying network, as you can see from the figure on the right. NEF is on top of the service-based architecture, and also it is a secure manner to expose these services. And finally, it can enable monetization for the mobile network operators. So here we have the architecture of the NEF simulator. Why a simulator? So as Dr. Amadas mentioned earlier, there are no commercial 5G deployments that support the service-based architecture entirely and expose these APIs between the network functions. So the need arises from the fact that in order to expose these services, the NEF needs to communicate with the southbound APIs, and these southbound APIs do not exist currently in any commercial solutions. That's why we created a simulation environment which is based on an inherent characteristic of mobile networks, which is the mobility. So that's why we have predefined paths in our simulation where UEs are moving and we simulate events. So at this stage, we support two APIs, the monitoring event API and the AS session with quality of service API. The monitoring event API supports some events that have to do with user equipment's life cycle within the 5G network. And the quality of service API enables applications to choose quality of service flows to ensure better service experience. And also we have a common management layer when the users, the NetApp developers, need to create an account and then they can define their own scenarios. So here is an example of NEF Simulator's dashboard where users can create, update, delete, and monitor their components. For example, the UEs, the predefined paths, and the cells. Here we have the geographic representation of a scenario at the Democritos premises. You can see users moving and creating and triggering all these events in order to be exposed by NEF. And regarding some security aspects, in the implementation, we cover most of them. First of all, we support mutual authentication based on client and server certificates using the TLS protocol. And also through TLS, we provide integrity, replay, and confidentiality protection through the N33 interface between NEF and application functions. And after the authentication and the encryption of the data, a no-auth-based authorization step follows in order to receive a token to send the HTTP requests to the APIs. And finally, an important aspect is that in the APIs, we do not expose permanent identifiers like SUPI, which is the identifier of the SIM card, and this is associated with an external identifier that it is exposed in the applications. Okay, another aspect of NEF is the service consumer and service producer model. This is same as a client-server model, but this is in 3GPP terms. And we have an application, and we have the NEF simulator. And besides direct HTTP requests and responses, we support the subscribe notify mechanism, which is actually an application sends an HTTP post request message to declare interest and make a subscription through the simulator, and then subsequently the simulator sends an acknowledgement with a 201 created message, and then if an event occurs in the 5G network, then we notify the application with an asynchronous post notification. So here the NEF is the service consumer, the client, and the application is the server. Here is an example of the AS session with quality of service API. How this API works is that applications, NetApps, in our case, can request quality of service from a set of standardized values. Here is an indicative table with standardized values. In order to receive the notifications that the quality of service can be guaranteed or not, the applications need to choose a guaranteed bitrate flow. And we support both periodic and event trigger reports. The periodic reports can be every 2 or 5 or 10 seconds. This is defined by the application. And the event that triggers the notification is the handover. On handovers, we notify the application that the quality of service can be guaranteed or not. Okay, here is an example of the simulator that sends an HTTP post request to a network application that the quality of service is not guaranteed. Okay, to conclude the presentation, this NEF simulator is an open source project. As I said earlier, we have no commercial solutions. We know that it's in the roadmap of many vendors like Ericsson, Nokia, but we provide an open source implementation of NEF. You can find the project on this GitHub page. And as a future work, we try to implement some additional NEF APIs and integrate NEF with Open5GS, which is actually an open source solution that realizes the 5G service-based architecture. And so we try to skip the simulation part and make an actual deployment of a 5G system. And that's all from my side.
Thank you, Mr. Frangos, for giving us these views based on the Evolve 5G project. Very interesting, still ongoing. My great thanks to Dr. Kumaras as well. And potentially we will remain in the Evolve 5G framework in the industry forum environment. And I will invite the next speaker on behalf of Infolysis, Mr. Nick Vrionis, to give some related information about the intent-driven chatbots for precise management.
Thank you. Thank you, Mr. Kochouliouros, for the invitation. My name is Nick Vrionis, and based on Dimitri's previous presentation about NEF in Evolve 5G, I will present our contribution to the project. First, a few things about Infolysis. It's a Greek SME located in Athens. At this point, we count 15 members personnel, and we are specialized mainly in development of chatbot applications. We have chatbots for many reasons: anonymous feedback, complaints in management, surveys, contents, training, and reporting, as we will see in next slides. Infolysis has two parts. It has a commercial presence in many fields like retailing, marketing, tourism, and education, but also in various research activities, focused on IoT mainly and 5G applications. We participated in European Commission-funded projects and open calls. Some of those are 5G Genesis, 5G drones, Evolve 5G that we will talk about more later, Assist IoT, Smart 5 Grid that I think you talked about earlier in the morning, and second. We have different roles like leading impact and communication activities, and as well development and contribution in several use cases. Fields of disaster recovery, UAV, smart cities, training, and Industry 4 solutions. Some of our research interests are chatbot application over IoT environments, chatbot application over 5G for Industry 4 and training, like we see today, containerization, visualization, IoT interoperability and VNFs, also some IoT virtual gateways with DPI functionalities, and in general, deep learning and NLP technologies. So we have already a Viber-based chatbot, as well as a web-based platform for our applications. For those that don't know, chatbot applications are simulating human conversation. Basically, primary and flows, we can see some examples in the pictures here. There are multiple choice questions, answered with questions with free text, like here, or upload some files. The chatbot assistant app developed with Evolve 5G project is based on our web-based version of the chatbot platform, and it's self-connecting with the factory environment. It's in a non-public network. So here we can see a general overview of the Evolve 5G project. There are 11 SMEs in 4 pillars, which create their vertical apps. The project targets, as I said, a non-public network for the Industry 4 sector. As you see before, the APIs, they enable the vertical apps with aid of network application consume the 5G core and the different APIs. Also, the development of a net app has some input for different from previous projects like Tango and 5G Genesis. And here we can see the 4 pillars of the project. We are in the first pillar with innovation interaction of employees and machines through augmented reality features and remote control capabilities. The rest pillars are efficiency in FF operations with novel predictive maintenance applied on digital factory, security guarantees and risk analysis for the FF communication and management system, as well as agility in production, line infrastructure through automation and robotic parts. So a little more about our solution. We're in the first pillar. For our application, we take advantage of the indoor location 5G provides, so we can offer a solution for automating some time-consuming procedure in factories, especially reporting of problematic issues with machinery and equipment. We have a chatbot application that will facilitate these procedures. So let me show a more detailed view of this use case with this flowchart. Here we have the user. First, it's logging in the system and provide the necessary authentication information for accessing factory files, factory areas, etc. So when a user spots a problem, it initiates the chatbot. So then we go and from the 5G we get the location information, so we can know in which part of the factory the user is located. So then the user can see the machinery in the area he is currently in. And we initiate an authorization procedure. So when he has access, then he gets manuals and respective maintenance documentation to see if he can solve the problem. If this isn't the case and the user doesn't have authorization or there is a problem, there is an appropriate message and some other personnel is called based again on the location of the other workers, maybe a more authorized personnel or a better suited colleague. So here we can see, you saw that in the previous presentation in Demokritos, it's like we are in a factory, the different areas. It's the cell towers, the antennas here. The workers are working, and if they found a problem, they get to report it. we will see a small demo at the end of the presentation. We're going to see live this here. And also, this is lately developed. It's a dashboard for creating more users, adding more machines, and more incidents, maybe to keep track of what is happening in the factory. So here, I think, here is a video, a demo, a small demo. Okay. So here is a worker inside the factory. And this is the chatbot application. Now I assume that the worker found some problematic machine and he started the issue to... This will be the manuals of the machine. Each time the worker finds the problem, he reports the problem, he sees which machine has the problem, and he sees all the relatively files for the machine. This is the dashboard that Dimitri showed you previously. Now that the worker changed area, there are no machines here, so there is nothing to report. Always he is located by 5G functionality, so I think the video has ended. So I'm not sure if there are any questions. I sped that up because we're a bit late, so I thought to save everybody some time. I think not.
The session for your presentation,
It was our pleasure.
which faces practical challenges, actually, and implicates for applicability in the market sector. I hope you will promote this and proceed to next results. By my side, I see that this can be applicable not only, let's say, in industrial applications, but also in other applications as well.
Yes, we have many areas, so we're working.
Thank you again for joining.
Thank you. Thank you.
As I mentioned before, the next speaker will not be able because he declared he had some difficulties with his health. So this has been taken into account. So more or less we are according to the schedule. We can have a 10 minutes break now because we had two sessions subsequently, and then we will continue with the 5G induced dedicated session. Okay. Unless, Christina, you desire starting just right now for the economy of time, but we can have a 10 minutes break if you desire. Thank you again. session, the 7th in turn, hopefully, which is based on the scope of the ongoing 5G in use project. First of all, I would like to express my thanks to the invited speaker, Dr. Chiara Lombardo, Mr. Manuel Lorenzo, Professor Franco Davoli, and of course my colleague Cristina Lessi from OTE. Thank you for joining this session. Some apologies for an issue which is not our responsibility, although we have provided the updates in the project, in the program. Finally, these leaflets have been finalized almost 10 days ago, as far as I have been informed, but in any case, the website, if not already updated, it will be updated, and it will be accessible. Your presentations can be uploaded once we get your consent for this, and we will also have this live video streaming. We have the website. They will also send us the video, so it's a sort of apology, but unfortunately it's not under the full scope of our responsibility. Now I will give the stage to my colleague, Mrs. Cristina Lessi, who will be the chairman of this session. Thank you again for joining, for coming, and Cristina, thank you for supporting this 5G in use session in the event.
Hello, welcome to session 7, which is about innovations coming from a 5G Induced program. 5G Induced program targets the development of an open edge network functions virtualizations compatible 5G orchestration platform for the development of advanced 5G network applications. The project focuses on the Industry 4 vertical sector as one of the fastest growing and most impactful sectors in the European economy. We will start with the presentations of this session, and at the end there will be time for questions if there is any. During this session, both the platform and the experimentation facilities that will be implemented for the use cases validation will be presented. So, let's start with the first presentation, 5G Induced Platform Design for Industrial Sector Network Application, which will be presented by Dr. Chiara Lombardo from CNIT.
Okay. Good afternoon, everyone. As already introduced by Cristina, the 5G Induced project has the ambition to build open and cooperative 5G network platforms to the goal of helping with the evaluation and the showcasing of the network and services and vertical applications in the scope of 5G, especially related to the Industry 4.0 context. Specifically, 5G Induced wants to provide realistic experimentation facilities to provide the seamless deployment of network functions, and in this way helps to form the building blocks of the market-oriented industrial applications, while at the same time providing an attractive platform for service providers. Specifically, this presentation will be about the platform that the project is helping developing. And the platform has the goal of managing applications on top of programmable 5G slices. A further ambition is to bridge the gap between the application and the 5G network domains. To do that, we want to enable vertical application developers and service providers to design and deploy 5G-ready applications in an easy way. So the goal is to help integrating common microservice design patterns similar to the ones that have been known for ages in the context of cloud computing. And with the same tools, same familiar tools, bring them forth for the following deployment over the 5G infrastructure. So familiar tools over new technologies. And in this way, we hope that the deployment of 5G-ready applications over the 5G infrastructures will be smoother. And we also aim to include the automatic provision of supporting 5G network slices in the process. So specifically, the proposed platform wants to hide the complexity of the 5G environment underneath, so that the application developers can forget about the minutiae of the actual technology that they're using. And as I was saying, just focus on their deployment that can be performed in an environment that they already know very well. This is an overview of the platform architecture. So we're dealing with three main domains. The first one on top is the applicative domain, and it corresponds to the network application orchestrator, which is one of the two main modules that compose the 5G-induced platform. The second one being the operation support system, which is actually an extended OSS that is, can be identified with the telco administrative domain. And finally, we can identify the infrastructure domain, the one related to the experimentation facilities, which will not be covered in this presentation because it will be then the object of the three presentations that you will see after this one. We're focusing on the now and the OSS in this presentation. So the applicative domain and the telco administrative domain. And so this is exactly what we call the 5G-induced platform. And now I'm going to briefly comment on each one of the functions composing these modules. So talking about the administrative domain, we start with the Graph Composer here, which is a tool that helps the composition of the actual application graphs, starting from the register components and defines the dependencies between components, which means the actual links that join the components of an application. After that, we have the constraint editor that, given these links between two components, allows defining the network requirements and the constraints that need to be fulfilled during the placement of the vertical application. Next, there is the policy editor that, given this application graph and given the requirements and network constraints, allows to declare the high-level runtime policies that have to be applied during the operations of the associated application graph. And finally, deployment manager that helps with the deployment and afterwards with the lifecycle management operations on all the components of the vertical application. So given an application composed in this way, it is then necessary to deploy it actually. This is performed with the interaction between the now and the OSS, so the application and the telco domain, by using a slice negotiation. So we have the negotiation of the initial application graph annotated with quality of service and operational requirements that needed to be fulfilled by the infrastructure underneath. And this is negotiated with the OSS by using the modules, the tools that I'm introducing now. It's worth noting that I'm giving further details in a moment about how the actual slice negotiation and instantiation takes place. So moving to the telco domain, we start with the northbound OSS, which is the counterpart of the slice negotiation here on top. And it is the component that has the purpose of managing the slice negotiation from the OSS, from the telco platform point of view, and to maintain the metadata on the already onboarded modules. After that, we have what we call the core of the OSS that is divided into two subcomponents. One is northbound, and there's only one for each telco domain, which is basically a high-performance session manager that has to dispatch the slice intent requests against the resources that are available in the telco domains that it manages. The southbound core instead is a module, a component that is split in each one of the experimentation facilities that are handled by the 5G induced platform, in the sense that it has to verify the presence of the required resources in its domain, depending on the available programmability level. This is very important because the platform allows to handle different levels of programmability, because the experimentation facility necessarily not have all the same capabilities, do not expose the same APIs, and do not allow the same degrees of freedom in handling the computing and network resources. So for simplicity, in 5G Induce, we have defined the 3 levels of programmability. And these are the ones that are represented in the experimentation facilities of the project. The left one is the most basic, which is black box resources. So in these experimentation facilities, we only have an available set of pre-computed, pre-designed network slices, and so the southbound core only can take a look at them, see which one is the most suitable, and proceed to its deployment. Second level is the partial programmability. So there are custom APIs. For example, we rely on the standard NFV-SOL 006 for this level of programmability. And finally, for testbeds that allow the deeper level of programmability, we can have different degrees of freedom. For example, we can have a network, an NFV convergence layer to manage the life cycle of NFV services and provide the required connectivity towards the network application, towards the vertical application and the user equipment. Or we can even go down below, down to the metal level. So with different degrees of handling directly VIMs, operating systems, or even bare metal resources, all with the same platform. So how do we proceed with the slice intent request and materialization? So you already can understand that there's an interplay between the now in the application domain and the OSS in the telco domain. So these are the following steps. At the beginning, the now sends to the OSS, and in particular to the northbound OSS, a request, which we call a slice intent, that has the description of the application graph, of the network requirements, and of the constraints that it has. Upon reception of this meta model, what we call the slice intent, the northbound part of the OSS, the northbound core, checks it and checks it against the resources that are available in the different administrative domains that are managed with the 5G induced platform. The first one of these registered southbound cores, so the component that we have in each one of these experimentation facilities, the first one that confirms that has the ability to support this kind of deployment, so has enough resources and can fulfill the network requirements, that's the one that is chosen for the actual deployment. At that point, given the choice, the northbound OSS gives back to the now the communication that we have a candidate for the slice materialization. So we found a physical test bed that can support that deployment. And here's the kind of slice that we would like to deploy to support your application. If the now accepts the proposed slice, the northbound core then asks downstairs to the southbound core to actually proceed with the materialization of the slice and then waits for a confirmation that everything went well. At this point, the steps that follow depend on the levels of programmability that I described before. In the case that, only a simple catalog of slices is available, you pick one, you say we got it, and you proceed with the instantiation. If you have a different level of programmability, for example, the configuration of the configuration of some level of the domains, you can handle the programmability with the ETSI specification that I mentioned, and that is used for the representation of the network service descriptors. And in that case, the actual onboarding of the descriptors is what is considered the positive feedback that guarantees the feasibility of a slice intent request. In the case that we have a full programmability, like the one that I showed you on the right-hand side of the slide with the platform architecture, we can go starting from the request of the SS southbound core. We have the NFVCL function is in charge of selecting the most suitable blueprint. A blueprint is a generalized structure that realizes complete network environments. I'm giving further details on this in a moment. Selecting the most suitable blueprint, then the NFVCL provides feedbacks to the southbound core when all the VNFs and the physical network functions have been successfully configured. Once that the required slice has been actually created, a new slice ID is returned to the now, and this is what we call the candidate materialized slice. A little bit of details on the network service blueprint, because it's something that it's really dear to our heart. It was conceived because we initially found some limitations in the way ETSI-NFV specified network service descriptors, in the sense that they are composed of predetermined unmodified numbers of virtual network functions and the links among them. So we wanted to introduce a higher level of flexibility. So what the network service blueprint actually is a generalized structure that can be seen as a manager of the lifecycle manager of coordinated network services, virtual network functions, and even physical network functions to realize a comprehensive network service. So we've got some for the whole 5G network, from the access to the core that is pre-annotated, but once the slice is up and running, it can be changed. So we don't have to put everything down and build a new slice back since the beginning, but changes can be made online. So for the day zero, we have the typical terraforming of the VIMs with the computing resources that are required, the types of physical, virtual, and also Kubernetes network functions that are required, their interconnections. So everything is described in this blueprint. For day 1 and 2, we have the information collection at runtime, the selection and deployment of the configuration files, and the playbook of the commands that are required for the lifecycle management of the individual functions at runtime for day 2 operations. Of course, there is also the possibility to clean the resources and the instances at the end. What we intend for lifecycle management is something that can happen triggered by 2 different triggers, so to say. It's either the now that requires a new configuration of the allocated resources, for example, upon changes on the SLA of an application, Or this can come from health checks on the resources. So for example, we see that a server is used at a percentage that is not comfortable for us, so we would like to scale it to do some migrations. And for this reason, a monitoring framework is also under development for the 5G induced platform that can be triggered by the NFV convergence layer and allows to retrieve metrics straight from Kubernetes for KNFs and from OpenStack for VNFs. And then it can provide these metrics to external applications that can perform their own analytics and then ask for operations of scaling or migration. So this is very useful in the presence of heterogeneous multiple infrastructures because they can plug in their own algorithms for analytics and be fed by KPIs that are collected by the platform itself and give back feedbacks to the platform to perform such operations. Have further details on the lifecycle management in reality, but I think that it would take a little bit too much time to go through everything. So in case you don't have, if you have specific questions, I can go through it, but otherwise I would stop here. And thank you for your attention. I know it was very dense. Thank you.
Thank you very much, Chiara, for the interesting presentation. The next presentation is Advancing Industry 4 with 5G SA, AMR, VR and ML at Ford Motors factory in Valencia, presented by Mr. Manuel Lorenzo from Ericsson, Spain.
Thank you so much. It's my pleasure to be here. Thank you for the invitation. And please allow me to share a brief presentation on some of the applications and possibilities and dynamics related to the activities that we do in this project. I would like to talk today about what happens when combinations of disruptive and exponential technologies like augmented reality, 5G, machine learning happens, and with the concept of being really applied to what can happen today and what we expect that will happen in the very near future, and what we have to do, what do we have to do about that situation. Hopefully. First of all, 5G Induced project has these three big locations that we call experimentation facilities. One in Italy, one in Greece, and one in Spain. I will focus today in one of those corners, in the nice area of Valencia, and what we are doing from Spain, in a combination of partners of all sizes and varieties of skills and disciplines. Let me go to the setup for this. First of all, the place where we're playing the game is the largest factory of Ford in the world outside the United States. It's that type of city. It's not a collection of buildings, it's a city in itself that takes you like 25 minutes to go from the entry to the actual place where the warehouses and the manufacturing cells are located. A huge area where there's a combination of two factors that we believe are fundamental for innovation to be happening. The first one is a very strong approach of Ford Motors to the modernization of their environment and to make their factories 100% free of human operation in the logistics. They already have 66 AGVs circulating all around their factories, and they control them with tablets, with near-field communications, Wi-Fi, and so on. So they can do a lot of operations with them with some human intervention on the devices. That's the very first aspect. So there is a roadmap a possibility for doing a lot of things in modernizing logistics in this case. The second one is the power of the ecosystem. In this project, there is a combination of companies with all their competencies in 5G, in augmented reality, in machine learning, and actually there's a number of companies who have adhered to the project even without being partners, and they are contributing with their ideas and their technologies to make it happen. So in that context, the starting point is a selection of use cases, 3 use cases that could lead to 10 or 30 new use cases in the near future. Let me explain a little bit what they are all about, and then we will move into considerations on the architecture, deployment, etc. The very first one is about the possibility to do a smart monitoring of what is really happening in an environment where there is, as I explained, up to 60 AGVs circulating and doing odd things. Of course, not crashing to each other, but really taking more and more complex tasks every day. So in this situation, we have to monitor in a different way, in a smarter way, what is happening, and also train the people in the factories to understand what can happen, how they can plan the work for the AGVs better. So in here, the incorporation of technology has to do with using augmented reality to get annotated extra information on what is happening with each AGV and feeling as if you were in the factory without risking your life or your safety for being there. A second use case is really interesting in our opinion. We talk a lot about automation, having AGVs going from automated guided vehicles going from point A to point B, but in reality it's more dynamic than that. AGVs should be able to correspond to commands by people, and people should be able to send in a very easy way commands to these machines. Move to the left, turn to the right, stop, restart, transfer this activity or this load, etc. So for this context, we are using the potential of machine learning, computer vision, to make it possible that without any type of tablet, mouse, or this type of devices, just using your hands and your gestures, you can control an AGV which is in front of you, or control remotely an AGV that you cannot even see before you through a computer. And that you can do for all the swarm of AGVs in the factory. So, 2 use cases incorporating augmented reality, video 360, and machine learning in combination with 5G connectivity. And finally, a case of being able to have the same network, the same devices to satisfy the needs of AGVs circulating in the outdoor areas of the factory and in the indoor areas. And for that, obviously 5G becomes a very natural option, and it's been tested in this large factory. So, what happens with this type of environments? We always think end-to-end. So we build everything coming from the coverage to the applications. But in this case, it's important to bother more on the second end, the applications and their dynamic. Of course, we take the work to plan the right coverage for 5G and R for this. Then we think of a private type of solution for the core network in the factory. Then we incorporate all devices in these AGVs, and then the magic happens with applications that manage to understand what you are doing in different conditions of light, etc. And you can orchestrate the work of AGVs, understand what they are doing, and they can circulate freely in outdoor and indoor areas. So that's for the end-to-end. And we take care of that with what we call NPN, non-public network approaches, and there's plenty of different solutions for that. There's a little bit more complexity in this. The world of applications is not static, it's dynamic. So we can expect 2 factors to influence in whatever solution we plan. The first one is that the underlying technologies like augmented reality, 5G, all of them are in constant evolution. So they are subject to evolve in very frequent cycles. So no solution that we can plan today will stand for a long time. We'll have to be adapted or be future-proof to that. And the second point, and to me more fundamental, is that there's nothing like a set of use cases that it is in there and remains forever. There will be more applications, more extensions to applications, and different ways to deploy applications because of the different requirements they have. So it's not only the end-to-end, it's really about thinking about how taking the exploitation from the beginning in your thinking. Luckily, there is something happening with 5G standalone. It provides the flexibility to adapt both in terms of performance and economies of scale to the needs of different use cases. With the standard, and that's just a picture of the standard, it is perfectly possible to distribute the applications connected to the network and the network functions themselves, either in the far edge, in the near edge, in central office, and even outside in public cloud. So, I think that everyone confronted to investing in a 5G setup for applications that have to do with their world, with the Industry 4.0 world, will have to think about this. And if they take it seriously, then we'll have to test it and validate it. And that's the whole point with 5G Induce, that all these scenarios and concepts can be taken from the drawing to the experimentation using the facilities of the platform, so that we can automate and vary all the test scenarios in no time. Otherwise, it would be a 10-year project to make sure that we evaluate all the conditions and check that, yes, it performs as we expect, and yes, it scales and it's flexible as we expect. This is the key message for 5G standalone. And in the type of thinking that we have for Valencia Factory, we believe that it's about the cloud edge continuum for the services. The reality is that in the factory, we can have all the functions of 5G, or we can have some of them. And we can host some applications, and we can host only a few of them. Because we can play with the game in the middle, the near edge, and we can play with central office at the telco cloud. This is very important to make sure that there's economies of scale benefited from the project, and that we can control the investments and also have an idea, predictability of the operational expenses of the solution. So, in essence, we are talking about three major factors. We are talking about something that is inherently derived from the use case itself, what they need from the performance of the underlying network, that is normally expressed in KPIs. We also deal with the flexibility that we demand to the setup that we have, so that more applications, more extensions to the applications can be incorporated, or new upgrades on the underlying technologies can be also taken. As you know, services are becoming themselves like networks. So it's a complexity of components, application components, that can be added, removed, and improved and upgraded. That's the reality of a live environment of operation. And finally, the investment. Decisions on investment that we don't have to think only that have to do with the factory. They have to do as well with the operators, they have to do with the vendors, and they have to do with the application developers. All of them have to know what possibilities are there, and to me the core message is that there is a need for an innovation cycle of testing and validation to be limited in time, but rich in results to make these decisions well informed by all parties. Yes, very much I want to wrap up here, and I touched upon only one of the corners of applications of 5G Induce project. The very first thing is that dealing with 5G non-public networks is our daily business. This is what we do in the project, and we are accumulating a lot of experience on real-world use cases. Then, second point is As I said, 5G standalone is much more than a standard. It's really an innovation platform to innovate upon, because it opens this possibility of flexibility, and so it is your choice to use it in the best way for you. And which is especially important for Industry 4.0, with a number of new applications coming all the time that you can reuse from one experience to another. And the final point is that we are an open project. Whatever we learn, we share, and we invite more companies to establish new partnerships with us. They can bring their own ideas, they can test with us, they can join for experiences, and it is important that if there is this possibility, this interest, you can always reach our project coordinator, technical manager, myself, because we are really looking into that, into having a much better impact on what we can do with the learnings we have that are collective and for being shared. So, hoping that this was quick and short enough, thank you again for having the possibility to present this. Thank you.
Thank you very much, Manuel. So I will be the next presenter. Thank you. I'm Christina Lesi from OTE. In this presentation, the Greek testbed that is used in 5G Induced project is described. The infrastructure is implemented based on 5G technology, which offers several advantages in the 5G Induced use cases. These use cases are for Industry 4, as we will see later on the presentation. 5G Induce is an ICT 41 research project funded by European Union, and 21 partners participate. You could also visit the site, the website of the project for more information and project outcomes. The project's main vision is to deploy an end-to-end orchestration platform for 5G applications that can be used in Industry 4. The main target is this platform to be easily ported, deployed, and managed. There has been designed 8 use cases in order to demonstrate the platform. 3 of them will be demonstrated in Greece. The key component of the infrastructure is the network applications that will be deployed and demonstrated in the testbeds. These network applications will let us increase the interaction between NetApp developer or service provider and the telecom infrastructure provider. As I mentioned, 3 use cases will be demonstrated in Greek experimentation facilities. All 3 of them will be validated in Public Power Corporation premises, or PPC for short. The first use case is about predictive maintenance for a power generator. The second one has to do with UAV inspection and surveillance. And the last use case focuses on AR assistance for maintenance procedures. In these use cases, in all of 3 of them, 5G network is used to ensure the low latency, the high bandwidth, and the high availability of the offered services. As we can see from the use cases, 5G technology could be used not only to redesign the production line, but also to enable operating models with networking characteristics that enable added value services for quality, safety, and security. As we saw, the use cases had to do with these things and not with the production line. So a large amount of components could be supported at the same time with different requirements. And in order to install all these components and use them at the same time, supporting their requirements, for example, the high availability is one of the requirements that it is very important. Any interruption of the available service is never welcome, or high throughput, which is also needed. In an industrial environment, we know that several cameras and sensors could be installed. Also in our use case with UAV, we should send and receive video, so high throughput is required. And also low latency plays an important role, another demanding requirement. We should try to minimize latency as possible. So when we have these demanding requirements, we see that 5G technology plays an important role. But since we're talking about heterogeneous requirements, we should find a way to support them all. So a feature that is introduced by 5G technology is slicing, which allows us to use at the same time these heterogeneous requirements and make all the services be reality in our use cases. However, in order to support slicing, we had to install new version of 5G technology, such as 5G standalone release 16 architecture that is also used in Greek testbed. You can see here in this figure on the right the Greek testbed. We have installed our equipment in two different sites. One is in PPC premises here, where the RAN is installed, while the packet core is installed in OTE premises, and the distance between them is about 15 kilometers. We also have installed the transport network, so this testbed is actually integrated and fully operating. And several pieces of equipment has been used, as you can see, antennas, indoor antennas, 4 in total, and an outdoor antenna, and baseband and radio units are also installed on site. And we have already covered 3 floors and an outdoor area in order to demonstrate the 3 use cases. We have already completed initial tests, and we will soon be ready to provide some demonstration results. So to conclude and summarize, for the Greek testbed, we have installed a 5G standalone network in order to support the demanding requirements of 5G induced use cases. It is important to mention here that our main goal is to offer services beyond the productivity line. We are focusing on safety, on security, on prediction maintenance, and in order to achieve our goals, we use 5G technology and its added values. Thank you very much. So now let's move on to the last presentation of this session, which is ML tools and AR applications implementation in a 5G environment for predictive maintenance, presented by Professor Franco Davoli from CNIT.
Thanks. Thank you very much, Christina, and thanks for the invitation in this workshop. Okay, can we have the next set of slides? Okay. Yes, this is actually a flash on the Italian experimentation facility, where 2 use cases will be deployed regarding
this this kind of specific applications. Again, we talk here about predictive maintenance as one of the test beds in Greece, of the use cases in Greece, and these two actually that we will briefly describe and that are based on deployed on the Italian testbed focus on the application of machine learning tools and AR applications. So that's the origin of the title. The current deployment status of the Italian experimentation facility, there is the infrastructure has been deployed. We will see something on the deployment status of the use cases that regard this specific application and the next steps and the plan of the demo. Let me just again summarize. We've said already something about the structure of 5G in use and the experimentation facilities, but this is just an overview of the three. We have three experimentation facilities in Spain, in Greece, and in Italy. All are structured in this way, with the presence of the use cases, the experimentation facility itself with and the core network, and the components of the main components of the 5G induced platform, the NOW and the OSS. In particular, the Italian experimentation facility sees the presence of the 5G core network and NOW and OSS in the CNIT premises in Genoa, and these are connected by a virtual private network to the actual site in Cassinetta of Whirlpool, where these use cases that we will describe will be demonstrated. There are a total of over the three experimentation facilities. The goal of 5G Induce is to demonstrate a total of 8 use cases covering such different aspects. This is the deployment status of the Italian facility. As I said, there is this site of Whirlpool in Cassinetta, where this is being the actual use cases will be deployed. The network provided by Wind3 and the data center also provided by Wind3 that contains this core network. This is connected to the CNIT premises in Genoa, where the NOW and the OSS are deployed to support the experimentation. The two use cases that adopt the machine learning tools and augmented reality are one for edge analytics, regarding edge analytics for predictive maintenance, where there are basically three functional parts. It is related to the execution of analytics, data-driven analytics for the maintenance within a factory setting. The network application that is being developed in this context offers all that is required for data collection, analytics, visualization functionalities, and these are realized in different virtual network functions and deployed in the edge, on the shop floor, and at the factory level. And the on-premises analytics are running on a Kubernetes cluster and allow the breakdown of operations into different jobs
and employ, in terms of machine learning, tools like Spark and TensorFlow to execute the analytics itself. The development status of this use case regards the development of a specific network application for predictive maintenance of a thermoforming machine. To test, the main objective to test the bandwidth and latency on real-time data flow to connect the machine and perform the analytics operations by using on the machine PLC data and thermal camera images that will be conveyed via the 5G network. And these are, the requirements. And currently, there is the data availability in the private Whirlpool cloud. This will be completed in December. This system integration architecture has been defined, and there are mobile devices available, and the 5G SIMs have been deployed and tested, and the demo session should be take place in January next year. The other use case is centered instead on the application of augmented reality, and it regards remote inspection, maintenance and repair. It's use case number 6, and this will also be deployed on the Italian experimentation facility. It uses a remote support module of Oculavis, one of the partners of 5G Induce, that provides high quality support with a combination of video and audio stream at very high quality, collaborative working tools, and augmented reality annotation and documentation. And so it enables the application of the execution of maintenance, inspection, and repair tasks remotely, so that the travel time and costs can be reduced and to increase the machine availability. This is a graph of the network application that represents actually one of the specific connections, the one that regards the machine that will be the subject of the predictive of the experimentation. And then similar connections will be for the maintenance operator, not shown for the sake of clarity, for the maintenance operator and for the control process engineer, which are the various actors involved. All these, again, at the Whirlpool site. And the network application graph is the one that, as Chiara described, is used to deploy the network application via the network application orchestrator of the 5G Induce platform. So these are the two specific use cases that apply these machine learning tools and augmented reality specifically, and also for this one, the current status is that we have the availability of the Oculavis Share platform, and that is in progress. User training sessions will be planned, and all the mobile devices are available and tested. There are AR glasses that are being configured, and the demo session again should be ready in January. So this is the short overview of these two specific use cases, and thank you very much for your attention.
Thank you very much, Franco, for the presentation. Unfortunately, we don't have time for questions, but we will all be available for further discussion during the break. So let's now have 10 minutes break. Thank you very much.
Θα προχωρήσουμε στην επόμενη ενότητα. Αν ο κύριος Κουμουτζέλης είναι εδώ. Ωραία. Okay, so ladies and gentlemen, we pass now to the 8th session, which is about the long-term evolution and smart connectivity beyond 5G. We have 4 presentations covering various ongoing activities funded by the European Commission. We have the AI at Edge project, the MONB 5G project, the Encrypt project, and the Octopus project. I think that the most important issues are what the presenters are to describe. So I give the stage to Mr. Stelios Koumouchelis from 8 Bells. By the occasion, I would like to express once again my profound thanks to 8 Bells and also to Dr. Ioannis Yanoulakis and to Dr. Manolis Kafetζakis, who continuously support such activities. We consider them as a reliable partner. And I give the stage to Mr. Koumouchelis for his presentation.
Thank you very much. It's a great honor to be here, and we're more than happy to present our work. We're going to talk about the AI at Edge project. The tagline is a secure and reusable artificial intelligence platform for edge computing in beyond 5G networks. I'm going to get into a little bit detail, but we will be brief, don't worry. What is the background of the project and the work we do? Artificial intelligence is not something that is coming out of science fiction now. It's not confined into, let's say, research centers or libraries or books. It's something that has been integrated in our everyday life. Of course, this trend cannot go unnoticed by the European Union and by partners that are heavily relied on artificial intelligence and machine learning. We thought that especially intelligent and secure networks can be greatly benefited by the breakthroughs that we have into the scene. Of course, this kind of AI integration in potentially autonomous decision-making systems or even critical infrastructure requires an end-to-end quality assurance and a platform that has to do this kind of work. So, motivated by this need to support elastic and demanding real-world use cases, the AI at Edge project aims to provide a platform like that and a tool that will be resilient, elastic, and secure end-to-end. This is the AI at Edge consortium. We are very honored to work with a very diverse consortium, 19 partners spanning across 8 countries, 6 research centers, 6 international companies, 3 university departments, and 4 SMEs. Let's summarize a little bit about the project, what we do, and what are the goals of our work. What we aim to deliver is a platform that will implement a secure and automated large-scale edge and cloud compute infrastructures with close to zero touch with the underlying heterogeneous mobile edge computing resources. So what we plan to do is to have this kind of a platform and fully utilize the benefits that mobile edge computing brings to the stage nowadays. In order to do this, we plan to develop and use a serverless computing paradigm to automate the deployment of distributed application at scale. Of course, utilize native hardware acceleration as is a very promising trend and something that will benefit us all. And to also utilize a cross-layer multi-connectivity radio access. With supporting systems of architecture and method development to manage the mobile edge computing resources that we talked about, a development of low overhead communication schemes for distributed algorithms, because all these edge devices are going to run the AI algorithms that we utilize and mentioned earlier. And of course, another supporting system that is also a pillar of the work we do is the security aspects, covering service isolation and protection for federated learning, because we cannot forget that when we utilize AI, we have a large-scale, let's say, sources of data, so security should be number one. Our main goals is to leverage the concept of reusable, secure and trustworthy AI for network automation, so as to achieve an impact, especially in the industrial, let's say, relevant aspects. So to prove this impact, we have some use cases scenarios that concretely demonstrates how our work can be embedded in those modern industrial sites. And of course, when everything is all done and complete and we have something concrete on our hands, we have to assess the impact of our work from a societal standpoint, and then all those lessons learned to integrate them back to our solution. So let's talk a little bit about the use cases in order for you to have a more concrete, let's say, a view of what we do. The first one has to do with virtual validation of vehicle cooperative perception. What we do actually is we have some drivers in a real-life environment and then a simulated network of cars. We try to connect those to the physical drivers and the emulated drivers. And then the goal is to recreate this network data data exchange required to build this cooperative perception. So by utilizing edge devices and AI, the actual drivers can learn from the simulation, which is, of course, optimal. The second use case, a little bit more industrial, let's say, is focused mainly on security. It has to do with secure and resilient orchestration of IoT networks. So what we have is a large network, an industrial network. We exploit their augmented edge equipment and devices with AI and machine learning solutions. And we detect anomaly attacks because when we have an industrial, let's say, site with many automations and many entry points to the system, to use artificial intelligence to enhance our security seems like a good idea, and it has been so far. It's very interesting. So the third use case is about edge AI-assisted monitoring of linear infrastructures using drones in beyond visual line-of-sight operations. So let me elaborate a little bit on that. Even a small drone fleet that has, payloads such as thermal cameras or any kind of sensor whatsoever produces terabytes of data. So to manage this volume of data in a production setting drone, we require a combination of both onboard, let's say, equipment that is upon the drone and ground edge computing capabilities. So what we do as a project is to leverage 5G to support this faster data transfer as well as advanced AI-enabled edge image and video processing. So we utilize edge devices and the infrastructure in order to perform the computations that are needed in order for the drone both to take the route and do this, let's say, thermal scanning and stuff like that. And the fourth use case, and my personal favorite one, is smart content and data curation for in-flight entertainment services. So what we actually, let's say, saw was that in planes we have all of those sensors, all of those edge devices, and the capability for network softwareization. So it seemed like a good idea to present, let's say, all of those resources and recreate a cloud inside the plane. Along with AI solutions, this cloud can support something that has been so far not so common, let's say, and that is actually consuming video content or audio content via the internet in a commercial flight. So allow us to explain a little bit our key contributions on the project. We lead the task 2.3. This is about KPIs, socioeconomic impact assessment and techno-economic analysis. I assume that most of you are familiar with the term KPIs. They are at the core quantifiable values associated with a metric that evaluates critical parameter of a system component. And my personal opinion is that the definition of a crucial KPI is in a way as important as the technical development itself, because it gives you a roadmap to be more precise and to produce a product that is actually useful. Following the same train of thought, the definition of a product's socioeconomic and techno-economic impact is, of course, the gateway between research and development and the industrial production / market, because you can, of course, produce a product or a software or something as a project, as a company, as an individual, but how this product is going to be, let's say, integrated in society or in the market is another let's say, issue, and this is something that we are happy to, let's say, make research on from our point of view. And about our technical involvement, it is in close connection with the KPIs. We have produced, let's say, first version of a KPI console. This is a web interface that has every KPI of the project in a very graphical, in a GUI that is very user-friendly and has several, let's say, possibilities. One can navigate through the KPI matrix. The KPI matrix is a matrix that confines every KPI that we have as a project defined in order to assess both technical and non-technical requirements of the project. You can get the latest measurements regarding the KPIs, so it's like something vertical. So if you have a technical work on one side of the project, you can, by accessing this and don't ask around, find the latest measurements of your KPI or a KPI from another technical team. You can, of course, connect to the AI project through the links to our social media, and you can contact the consortium and provide feedback over the KPIs. I wanted to have the interface with the feedback and the message, but it wouldn't fit the slide. But if you click on the tab, you have a form, and any kind of question that you have to do, either as a partner or as an individual, you can have it, and then the consortium can talk about it. And concluding, we have to talk a little bit about our next steps, both as Edbels and as a project. We plan to expand this KPI console that I showed you before in order to be a real-time monitoring of technical KPIs. So as of now, there is this tool, but it has to be fed with data in order to manually, let's say, refresh and see the latest values of the KPIs. What we plan to do further on is to have it in real-time monitoring some especially technical KPIs and refresh those values in order to be up to date. Of course, with a thorough analysis of the use cases from a socio-techno-economic point of view, in order to further plan the exploitation of the AI platform in a vast number of industrial and commercial applications. This is something that I of course, mentioned earlier, how to exploit all of this work and all of those innovations that we have on our project, and how the industry and practically everyone can benefit from our applications. And last but not least, of course, is to assess the societal impact of the project and how the innovative solutions and enhancements to the already established 5G networks can actively benefit societies as stakeholders. We go, let's say, a level up, and we see how this work affects society as a whole. And let me add a couple of points extra that there are on the slide. As of technical work, we also plan to see issues about security on GPUs and FPGAs, because those two are the main edge devices that we utilize. And we plan to get behind the security aspect of FPGAs and GPUs, because it's something that is really an issue, a cutting-edge issue, let's say. So that was all. I hope I was relatively brief. Thank you very much for your attention. And again, it was an honor to talk to you here.
Just a small comment or question. First of all, thank you very much for your detailed presentation.
My pleasure.
I would like to mention the fact that the AI at Edge is among the few projects actually promoted by the European Commission. There are 10 projects focusing towards 6G. Now there is reference to 6G instead of saying beyond 5G. Actually, just an estimation based on the progress of the activities. Do you feel that security challenges really implicate for the transition to 6G based on what you are dealing with in the project, or up to a certain extent, some of the challenges may be faced and dealt by considering 5G, but some others reasonably need to a more enhanced version? Just an estimation.
Well, it's a pretty interesting question, actually. From, let's say, my point of view and from everything that I have seen, there are, of course, security issues in the underlying infrastructure that we have up to now. And, of course, as you tend to go up to 6G, 7G, and stuff like that, that means more speed, that means more data, that means a very intricate solution that has many, many things to check upon. But this is something that this research is being, let's say, pipelined. So we work on several things simultaneously. Thank you. So we don't let's say, security issues that are underlying in our infrastructures that are up to now to prevent us from going up to 6G and certain innovations. But of course, whatever we do, especially if there is the plan to be commercialized in the future, we have to be extra cautious and really, really think about it. Thank you very much.
Now it is time to pass to the next speaker. I would like to invite my colleague, Mrs. Vasiliki Vlachodimitropoulou, from the R&D Department of OT and Cosmo OT. She will present some important information coming from the scope of the MONB 5G project, which is also in the activities of the Commission about beyond 5G.
Hello, and thank you. Hello, and thank you for attending my presentation. I will present the energy efficiency techniques of MONB 5G European project. The objective of MONB 5G project is the management of a massive number of network slices across domains that is hierarchical, distributed, scalable, and driven by artificial intelligence with the end goal of zero-touch management of 5G networks and beyond. In the project, they are participating 12 partners from 6 different countries, and you can find more about our project in our social media and web page. I will present the high-level architecture of MONB 5G, the main energy management and orchestration architectural building blocks, the MONB 5G reference architecture, and the main energy efficiency algorithms and the results of these techniques, and also the MONB 5G proof of concept. This is the high-level architecture of MONB 5G. The MONB 5G has closed control loops that are artificial intelligence-based, and they include 3 components: a monitoring system, analytic engine, and decision engine. The monitoring system is responsible about the monitoring of KPIs and the data from resources The analytic engines is responsible for analyzing the data, and we use a distributed machine learning federated learning for slice-level KPI prediction. And the decision engines use the inputs from analytic engines for data-driven inter-slice management and energy-driven reward functions for DRL with distributed reinforced learning. These three components are implemented in various levels of the infrastructures, like the virtual network function, physical network function level, the slice level, the domain level, like RAN, Edge, and Cloud, the inter-domain manager and orchestration level, which manages the life cycle, the end-to-end network slices by making global end-to-end analysis and decisions. The infrastructure also needs management, and we consider separate OSS-BSS domain for infrastructure management. The domain-specific DMO management and orchestration can use the infrastructure orchestrated management functions to achieve effective infrastructure management and to reduce the energy costs and the associated with the infrastructure. The minimization of the measurement load is achieved with the internal memory, like the time series database. This memory block enables avoidance of implementing energy-demanding synchronization among the three components: analytic engine, monitoring system, and decision engine. The energy efficiency at RAN and Edge is achieved with statistical federated learning analytic engines and stochastic federated learning based policy. With these techniques, we reduce the amount of raw data exchanged between local analytic engines and the end-to-end analytic engines. The decision engine uses deep reinforced learning strategies to perform cross-domain energy-aware VNF and service function change placement in 5G service customized network slices. We choose the ideal compromise solution to achieve a balance between energy efficiency and service level agreement. Here we see the 5G RAN architecture. There is a control unit, distributed unit split, and the monitoring system collects the RAN KPIs, and the analytic engine predicts the resources that are needed under the servers, under the constraints that we have from service level agreement. To demonstrate the general framework of statistical federated learning, three main slices are considered: enhanced mobile broadband, Netflix, YouTube, and Facebook video, social media, and browsing. The proposed statistical federated learning enables controlling of the long-term statistical behavior of the SLA compared to federated average baseline. Here are the results. We compare the statistical federated learning with the centralized constrained deep learning. And as you can see from the graphs, and we have a dramatic overhead reduction and significant energy gain. To reduce the network data overhead, optimize the federated learning computation time, and increase the system energy efficiency, we use also stochastic federated learning and stochastic analytic engine policy. In each round, analytic engines with a low SLA violation have a higher probability to participate in the next federated learning round. We have, in order to solve the problem of zero-touch service function chain orchestration for multi-domain networks, and the reduction of URLC latency while improving the energy efficiency. To solve this problem, we use decentralized deep reinforced learning strategies to perform cross-domain energy-aware VNF placement and service function placement in 5G service customized network slices. We split the network in inter-domain level graph and multi-intra-domain level graphs. The steps of the algorithm is for every VNF in the network, we perform an auction, letting multiple local domain reinforced learning agents bid to receive a specific VNF. Local agents perform intra-domain orchestration to avoid global network slice reconfiguration. Here we have the results when we compare our solution with centralized reinforced learning and static placement. In the static placement, the VNF placement is static and the VNFs remain hosted in the initial node throughout the experiment. You can see from the graphs the average energy consumption that in our case is dramatically reduced. And also the average service latency compared to two other solutions is also reduced. This behavior is a result of schema ability to cluster VNFs within servers, minimizing the number of transmissions in physical media, therefore decreasing costly communication between the servers. Here we summarize the results of energy efficiency techniques that we implement. The distributed management and components with embedded intelligence reduce the information exchange for management purposes. The response time and the energy cost. IOMF functions can improve the effectiveness of infrastructure use and contribute to the overall quality of infrastructure management and as a result to achieve energy-saving goals. Scalable, cloud-native, SLA-driven stochastic federating policy for zero-touch network slicing resource allocations, reduce the corresponding computation cost and SLA violation. The statistical federated learning that we use in analytic engine for slice level KPI prediction achieves greater than a factor of 10 improvement in energy efficiency. And finally, schema, a distributed reinforced learning algorithm through model validation and simulation, shows its ability to jointly reduce average service latency and energy consumptions compared to centralized reinforced learning solution and static placement. The proof of concepts of the project will implemented in the following experimental platforms in CTTC Barcelona and Eurocom in France. We will demonstrate the energy efficiency techniques and the results in the first proof of concept, a zero-touch network and service management with end-to-end service level agreement. You can find more about the algorithms and their implementation in the following references. Thank you very much for your attention.
Thank you very much, Vasiliki, for this presentation, describing some energy-related aspects of the MONB 5G project. As you mentioned, and as far as I'm concerned, trials are still ongoing, so it is expected that by April, some final results will come from the proof of concepts,
yes,
potentially.
We are in the phase of integration of the solution in the test beds, and finally we will demonstrate the results at the end of April. Thank you.
Now it is time to invite the next speaker, Mr. Konstantinos Kaltakis from 8 Bells. He will present some aspects coming from the Encrypt project about a scalable and practical privacy-preserving framework. Thank you again for joining today.
Can you hear me?
Yes.
Thank you very much. My name is Konstantinos Kaltakis. I'm working at 8 Bells. I will present the Encrypt project, which is a scalable and practical privacy-preserving framework that allows researchers and developers to process data stored in federated cross-border data spaces in a GDPR-compliant way. The project is funded under Horizon Europe Work Programme. It started at July 2022 and it will end at June 2025. The Encrypt Consortium consists of 14 partners across 18 European countries. That includes 1 startup, 3 SMEs, 2 enterprises, and then the research institutes and universities. The challenge and the vision of the Encrypt project is to overcome several limitations that the existing privacy-preserving technologies have, such as homomorphic encryption, multi-party computation, trust execution environment, and the differential privacy. That limitations are the scalability issues, the drawbacks of each technology, threats and performance, slow computation times. So we need to create an easier to debug technology to provide an AI-based recommendation system for personal data and performance, and all this must be in GDPR compliant. The objectives of the Encrypt project is to improve the applicability and performance, developing a toolset of scalable, practical, and reliable privacy-preserving technologies, to improve the user-friendliness so this technology could be understandable and can be easily adopted by all actors, to foster and inherently support the interoperability of privacy-preserving processing of similar data types across organizations and across all sectors, to promote GDPR compliant and common European data spaces, and facilitate the exchanges of CTI to ensure the applicability of all these technologies. We co-design with realistic use cases with end users. And finally, to strengthen the open source ecosystem by exploiting disseminating the open source project results. The high-level methodology of the project start with the gathering of requirements of system and design, and this is the currently phase of the project. Then with development of the tools to integrate it in a platform and create a prototype. Then we test it in a lab, and with the help of the external use cases, we can validate the framework. The Encrypt platform architecture in a glance, the data owners can use the privacy budget optimizer to choose between utility and privacy. Then this data will be inserted in the Encrypt platform, and we will use different privacy-preserving technologies according to the use cases, and the outcome will be used by researchers, service providers, and data processors. We have three distinct use cases. The first one is the inhaled domain, when we use trusted execution environment and homomorphic encryption that will result in protected data from safety and privacy violation, while enabling full automation of the treatment process at a fraction of the cost. The second use cases will be in cyber threat intelligence domain, where we gather and correlate data and using differential privacy and multi-party computation technologies, we will result in increasing the CTI awareness and resilience for data owners. And finally, the third use case is in fintech domain, where we use full homomorphic encryption with the help of GPU hardware acceleration that will unlock the value in sharing financial data without compromises on privacy and confidentiality. The expected impact of the project is to improve the scalability and the reliability of all these privacy-preserving technologies, is to become more friendly, all these solutions, to improve the privacy-preserving technologies in the CTI domain and data sharing solutions, and of course to contribution to promotion of the GDPR compliant European data spaces. And finally, again, to strengthen the open source European ecosystem for developers and researchers. Thank you all. You can find more information on our site, and we can stay touched in our social media. Thank you.
Thank you as well for your concrete and detailed presentation. The next speaker is normally to be connected via the Zoom application. I'm not sure if he is online.
Yes, I'm online. Can you hear me? This is George Kappas from University of Thessaloniki.
Okay.
Just to let you know that I saw a pop-up to turn on my camera, but unfortunately I'm joining from the desktop and I only have like a virtual OBS camera, so apologies, but I won't be able to show myself. We should probably get a webcam soon. I'm very sorry I couldn't be there for this presentation. I would like to see you all from up close, but unfortunately this is this period and therefore could not join physically. How do you propose to include it? Because I had no image, I was only hearing audio this time. Should I start sharing my screen? Is this okay with you?
Yes, please go on, because actually we are waiting to see your screen.
Okay.
Yes, it works, and we see the first slide of Octopus. Okay, excellent.
Okay, so everything is working properly. So, hello again, my name is George Kappas, and I'm here on behalf of the University of Thessaloniki, who is the coordinator of the project Octopus. Our short title for presentation is Building the Next Generation Central Office for the 5G and Beyond era. Thank you for inviting us to speak and present our project in this very early phase that it is in. So the actual title of the project is very large. You can see that the two lines that start with optical circuit switch, time just in network architecture. So I will not go through the whole, title where the acronym has come from. As the short title says, if we could summarize in one sentence, it would be that we're trying to be the next generation central office. So this is the presentation outline. I'm going to give you some very basic information about the project and the consortium, present you the overall goals of the project, the technology enabled behind our solutions, and then present you the architecture and the demonstrations. So some legal data to begin. The project is quite young. We have started on the 1st of September 2022. The duration is 42 months, and we have like a total of 500 PMs. The Arsudi University is the coordinator, and you can see in your screen the people that are involved from Arsudi University Thessaloniki. The PI, the Principal Investigations Professor Nikos Kleros. And at the bottom of the slide, you can see the Octopus ICT.eu. It's the URL of our website. It's still not yet 100% complete, but please, you can join and you can see here, there some very interesting information about the project. Now, this is the Octopus consortium. As you can see, we have a variety of partners in a variety of European countries. We are made up of 11 partners, 9 countries in total. We have 7 companies, including the vendor in Libya. We have 2 MNOs, Cosmote and Orange are the MNOs participating in the project. We have 2 research institutes, the Fraunhofer, the IMEC, and of course we have 2 universities, the National University of Thessaloniki and the Southampton University in the UK. So, just to go through the very basics of the project and our proposals of what we are producing here, our main goal is to increase the capacity at the next generation central office, which termed usually as NGCO. Second goal is to efficiently support the disaggregated RAN. Now, emphasis in this disaggregated RAN world that we're living in, we have the front haul, grid haul, and back haul segments. The emphasis given in our project in the front haul and the underlying time-tested networking capabilities that must be present in order to be able to facilitate services such as front haul, which have very strict latency limitations. And of course, the other goal is to efficiently support URLC services that in 5G world are services where you have the very low latency requirements. So as you can see, because of the project, you usually have to do, latency is a big part playing here. Another goal of the project is to consolidate the physical layer that we're going to produce within the project with an overarching SDN control plane that will allow faster configuration, automatic configuration. If we can make it zero touch, then this will be also one goal that we definitely strive for. And finally, increase of the energy efficiency is something that we definitely boast as being one of the main targets that we want to deploy here. So, in one liner, Octopus aims to deliver an agile, low-cost, and energy-efficient photonic integrated circuit technology framework that will essentially redesign the NGCO, upgrading to at least 51 Tbps and beyond. This is our goal, and provide an innovative optical switch backplane and transceiver toolkit. Now, in the figure, you can see the Octopus concept and vision. I will go through in the next slides each part and explain it better. Now, the technology enablers that allow us, to reach the ambitious goals we have in this project, combine the following technologies. So we will use, Octopus aims to use novel phase-changing material, PCM, in order to develop several zero-power, ultra-low-loss switches that feature, and this is critical for latency, nanosecond scale configurability. So we have a target of 20 nanoseconds of switching times in the basic switching elements that we plan to produce. And of course, our goal is also to make them zero power, where they do not change the state, they do not consume power, and of course have ultra low loss as components. Now, besides the switching elements, we will develop a broad portfolio of 50 GHz peaks, photonic integrated circuits in the O band, the horizontal band, optical band, that will allow us to construct transceivers that go up to 800 GHz, you can say, that are able to have for communicate between board-to-board communication and low-reach point communication, all this with reduced energy consumption. So we plan to build lasers, modulators, photodiodes, all of those. We plan to have high power, low losses, very high bandwidth. So we are able to produce this very high bit of terabit scale that we envision for Octopus. We also have we will develop some other materials such as the glass waft in the poser there that will act as interfaces between the photonic chips and the fibers that we will connect to, and can also be used as diplexers for utilizing two optical bands. The predominant bands, as you know, the things become clearer and clearer and years pass on. O band and C band are the clear winners here, so we are developing materials for both of these bands, and also, of course, we plan to have the particular electronic ICs that will be used, as drivers for the other, for the modulators and the chips and lasers, etc. Will be used as transceivers, amplifiers, etc. And all this underlying physical layer that we must have and make, of course, very fast, to be able, to reach the targets that we're planning for the switching of materials, etc. and the bit rates. Now, another goal of the project is to deploy a pool of advanced optical components to demonstrate the low power, ultra-fast, configurable, and optically enabled backplane technology in order to interconnect the components that are within the central office. We plan to have series of architectures built for the backplane. We'll use an optical circuit switch, OCS, backplane that's made up of arrays of 2x2 PCM switches. We can max them up to 16 parallel PCM switches, so we can have main ports, input and output ports. We will also test some layouts that will enable us to connect many output switches in the next central office in a manner that allows us to, in the future, upgrade the capacity of the NGCO to 200 terabits from 50. And we also have some other 3-style switch layout that enable us to establish alternative paths for the types of traffic that are have very, very strict latency constraints or are being sent by a centralized RAM that is far away from the endpoint of the service. So this is a picture of the overall Octopus NGCO architecture. As you can see, it looks a bit complicated, but essentially it's made up of 4 core points. One, we have the output switches on the left-hand side, which are the connection essentially to the metro network. We plan to produce scales that allow us to connect up to 8 uplink switches of 25 terabits each for connection back to the MNO, metro, and backhaul networks. On the right-hand side, we have the interface cards. We plan to support up to 16 interface cards per uplink switch to connect to the transport network. The transport network is what connects the NGCO to the endpoints, which can be, the MNO equipment. They could be, genome bees, distributed units, remote units, 4G towers, even so, fiber to the home connectivity, everything that that the MNO and the ISPs generally require and produce in their service portfolio. In the middle, we have a switching fabric, that we're using in the Octopus. We have this optical circuit switch that allows essentially to connect any uplink switch and many of the ports in some combinations to the ports of the interface cards in order to properly route the traffic to the proper destination, aggregate paths, etc. It allows us to reroute and reconfigure the network, acting as the central switching fabric of the Octopus network. And finally, we have the control plane. We plan to have a unified control plane, SD control plane, where we have a strongly coupled TSN and SDN controller. Now we have 3 layers of service provisioning envisioned here. We have the best effort paths. This is, let's say, the path for relaxed services that have no relaxed constraints, both in terms of bandwidth as well as most predominantly in terms of delay. We have TSN enabled paths, so we'll have paths that will pass through essentially ports that support TSN time system networking standards that will allow us to have delay guarantees in the project, produce deterministic guarantees, which is for some services, for instance like the front haul or the URC, will be very essential to have to be able to guarantee the correct operation of these kinds of services. And we also envision some express paths that will bypass all intermediate NGSO component. This is a niche, let's say, offering for applications that have extreme delay requirements, and we want to even, avoid the congestion in the rest of the NGSO, the other switches in the interface. We want to avoid the store and forward delays, the stuff, etc. So they will be used in some cases in order to avoid traffic congestion, litigation, and essentially guarantee that the service has a dedicated path, let's say, so that it's able to properly execute. And finally, we have, the STM controller that will monitor the network, will register the incoming requests for the services, will choose the correct paths. This will interact closely with the TSN controller, the CNC and the CUC, the user controller and the network controller of the TSN, to deploy TSN-enabled flows. We envision, of course, automatically routing in case of congestion or load decrease. And as part of the project, this is for more forward thinking, we would like to employ prediction schemes, that will allow us to have quick responsiveness for the network, so we can quickly reroute or create resiliency or other useful things at the NGSO. Final slide. Octopus will perform, a series of lab and field trials in time-sensitive application scenarios. The last demonstration that will happen during the last part of the project will take place at Cosmote premises in Athens, and will focus on showcasing the full Octopus portfolio, the full Octopus functionality, with emphasis on delivering, real-time protocol, real protocol and real URLC cases, and we look forward to be able to have a successful demonstrator in Cosmote Athens once again. So thank you all for your attention. I hope we didn't take too much of your time. Please visit our website, and from our website you can also see the list of the social media. Please follow us and subscribe in order to get the news of the project, as we will be happy to share them as the project evolves. Thank you very much.
Thank you very much, Dr. Kalfas, for this very interesting presentation, giving the aspects of this innovative and new effort, which is to have a duration of 42 months, if I remember correctly from your slides. Actually, you're still in the beginning. You have presented the expected innovative framework, maybe it is too early to ask a question about the intended use cases and how to proceed, because I feel that first of all, you will give priority to architectural issues and so on that have also been presented. So by my side, the only I can say is thank you for giving us the main idea, the initiatives of this interesting project, and hopefully next year, once you have some more concrete to present, we would be glad having you again with us.
Sure, it will be an honor for us to come back in a year's time and give you the updates and present to you all the novelties that we hope that we'll have by then. Thank you very much.
Thank you. We can pass to the final session. We have 3 more presentations. Mr. Dr. Konstantinos Philis can start, unless Kostas, you feel that we need some short break, but I think that it's a good opportunity to finalize earlier, because we have for the speakers the social event. Before giving the stage to Dr. Konstantinos Philis, I would like to mention that this final session is a very practical one, because in the previous sessions we have heard about 5G verticals, 5G in innovations, the way beyond 5G towards 6G. We have heard about security, we have heard about network flexibility. However, the question is, all these are interesting, practical, but what the impact is on our everyday life. So I feel that this view will be covered by this final session, where we have 3 dedicated presentations, different one to the other. However, they all have a main aim: to improve living standards, to give more, let's say, benefits to our everyday life, to improve well-being occasionally of the citizens. So I will give the stage to my colleague, Dr. Konstantinos Philis, from the R&D department of Cosmodee, one of our colleagues. Konstantinos always supports our activities, and I cannot find words to thank him, to express my thanks. He will present the Slices Starting Community project, so we can see this interesting aspect.
Okay, so this presentation has to do with Slices SC. Slices SC is a program that has to do with engaging the community of researchers in using research infrastructures around Europe. So let's take a look at this. This project has an umbrella project, let's say. It's called Slices RI, from Research Infrastructure. Slices RI has the aim to provide a programmable and virtualized, remotely accessible research infrastructure for researchers to perform advanced experiments. So these experiments can do with networking protocols, radio technologies, data collection, edge-based computing architectures. So these are some of the experiments that can be done. And these experiments can be done in several platforms, research platforms that are around Europe. So this umbrella project, as we said, the Slices RI, has 3 individual projects. The Slices DS, which has to do with the design study of the face. The Slices SC, which has to do with starting the community. That means engaging the community in doing and knowing how to do experiments. And slices PP, which has to do with the preparatory phase. The slices SC vision, in particular, as we said, is to organize and engage the community of researchers in doing experiments. These researchers can have an academic background, an industrial background, or they can be individuals that are interested in performing some kind of advanced experiment. This availability is offered by Slices SC through a European-wide network of different platforms that are available for these experiments. We can see that we have different research infrastructures in 10 countries, and we have 14 members, partners in this consortium. Most of them, almost all of them, are academic institutions owing a very advanced research infrastructure that they can have available for researchers around Europe to perform experiments. We can see here that Slices stands, let's say, between Slices DS and Slices PP. Slices SC runs for 36 months and succeeds Slices DS and precedes Slices PP. So the individual objectives of Slices SC include, first of all, the access to a fully programmable and customizable internet scale ecosystem in order to perform digital experiments in using advanced infrastructure, to enable virtually anywhere access from all over the world, to provide specific experiment descriptions, to ensure repeatability and reproducibility of the experiments, to raise the awareness of the digital sciences in order to promote the use of infrastructure, to empower, assist, and sustain the growth of the community of academic and industrial researchers, to launch and organize joint training activities, not only for researchers, but also for students, and to support the sustainability and the exploitation potential of the umbrella project for Slices RI. This will be the, let's say, portal that a researcher will be able to use. For example, here we can see that if we have an academic researcher having an academic account, he can use this one in order to log in to the site and to the platform and starting the experiment. However, anyone can create a new account and can use this account to perform the experiments that he likes. Now, the role of Cosmote within Slices SC is very important. We are work package leaders for the work package that has to do with the liaison with industry and other stakeholders. So we are responsible of engaging industrial users actually to the platform. We are also task leaders for the task that engages industrial researchers to the use of these research infrastructures. We are also involved in requirements, dissemination, and exploitation, and we have also made available our test bed, which is called the Leonardo Lab. This testbed consists of 4 individual domains. We have an ICT cloud. We have a 4G, 5G non-standalone and 5G standalone testbed. We have an IoT platform and a fiber-to-the-home testbed. This testbed has been interconnected with several institutions, and it has been utilized, and it's been utilized in several projects. In particular, the IoT platform of the testbed, which is a very flexible platform, has been developed entirely in Cosmote from scratch. And it is made available for slices for the particular project, for performing experiments. So this can be used for integrating any sensor and any technology. So we can use different sensors, commercial or made by individual researchers in order to perform experiments. So this is one, let's say, one of the platforms that will be available to researchers around Europe and around the world in order to perform experiments. The platform is accessible from anywhere. It is presently utilized in many projects, and it is constantly upgraded. It consists of the end devices and sensors, the hubs and gateways using multiple access technologies, and a back-end system which is used for data storage, processing, and visualization. We have also Docker deployment and remote configuration, device management. So we can also manage different devices, not only monitoring. So we can turn on, turn off switches, stuff like that. The ultimate purpose of our IoT platform is to provide smart buildings. So when we talk about smart buildings, we mean that we can manage the energy of a certain place, of a home, of a whole building, using relay, plug sockets, light switches. We can also monitor the energy. We can have home comfort, meaning cooling, heating, TV, music, players, etc. Security, cameras, motion detections, fire detections, etc. Advanced automation, alerting, using push notifications, smartphones, etc., and other services, including voice commands, location, presence, etc. So the ultimate purpose of the IoT lab is to promote the future smart buildings. And this is only one of the research infrastructures that will be available for the Slices SC and the Slices RI in general project for different researchers to perform experiments. There are other 13 labs and test beds provided by the rest of the partners in order to be used for additional experiments. So that's all from me. Thank you very much for your attention.
Thank you very much, Kostas, for this presentation. It is quite remarkable the fact that some, let's say, research entities actually provide access to anyone who desires to use these infrastructures and these facilities, and it really it gives a very good impression. I don't have words to say. I feel that this will allow extension of research and development, and also strong connectivity to current market activities. We will now pass to the next speaker, Mrs. Betty Karalabopoulou from Geosystems Hellas, CEO of the company. She will give a presentation regarding the use of Earth observation, IoT, and telecommunications assets for improving well-being of citizens in the scope of certain Horizon projects. Once again, Betty, before you start, thank you for support the Infocom series with your presentations, and we hope that this year as well we will see some innovations from your framework.
Thank you for the invitation. Once more, Dr. Chouliouros, I am happy that I can be here participating to this event. As you all understand, we are passing to other subjects that have to do more with Earth observation and GIS. But the 4 projects that I will briefly present are from the Horizon 2020 framework, so are quite mature, means that are around, one is close to finish and the other have passed the 50% of the implementation. So the examples are the examples of the D2EPC, Police, Heart, and Harmonia, and all projects have to do with the urban environment and have the vision and the impact on the citizens' well-being. Wow. Just a few words for the company, for the ones that they don't know us. We started working in Athens in 2009 as Geosystems AU Group last company with a minority shareholder from Geosystems GmbH. In 2022, Geosystems GmbH is acquired from OHBSC, that you all know as the space design and build of telecommunication satellites. Most of you maybe have worked with SpaceLux, which is OSB Luxembourg, and I know that in the past we have been in some communication also with them and Enότητα. We do have participation in the downstream space sector in Greece and Cyprus. And of course, being in this market, we are funded member of the Space Cluster since 2014. We are a member of the Hellenic Association of Space Industry, HASI, and the last year I'm involved as elected in the board of HASI and also in the European Association of Remote Sensing Companies, EARSC. Also involved, elected as director in EARSC in 2022 and appointed in GEO, which is the United Nations Geographic and Geospatial Initiative that is represented United Nations worldwide. So, moving on, we use most in most of our application images, and based on the information that we can get in 3D using photogrammetry or in 2D and artificial intelligence doing remote sensing, we get information, imagery intelligence, and we provide this imagery intelligence as geospatial intelligence, mostly focusing in the urban environment and participating in the vision of the smart cities, doing what we say with the image, digital twin Earth. Based on that, we merge the information of the image with other information that is coming from the real world, which is IoT things that are, of course, connected with telecommunications. So this 5G or the vision of 6G is part of our projects. We see and we focus in the new space economy. So these are the three major subjects that we focus in, resilience, adaptation, and sustainable development. And based on that, I will briefly present those projects that I have mentioned in the beginning. This is a list of other projects too, including the ones that I will present. So in order to go faster, because it's afternoon and late for all of us, I am, let's say, presenting the first project, which is the D2EPC, Dynamic Digital Energy Performance Certificate. That it has to do, it's funded under the framework of Horizon 2020. And has to do with the initialization of new, more clever EPCs and do this visualization inside the WebGIS in order to, with this visualization, to produce EPC statistics. To visualize those statistics on a map means to geolocate them and visualize them on the map, have the possibility to provide spatial queries and attribute queries because the EPCs have to do with the building's energy efficiency, and it's very much connected to the energy consumption and also the zero emissions. And of course, use open services using OGC services, and at the end, visualize in a simple way the models on a map. This Horizon project is going to be finalized after Easter. Has started 3 years ago, and it's in innovation action. So Geosystems is focusing also in the exploitation and commercialization of the GIS platform, and in collaboration with the Austrian standardization of EPCs, which is a standardization body, we try to push this new clever EPC method in order to have a political acceptance, since it has to do with two keywords of our daily life, energy and climate change. This is a map from the D2EPC statistics. So like that, we can, let's say, go in a neighborhood or in a municipality and see the statistics and see how this can be visualized in the performance view. And also how this we can also visualize including also BIM models, which is the 3D representation of the building blocks, and also include the cadastral information that it's in most of the big cities available. Going to the second project, which is FPOLIS, it's an integrated natural-based solutions system for urban planning, and has to do with the health and the well-being of the citizens. This is the example of Mikrolímano in Piraeus. There it's as we have all seen the 2 last years, there is a reconstruction and a renovation of the area. It has to do with sensoring in the area. First of all, in the canal in Delfinario, that with this sensoring we can measure the quality of the water after being cleaned, and by using images in the surroundings, we have calibrated a method using artificial intelligence, machine learning, deep learning. So like that, the whole water bodies enter the canal and in the coastal region to be frequently monitored, not from sensoring, which is very expensive, but mostly from imagery, in order to have the infrastructure safe and secured. Also, there is a greenness new position in the area with green roofs, green terraces, etc., that also the citizens and the shops of the area have embraced, and we are in a position with Earth observation and Internet of Things to go in the vision of the digital twin Earth and provide also those green terraces, since the project has a budget for also such infrastructures. This is an example of how this in a specific place, very close to Actidilaveri, how the greenness will be in the future, because this is a plan. And in order to best have the citizens embrace the solution, we are providing them also sensors that while they are exercising in the area, they can measure their pulse, their heart pulse. It's like the sensors, the bracelets that we use in the gyms. And this is an online service in a platform, in a server, in order to see that this greenness and this change of the environment with the blue-green growth can give for sure well-being to the citizens. As an example on that is also this plot that is visualizing weather sensoring and those air quality parameters, that with those parameters we try to calibrate also satellite images and have more concrete information over the whole area before, during, and after the new infrastructures. A sister project of FPOLIS is HERT. And here you can see the land use landscape of and the changes of the Attica region, which is the most interested region for Greece. So the HERT has to do with healthier cities through blue-green regenerative technologies. And as you see, we can, by using Earth observation, we can monitor the water, the vegetation, the streets, etc. And based on that, with any kind of changes, to again using in ICT tools to see how the public health and the well-being of the citizens can change. Also, this is a visualization as a WebGIS toolkit for the environmental monitoring of the area before, during, and after the implementations. I could say that FPOLIS and HERT are sister projects because one has started with a difference of 3 months and one is complementary to the other. One is RIA, the other is IA. So with the IA, it is supposed that exploitation and commercialization of the tools of the platform will come next. And last but not least is the Harmonia project, which has to do again with the same framework of the Horizon 2020. It is about the development of a support system for improved resilience and sustainable urban areas to cope with the climate change and the extreme events. So there are monitored of natural and man-made hazards, identification of those hazards, and the project is the last one, so it's about 12 months old and has another 2.5 years running. In front of us, so has to do with integration of Earth observation, IoT and engineering, again for urban planning by using all those technologies. Here we have again pilot in Piraeus, since we had a lot from the previous project. So as a add-on of that, we have Sofia, Ixelles, and Milano as other case studies. And it is supposed that at the end of the project to have a resilience decision support system, a DSS, a platform that will merge any kind of information and contribute to the climate resilient cities. As you understand, Geosystems Hellas in all the project is the work package leader of the work package of the Earth observation, and in Harmonia we also we are also work package leaders on the platform for the decision support system. This is the company email. If there are questions, happy to answer now or by email or anytime.
Thank you once again, Betty. It is quite remarkable just to have a view on dedicated projects and understand how Earth observation, IoT, and other telecommunication assets, as you mentioned, may give immediate benefits to our everyday life. I cannot say more. Very interesting presentation with details. I think this can be an initiative for anyone who is interested just to look further and check on the outcomes of the project. I wish you may be able to continue these very interesting results with new results. Thank you again for coming. I would like to invite the final speaker, Dr. Dimitrios Dzembelikos from the municipality of Galeo. He will present a lecture about the use of national and European project results in the city of Galeo. Before starting his presentation, it's once again an opportunity for me to express my thanks to Dimitrios, also to the municipality of Galeo. We had some past cooperation in activities that have been completed quite successfully. We expect that with the first occasion we will be able to continue. However, apart from this, I have to make clear to the audience that the municipality of Egalo promotes innovative activities, as you will find out, and maybe for some of us it's not widely known. I know the effort mainly realized by Dimitris and his team, and I can believe that these are among the few innovators among the municipalities in Greece, and you will find out why if you hear Dimitrios' presentation.
Okay, thank you very much, Dr. Hochliouros. First of all, I would like to thank you because you give us the chance to participate in this conference and promote and, let's say, present some projects which actually run in Egalo, in the city of Egalo. Thank you very much for that. Okay, just a very brief, I know I'm the last presenter, so I will be very fast because all were very tired. Just a very brief presentation about the profile of Egalo. The city of Egalo is situated at the west region of Athens. It's one of the oldest municipalities. The population of Egalo with the latest census action is about 65,000 people. We have a reduction of our population. Our economical budget is about 75 million. The most important for us is in Egalo there is a local university, the University of Agostatica, which actually is an added value for us. We have 3 metro stations. Well, of course, we are an urban city, and we have a very promising region in Egalo, which is actually the region of Eleonas. Our participation in the European project, we participated and participate in different projects. With the red ones is actually project we've already finished. With the black ones, project which after implementation, we participate in drones, 5G drones, Respond Day, Transformar, Sin to Impress, and 2 Erasmus projects. I would like to say, at this point, from 2017, in Egalo, we have a budget for this project for over 1 million, let's say, euros. But the most important is that give us, this is an added value for us, and how we can prove that, in the running period, we participated in 24 proposals, which actually other evaluation process. I would like now to present a very brief plan about the Smart City Plan, which actually we have in Egalo. We have 3 different categories. The first one is the smart infrastructure. The second one is the smart economy. And the third one is the smart living. We'll try to find economical resources and funding from different programs, national programs, European programs, or by own resources. For the first one, the smart infrastructure, we have to invest in IoT implementation and sensor. We need to prepare the city for, in terms of IoT infrastructure regarding the lighting, the air quality, the noise levels, and waste management, the energy consumption, the water management, and the fleet also monitoring. Regarding the second pillar, which is actually the smart economy, again, we invest in order to operate in and managing the urban environment, the infrastructure status monitoring, automate procedures, air and water quality monitoring, energy policy consumption management. This is very important for our municipalities, the local authorities, because due to the crisis, we have a very demand status for us, because we are very energy-consuming client. We have also to say about the measurement of meteorological parameters as well as the waste management. Some general aspects about the smart economy. We have 2 different categories, the digitalizing cultural heritage records, and of course, some integrated destination management system. We'd like to reveal that Egalo is a tourism approach for everyone, so we have to invest in these 2 categories. Regarding the smart living, we try to implement and set some smart application for our citizens. So we're having interaction between the daily life of citizens, the daily life, and the services which actually give from Egaleo, from our services. The last one for the theory is, okay, we can collect very big data. What can we do with this data? This is a question. And the second one is, our vision is to create two centers. The first one is to develop a smart city coordination center in order to, let's say, monitoring, control, and management of all this data. And the second one, which is actually very important for us, is to develop a command and control center. Now the project. The first one is Egaleo has a GIS system which actually uses it for our application. It's a basic, let's say, action for that. So we have an open data for our citizens. We have use all this information for our citizens. So it's an open platform. We have also developed some smart city application for our citizens in order to take some electronic documents. I would like to mention here that we don't cover the central governments and the gov.gr, which actually is the basic pillar for all these documents, but we have some supplementary documents for our citizens, which actually not covered by the gov.gr. This one is another initiative we have prepared and is working now, is a smart square. This smart square is the entrance of the municipality Grove, Barutadico. This is a very simple smart square. We have set a Wi-Fi network. This is the simple one. The other one is that we have used some sensor in order to measure some environmental parameters, which actually is very useful for us in order to understand the local and climate in the entrance of the Grove. But the most important for us is to have a pilot application regarding the network which is actually set for this smart square. We use a LoRaWAN network protocol in order to collect all this data. And why this is very important? Because as you can see in these slides, we have a very big project in Egaleo. It's about 5 million euros project, which actually change all the lamps and the lighting poles with a new lamps with low energy consumption. So we have a contribution to the reduction of the energy and the footprint of CO2. But the most important from this project is, actually I would like to refer now that this project is in the tendering process. We set in all Egaleo a LoRaWAN network, so we have the basic infrastructure in order to set different sensors in all our city region, which actually help us to be a very smart city municipality. The previous one is actually another application which actually uses the Novoville application. It's an interaction system which actually manages the daily life of our citizens. So every day a citizen comes, find the problems, use this application, know the problem, and will try to solve the problem. This is not actually the case, but we do our best for this situation. We have, in order to transform to a smart city, I would like actually to say here that we are not a smart city. We try to be, but we are not at the time being. We have some basic studies which actually help us in order to go further. We have a SECAP for our city. We have a study for the charging of electric cars. We have a study for waste management system. And of course, we have the last one, SUMB, the Sustainable Urban Mobility Plan. This is actually a beta version of our smart city platform. This is in a beta version, actually will be in use on September 2023. We have 5 different categories. We have a city guide maps, digital guide, recreation and walks, Egaleo My GIS, digital governance, consultation with citizen requests, and so on, recreation and culture, virtual tool in municipal growth, Asia Minor culture, digital guest book, games and content, so on. We have also behind them a business intelligence platform, which actually help us to take some a decision support platform, which actually is a continuous improvement for the service of the city of Galleo. This platform has tools, techniques, and technology for the analysis of the city data for the daily life. And the last one is interface some system and other user application, like some chatbot and application for our citizen. These are logos, Smart City Galleo. This is some promotion material which actually have been released. We have in Galleo opened the discussion about the digital twin. We have two options in this point. We have some contribution from a European project, Seem to Impress, which actually use a digital twin for public safety. And the second one, there is an open call from the central government regarding the smart cities. We invest in these projects using this financing tool in order to develop a digital twin for our city. Some material, we use some IT sensors placed in Galleo, climate, energy consumption, so on, some Earth observation data, social-economic data from Eurostat, citizen collecting data, and of course, an urban observatory, which all this data will process and transform into suitable parameter. This is another project. We have some smart climate station, which actually distributed in a different region of Galleo. So we have a profile of the environmental background of the city. Also, we can use some more custom environmental sensor. We use all this sensor in order to make the profile, the energy profile of and the environmental profile of our city. This is a work. We have developed the municipal command and control center in Galleo, which we use it for some extreme situations. And the last one is the adaptation hub in Galleo. This is a new project. It's a municipal hub who hosts many startup companies. It's a municipal hub, I say again, not a private, let's say, initiative. It's other operation, and this one, we're very proud for that. That's for me. Thank you very much. I'm finished. Thank you.
Thank you very much, Dimitris, for this detailed presentation. And every year I see an extension of your portfolio of applications, at least as far as I'm concerned. So I think this is a very good example to demonstrate how the municipal authorities take the advantages of novel technologies and really provide benefits and services to the citizens.
Yes,
thank you again for coming and giving us this update.
We have to give to our citizens very good services, very upgrading services, and I think this is the basic steps. I say again, we are not a smart city. We'll try to be one. This is the basic, let's say, sentence for that. But you cannot go to the step 10 if you cannot pass from the step 1, 2, 3, and so on. That's from my side. Thank you very much, Dr. Choliouros.
So, ladies and gentlemen, finally, this year as well, we are at the end of Infocom 2022. I would like to express my profound thanks to all speakers, first of all, for their continuous will to support. Some of the speakers participate on an annual basis during the last event. Some others came for the first time. We hope that we will have them, or most of them, next year as well. The aim of this workshop was to focus on several European-funded research projects intending to create opportunities for an innovative, competitive
5G-based or 5G and beyond-based market. We have made a separation in 9 sessions in order to cover as much as possible among the proposed, let's say, thematic areas or topics. Some of the sessions were dedicated to some projects, like the case of the 5G Induced project, the Smart 5 Grid project, the Data Ports project, the Marshall project. Some others were, let's say, in parallel with similar projects, similar under the term of the same context, or because they belonged in the same thematic area funded by the European Commission. I feel that we have presented a lot of information that will be useful for everyone. The material, as every year, will be uploaded. Of course, we get the consent by the speakers. I hope for once again we have passed the message that modern technology and 5G may be the tools, the essential means to transform our everyday life, create new jobs, provide opportunities to the economy for investments, for new activities, opportunities also to the society in order to improve our everyday life. And that's all by my side. But finally, I would like to express my thanks to the audience, those who are present, those who were present, and hopefully will hear this presentation by online streaming. And of course, my great thanks to the organizers and to the technical teams. They were here at any time, ready to provide solutions. I would like to ask you to have an applaudissement for the technical support as well. So that's all. We can conclude. For the speakers, we have the social event. I hope this will be an option just to discuss more freely. And thank you again for being with us. Hopefully, we will be able to organize next year a similar event. Thank you again.